Hello everyone, welcome to our AWS Developer Associate course. This course is designed to help you master the skills needed to become an AWS Developer Associate. AWS or Amazon Web Services is one of the most popular cloud platforms in the world, and there's a huge demand for skilled developers who know how to use it. Whether you are just starting out or looking to improve your skills, this course will guide you step by step. We'll cover everything from the basics of AWS to more advanced topics like deploying applications, managing services, and automating tasks in the cloud. You'll also learn how to build and maintain applications on AWS, ensuring they are secure, scalable, and efficient. Not only are these skills in high demand, but they also come with great earning potential. AWS Developer Associates can earn a competitive salary with many opportunities for growth in the tech industry. So let's dive in and start your journey to becoming an AWS Developer Associate.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
But before we begin, if you are interested in getting certified in cloud, check out Simplilearn's Cloud Architect Certification Program. Build expertise in AWS, Microsoft Azure, and GCP with our Cloud Architect Certification course. Plus, we have included an exam voucher for any one Azure course so you can get certified hassle-free. Learn how to design and deploy scalable services on various cloud platforms and in one comprehensive course. Let's build your cloud expertise together. Check out the course link in the description box and pinned comments. Imagine a large hospital where doctors and nurses need to access patient records every day. They look up medical histories, test results, and treatment plans to make sure they give the best care. One day, the hospital's old database system crashes, and suddenly nobody can get the information they need. Doctors can't see patient records during emergencies, and everything comes to a standstill. What can the hospital do to make sure this never happens again? This is where AWS databases come to the rescue. By using AWS powerful and reliable database services, the hospital can make sure the patient data is always available, safely stored, and easy to access. AWS offers a range of database solutions that keep the data secure and backed up, so doctors and nurses can always get the information they need, even in emergencies. So, in today's video, we'll explore about the storage services of AWS and the different types of databases available in AWS. We'll explain how each service works, their key features, and the best ways to use them. Whether you are a developer, a database administrator, or just curious about cloud technology, this video has something for you. So, what is AWS? Amazon Web Services or AWS is a comprehensive cloud computing platform provided by Amazon, offering a wide array of on-demand services such as compute power, storage, and databases, along with advanced functionalities like machine learning, analytics, and IoT. It helps businesses to scale their applications efficiently. It reduces the IT cost as it has pay-as-you-go model. Its global network of data centers ensures high availability and security. Now, what is a database and why is it important? So databases are systems that store, organize, and manage lots of data efficiently. They have tables to hold the data, queries to find specific information, and indexes to speed up searches. Databases also ensure that all operations are completed correctly and keep data secure. Now there are different types of databases. Relational databases use structured tables and SQL for queries, while NoSQL databases handle unstructured data and are easier to scale. Now, using databases in cloud has many benefits. Cloud databases can easily grow or shrink based on your needs. So you can handle busy times without paying for extra resources you don't need. They are also reliable because cloud providers manage backups and replicate data in different locations, which minimizes downtime and data loss. Additionally, cloud databases reduce costs because you don't have to buy and maintain your own hardware and software. They allow global access, so teams and applications around the world can quickly get the data they need. Now let's discuss the various storage services provided by AWS and identify which AWS databases use each type of storage. So AWS offers a variety of storage services tailored for different use cases. First, we have Amazon S3, or simple storage service, which is an object storage service that is highly scalable, durable, and secure, ideal for backups, big data analytics, and content storage. It's used by databases like Amazon RDS, Amazon DynamoDB, and Amazon Redshift for backups and data storage. Next, we have Amazon EBS or Elastic Block Store, which provides block storage for EC2 instances, offering different volume types for balancing cost and performance. Now, Amazon EBS is used by Amazon RDS and Amazon Aurora for database storage. Now, next we have Amazon EFS, which is Elastic File System. Now, it offers scalable file storage that can be concurrently accessed by multiple EC2 instances, suitable for applications needing shared access like web serving and content management. Next on the list is Amazon FSx, which provides fully managed file systems optimized for specific workloads, such as FSx for Windows File Server and FSx for Lustre, the latter being ideal for high-performance tasks like machine learning and big data processing. Now, for archival storage, Amazon S3 Glacier offers low-cost storage for infrequently accessed data, perfect for compliance and archival needs. Now, finally, we have the AWS Snow family, including Snowcone, Snowball, and Snowmobile, which facilitates secure and efficient data transfer into and out of AWS, supporting the initial data loading for various databases. So having known the services offered by AWS, now let's move on to the different databases in AWS and discuss each of them with their use cases. So first we have Amazon DynamoDB. Now, Amazon DynamoDB is a fully managed NoSQL database service offered by AWS. It is designed to handle large amounts of data with high speed and low latency, making it perfect for applications that need to store and retrieve data quickly. Some of its features are scalability. DynamoDB can automatically scale up or down based on the application's demand, ensuring consistent performance. It provides single-digit millisecond response times, which is ideal for real-time applications. AWS handles all the maintenance tasks like backups, patches, and hardware provisioning, so you don't have to worry about them. So let's see a use case. Imagine you are running a mobile game with thousands of players online simultaneously. Each player's game progress, scores, and in-game purchases need to be stored and retrieved quickly to ensure a smooth gaming experience. Now, DynamoDB can efficiently handle this type of workload by providing quick access to player data, even when there are sudden spikes in game activity. This ensures players have a seamless and enjoyable experience without delays or lag. Now, next we have Amazon Aurora. Amazon Aurora is a high-performance, fully managed relational database service offered by AWS. It's designed to be compatible with MySQL and PostgreSQL, which are popular database systems, but it's much faster and more reliable. Aurora automatically takes care of tasks like backups, software patching, and scaling, so you don't have to worry about them. Let's see its use case. Imagine you have an online store that handles thousands of transactions every day. You need a database that can quickly process orders, manage inventory, and store customer information without any slowdowns. Amazon Aurora is perfect for this because it can handle lots of read and write operations very efficiently, ensuring a smooth shopping experience for your customers. Plus, Aurora can automatically scale up to meet high demand during sales or holidays and scale down when traffic is lower, helping you save costs. Its high availability and automatic backup features mean your data is always safe and accessible, even in case of hardware failures. This makes Aurora an excellent choice for running a reliable and responsive e-commerce website. Next on the list, we have Amazon RDS. Now, Amazon RDS or Amazon Relational Database Service is a cloud-based service that makes it easy to set up, operate, and scale a relational database. This means you can store and manage your data in a structured way using popular database engines like MySQL, PostgreSQL, Oracle, SQL Server, and MariaDB without worrying about the underlying infrastructure. Now, imagine you run an online store. You need a database to keep track of your products, customers, orders, and inventory. Using Amazon RDS, you can quickly create a database that handles all these tasks. RDS automatically takes care of backups, software updates, and scaling, so you don't have to worry about your database crashing during a big sale or needing more space as your business grows. Now next, we have Amazon TimeStream. Now, Amazon TimeStream is a cloud-based time series database service offered by AWS, designed to efficiently store and analyze timestamp data. Now, timestamp data is information collected at regular intervals, like temperature readings every minute or stock prices every second. So the key features include performance. It handles trillions of events per day with fast query capabilities. Now, it automatically scales up or down based on the volume of data. Now you only pay for storage and queries you use, with automated data lifecycle management to reduce costs. Now imagine you have a network of thousands of IoT sensors deployed across a city to monitor air quality. Each sensor collects data like temperature, humidity, and pollution levels every few seconds. Now, Amazon TimeStream can efficiently store this vast amount of timestamp data and provide quick access for real-time monitoring and historical analysis. This helps in analyzing trends, predict pollution levels, and make data-driven decisions to improve air quality. Next on the list, we have Amazon Neptune. Now, Amazon Neptune is a fully managed graph database service provided by AWS. It's designed to work with highly connected data, making it ideal for applications where relationships between data points are as important as the data itself. Its key features include graph models. It supports popular graph models like Property Graph and RDF, which is Resource Description Framework, optimized for querying large amounts of interconnected data quickly. It handles database management tasks like backups, patching, and scaling automatically. Now, one common use case for Amazon Neptune is building social networking applications. So in a social network, users are connected to each other in various ways: friends, followers, likes, comments, and groups. Now, Neptune can efficiently manage these connections and quickly answer complex queries like who are the mutual friends of two users or what groups are my friends part of. So by using Neptune, social media platforms can provide a fast, responsive user experience even as the number of users and connections grow. So next we have Amazon QLDB. Now it stands for Amazon Quantum Ledger Database, which is a fully managed ledger database provided by AWS. It is designed to maintain a complete and unchangeable history of all changes made to your data over time. Think of it like a highly secure and transparent digital logbook where every entry is recorded and can't be altered. So the key features are immutable ledger. Once data is entered, it cannot be changed or deleted. It ensures the integrity of your data by allowing you to verify that it hasn't been tampered with. Now, AWS handles all the maintenance, including scalability, backups, and availability. So one common use case for QLDB is in tracking financial transactions. So imagine a bank needs to maintain an accurate and tamper-proof record of all the transactions to ensure transparency and compliance with regulations. So QLDB can provide a trustworthy and unchangeable log of every transaction, making it easy to audit and verify the history of financial activities. Now, the last on the list is Amazon RDS on VMware. So it is a service that allows you to run Amazon's Managed Relational Database Service or RDS in your own data centers using VMware. Now, VMware is a virtualization and cloud computing software provider. So this means you can enjoy the benefits of RDS like automated backups, patching, and scaling without moving your data to the AWS Cloud. So it's perfect for businesses that want to keep their data on premises due to regulatory requirements, low latency needs, or existing investments in VMware infrastructure. For example, imagine a hospital that needs to store and manage large amounts of sensitive patient data. So due to strict privacy regulations, this data must remain on-site itself. With Amazon RDS or VMware, the hospital can set up and manage databases easily within their own data centers. They get the reliability and automation of AWS RDS while keeping patient information secure and compliant with local laws. So this setup ensures the hospital's data is always backed up, secure, and accessible without the complexity of managing database servers manually.
So first is, why get AWS certification? So AWS certification is a recognized validation of your proficiency and understanding of AWS services. Acquiring AWS certification offers various advantages, including distinguishing yourself from other candidates in the highly competitive cloud computing industry. Then elevating your earning potential and career prospects, as AWS certified professionals are sought after and typically receive higher salaries than their non-certified counterparts. Then granting access to a supportive community comprised of AWS experts, mentors, and peers. This community provides a platform for networking, sharing the best practices, and mutual learning. Improving your practical skills and confidence in utilizing AWS services. The certification exams are crafted to access your hands-on experience and problem-solving capabilities, and establishing a pathway for continuous growth. Given that AWS offers a range of certification levels and domains from foundational to specialty, pursuing these certifications enables you to advance your knowledge and career in the field. So this was about why get AWS certification. Now let's move on to understand about the AWS certifications. So AWS currently provides a total of 13 certifications comprising of 7 core certifications and 5 specialty certificates. The core certifications are categorized into 4 levels: foundational, associate, professional, and specialty. The progression begins with the foundational level, followed by the opportunity to advance to associate and professional certifications. Now, under foundational certifications, there is AWS Certified Cloud Practitioner. Then under associate certifications, there is AWS Certified Solutions Architect, then AWS Certified Developer, AWS Certified SysOps Administrator, AWS Certified Data Engineer. These comes under associate level. Next is the professional certificate. Now under professional certificate, there is AWS Certified Solutions Architect, then AWS Certified DevOps Engineer. Then next is specialty certificate. Specialty AWS certifications that are more specialized focus on specific AWS services. These certifications include AWS Certified Machine Learning, AWS Certified Advanced Networking, AWS Certified Data Analytics, AWS Certified Security, AWS Certified Database, AWS Certified SAP on AWS. So these are the specialty certifications. Alright, so let's start with the foundational level certification. The AWS Certified Cloud Practitioner is designed for beginners without prior AWS experience, covering fundamental aspects like cloud services, architecture, pricing, and basic security. It requires no prior experience. This certification serves as a strong starting point, offering a solid foundation in AWS concepts. Exam domain include cloud concepts, security, compliance, technology, and billing and pricing. Exam format includes multiple choice questions. Duration is 90 minutes and cost is $100. And here is $100 US. Now coming to the associate level certification. So under associate level, there is AWS Certified Solution Architect. So let's start with this one. The AWS Certified Solution Architect is ideal for individuals pursuing roles such as Cloud Solutions Architect or Cloud Engineer, with a focus on architecturing secure and scalable AWS solutions. The certification covers core AWS services and best practices and requires at least 1 year of hands-on experience of AWS. Earning this in-demand certification unlocks various job opportunities, emphasizing the ability to design secure, high-performing, and cost-optimized architectures. So the exam format is multiple choice question again. The duration is 130 minutes and the cost is $150 US. So the next associate certification is AWS Certified Developer. So the AWS Certified Developer certification is designed for developers and software engineers engaged with AWS. Participants gain expertise in developing applications on AWS, integrating services, and optimizing application performance. With a prerequisite of at least 1 year of AWS experience, this certification is essential for mastering crucial skills in cloud development, making it valuable for those focused on building applications on the AWS platform. In this, the exam format is again MCQ, and the duration is 130 minutes and the cost is again $150 US. You can also give practice exam in $20 US. Now coming to the next associate certification, which is AWS Certified SysOps Administrator. So this certification is designed for system administrator, operations professionals, and individuals overseeing AWS systems, with a recommended minimum of 1 year of AWS experience. This certification validates expertise in key domains like monitoring, logging, and remediation, reliability, deployment, security, networking, and cost optimization, affirming proficiency in AWS operational tasks. So of this certification, exam format is like MCQ again. Duration is 130 minutes and again $150 US is the cost. Coming to the next one, which is AWS Certified Data Engineer. Alright. So the AWS Certified Data Engineer certification is designed for data engineers with AWS pipeline experience, data scientists seeking AWS data expertise, and professionals validating their data engineering skills, with a recommended of experience of 2 to 3 years in data engineering and 1 to 2 years in AWS data services, along with the familiarity in scripting and SQL. This certification offers industry-recognized validation, increased earning potential, and a competitive edge in the job market, ensuring a future-proof data engineering career. The certification consists areas such as data ingestion and transformation, data store management, data operations and support, as well as data security and governance. The exam format is again MCQ and the cost is $150 US. So this was about these associate level certifications. Now let's understand about the certifications that come under professional certificate. Alright. So professional level certifications, let's first start with AWS Certified Solution Architect. Yes, the AWS Certified Solution Architect is ideal for experienced solutions architect seeking advanced skills in multi-tier applications, high availability, disaster recovery, and addressing organizational complexity with a recommended of 2 years of AWS experience. This professional level certification demonstrates deep expertise in AWS architecture, covering solution design and continuous improvement and workload migration. For this certification, the format is MCQ and the duration is 180 minutes and the course is $300. Alright, if you want to give the practice exam, then it's $40 for this exam. Alright, so now let's move on to the next professional certificate, which is AWS Certified DevOps Engineer. So the AWS DevOps Engineer certification is designed for DevOps engineers, system administrators, and those emphasizing continuous delivery. With a focus on advanced practices, including automation, security, and optimization, it requires 2 years of AWS experience and is valuable for emphasizing DevOps culture and practices in an AWS environment. Topics include SDLC automation, configuration management, IAC, resilient cloud solutions, monitoring logging, incident and event response, and security compliance. The exam format is multiple choice questions, duration is 180 minutes, and the cost here is $300. So this was about the professional certificates. Now the specialty certifications. So the AWS offers a total of 6 specialty certifications. It is essential to possess a profound understanding of the selected domain. Since the examination difficulty level of these certifications is notably elevated, expert certifications are designed for domain expert. AWS specialty certifications focus on networking and data analytics, security, machine learning, or database management. Recommended for individuals with 2 to 5 years of hands-on experience in their chosen specialty. These certifications enable a deep dive into AWS domains, showcasing specialized expertise in the field. So these certifications are AWS Certified Machine Learning, AWS Certified Advanced Networking, AWS Certified Data Analytics, AWS Certified Security, AWS Certified Database, AWS Certified SAP on AWS. Alright, so these are the specialty level certifications. Now let's understand how to prepare for the exams. So AWS Skill Builder. First of all, we have this. Boost your skills with AWS Skill Builder for hands-on practice to get ready for certification exams. This is one of the best sources. Alright, now coming to the next one, which is AWS White Papers. So read AWS white papers to understand key concepts and reinforce your knowledge for exam preparation. After that, you can also go for online courses. Take online courses designed for AWS certification preparation, providing interactive learning for a thorough understanding. You can also have a look at Simplilearn's Cloud Architect Masters program, which will help you in the preparation. Alright, now talking about some tips. So the first tip is read question twice. Ensure clarity by reading questions twice to grasp the details and answer accurately during the AWS certification exam. Then next is build your practical knowledge. So strengthen your understanding through practical application, as hands-on experience is crucial for success in AWS certification. Also, don't spend too much time. Don't spend too much time on each question. Manage your time wisely. Avoid overthinking. If a question seems challenging, move on and return later if needed during the AWS certification exam. Alright, now go for AWS practice exams. Opt for practice exams to familiarize yourself with the exam format and access your readiness, helping boost your confidence for the actual certification test. So these are some tips that you can keep in mind. So as we conclude our AWS certification roadmap, we have covered the significance of AWS certifications and delve into the foundation, associate, professional, and specialty levels. Detailed information on each certification, including who should pursue them, has been provided. By understanding the why, what, and how of AWS certification, you are well prepared to navigate the certification landscape. Best wishes as you embark on this journey, armed with knowledge to achieve success in your AWS certification pursuits.
Alright, let's now talk about how easy it is to deploy an web application in the cloud. So the scenario here is that our users like a product and we need to have a mechanism to receive input from them about their likes and dislikes and give them the appropriate product as per their need. Alright, though the setup and the environment, it sort of looks complicated, we don't have to worry because AWS has tools and technologies which can help us to achieve it. Now we're going to use services like Route 53, services like CloudWatch, EC2, S3, and a lot more, and all these put together are going to give an application that's fully functionable and an application that's going to receive the information like using the services like Route 53, CloudWatch, EC2, and S3. We're going to create an application and that's going to meet our need. So back to our original requirement, all I want is to deploy a web application for a product that keeps our users updated about the happenings and the new comings in the market. And to fulfill this requirement, here is all the services we would need. EC2 here is used for provisioning the computational power needed for this application. And EC2 has a vast variety of family and types that we can pick from for the types of workloads and also for the intents of the workloads. We're also going to use S3 for storage, and S3 provides any additional storage requirement for the resources or any additional storage requirement for the web applications. And we're also going to use CloudWatch for monitoring the environment, and CloudWatch monitors the application and the environment, and it provides trigger for scaling in and scaling out the infrastructure. And we're also going to use Route 53 for DNS, and Route 53 helps us to register the domain name for our web application. And with all the tools and technologies together, all of them put together, we're going to make an application, a perfect application that caters our need. Alright, so I'm going to use Elastic Beanstalk for this project, and the name of the application is going to be, as you see, GSG Signup, and the environment name is GSG Signup Environment 1. Let me also pick a name. Right, let me see if this name is available. Yes, that's available. That's the domain name. So let me pick that, and the application that I have is going to run on Node.js. So let me pick that platform and launch. Now, as you see, Elastic Beanstalk, this is going to launch an instance. It's going to launch the monitoring setup or the monitoring environment. It's going to create a load balancer as well, and it's going to take care of all the security features needed for this application. Alright, look at that. I was able to go to that URL, which is what we gave, and it's now having an default page shown up, meaning all the dependencies for the software is installed and it's just waiting for me to upload the code, or in specific the page required. So let's do that. Let me upload the code. I already have the code saved here. That's my code, and that's going to take some time. Alright, it has done its thing. And now if I go to the same URL, look at that, I'm being thrown an advertisement page. Alright, so if I sign up with my name, email, and stuff like that, it's going to receive the information and it's going to send an email to the owner saying that somebody had subscribed to your service. That's the default feature of this app. Look at that. Email to the owner saying that somebody had subscribed to your app and this is their email address, stuff like that. Not only that, it's also going to create an entry in the database. And DynamoDB is the service that this application uses to store data. There's my DynamoDB. And if I go to tables, right, and go to items, I'm going to see that a user with name Samuel and email address so and so has said okay or has shown interest in the preview of my site or product. So this is where, or this is how I collect those information, right? And some more things about the infrastructure itself is it is running behind an load balancer. Look at that. It had created a load balancer. It had also created an auto scaling group. Now that's the feature of Elastic Load Balancer that we have chosen. It has created an auto scaling group. And now let's put this URL. You see this? It's not a fancy URL, right? It's an Amazon given URL, a dynamic URL. So let's put this URL behind our DNS. Let's do that. So go to services, go to Route 53, go to hosted zone, and there we can find the DNS name, right? So that's a DNS name, all right? All right, let's create an entry and map that URL to our load balancer, right? And create. Now, technically, if I go to this URL, it should take me to that application. All right, look at that. I went to my custom URL and now that's pointed to my application. Previously, my application was having a random URL and now it's having a custom URL.
Hey tech enthusiasts, welcome to yet another informative video from Simplilearn. Imagine you're managing an online store. You need to handle day-to-day transactions, analyze sales trends over the past year, and store massive amounts of raw customer feedback from social media. How do you manage all this data efficiently? This is where databases, data warehouses, and data lakes come into play. I'm pretty sure most of you are well aware of what a database is. A database is a system that stores and organizes data in a structured way, using rows and columns, making it easy to access, manage, and update information. Now, if data can be stored and managed in databases, then what is a data warehouse and a data lake, and why do we need them? So in this video, I will give you a clear understanding of what a database, data warehouse, and data lake is with examples. How are they different from each other, and what factors to consider before choosing amongst the three. So let's jump in. So what is a database? A database is essentially a structured collection of data or information that is stored electronically. It serves as a centralized repository where data is organized in a systematic way, often using tables, rows, and columns. So the primary function of a database is to support online transaction processing or OLTP, which means it handles the real-time transactions and operations of businesses or applications. So behind the scenes, a database management system or DBMS manages the database, ensuring data is stored securely and efficiently. So the DBMS also allows users and applications to interact with the data through queries, updates, and modifications. So in common usage, the term database can refer both to the actual data repository and the software system or DBMS that manages it, providing a seamless interface between users and their stored information. Now, there are two types of databases. Relational databases store data in structured tables with fixed rows and columns. This structured approach makes them ideal for applications requiring strong data consistency and complex querying capabilities. On the other hand, non-relational databases, often referred to as NoSQL databases, offer more flexibility by accommodating various data models. So these include JSON for semi-structured data, BSON, key value pairs for simple data retrieval, tables with dynamic columns for evolving schemas, and graph databases using nodes and edges for connected data relationships. So some of the examples of databases are Oracle, MySQL, and PostgreSQL, and also MongoDB. Now, what is a data warehouse? So a data warehouse functions as a specialized database designed to store structured information gathered from multiple sources, so encompassing both current and historical data. So unlike traditional databases primarily focused on transaction processing, data warehouses are tailored for analytical purposes. So they consolidate data from different systems to facilitate comprehensive analysis, uncover insights, and generate business intelligence through reports and dashboards. So in essence, while a data warehouse is indeed a type of database, it distinguishes itself by its optimized architecture for handling complex queries and facilitating data analytics essential for strategic decision-making in organizations. So a data warehouse serves as a centralized repository designed to store large volumes of both current and historical data gathered from diverse sources. This data ranges from raw, initially ingested information to highly refined, cleansed, filtered, and aggregated data sets. The process of moving data into a data warehouse is managed through extract, transform, load or ETL process, which extract data from its original sources, transform it to fit the warehouse schema, and load it into the warehouse on a regular basis, such as hourly or daily schedules. So this periodic loading means that the data warehouse may not always reflect the most current state of the original systems. So once the data is successfully loaded into the warehouse, business analysts and data scientists can utilize business intelligence tools to connect to the data warehouse. So these tools enable them to explore the data, uncover valuable insights, and generate reports that aid business stakeholders in making informed decisions based on comprehensive data analysis. So examples of data warehouse is Amazon Redshift, Google BigQuery, and IBM DB2 Warehouse. Now, what is a data lake? So a data lake serves as a centralized storage repository for data collected from various sources, preserving it in its original or raw format. So unlike data warehouses that also handle extensive volumes of both current and historical data, data lakes distinguish themselves by their versatility in storing diverse data formats such as JSON, BSIN, CSV, etc. So the core objective of a data lake typically revolves around analyzing this data to extract valuable insights. So however, some organizations use data lakes mainly because they offer affordable storage options, storing data in anticipation of future analysis. So data lakes are versatile storage systems that can handle large amounts of structured, semi-structured, and unstructured data. So unlike traditional databases or data warehouses, data lakes don't need data to be organized before storing it, allowing quick accumulation of diverse data types like spreadsheets, JSON files, PDFs, and multimedia. So different users access data differently. Structured data is often used directly by business analysts for insights, while unstructured data requires expertise from developers, data scientists, or data engineers. This set of flexibility lets analysts and scientists discover unexpected patterns and insights, using the data's variety and volume to solve problems that weren't anticipated initially. So data and data lakes can be processed with online analytical processing or OLAP systems and visualized using business intelligence tools, improving data exploration and decision-making capabilities. Some of the examples of data lake are AWS S3, Azure Data Lake Storage Gen 2, Google Cloud Storage, etc. So now let's recap the differences among the three of them. So if your application needs to store data, which is essential for most interactive apps, having a database is crucial. So databases are fundamental for applications in various industries and scenarios. They provide an organized way to store, retrieve, and manage data effectively. For instance, an online store uses a database to handle product stocks and customer orders. Similarly, a healthcare system relies on databases to manage patient information and medical histories. Even social media apps use databases to store user profiles and posts. So without databases, it would be difficult to manage and access data reliably, impacting the functionality and usability of interactive applications. Now, data warehouses are essential when organizations need to store large amounts of historical data and analyze it deeply to gain business insights. Their organized structure makes data analysis straightforward, accessible to business analysts, and beneficial for data scientists. So unlike transactional databases used daily for operations, data warehouses specialize in handling complex queries and generating detailed reports. So this capability supports strategic decision-making based on past trends and patterns. It's important to know that while data warehouses excel in analytics, they aren't suitable for real-time transaction processing or handling multiple users at once. So organizations typically maintain separate databases for day-to-day operations and use the data warehouse specifically for strategic analytics and business intelligence. Now, data lakes are a budget-friendly way to store large amounts of data in its original form. So unlike regular databases or data warehouses that need data to be organized beforehand, data lakes allow storing various data types like structured, semi-structured, and unstructured without immediate restructuring. So this keeps data raw, letting business fully explore and analyze both current and past information, uncovering insights that may not be obvious initially. So data lakes are great for advanced analytics such as machine learning and predicting trends, offering flexibility for experimenting with data. However, they aren't suitable for handling day-to-day transactions or meeting the fast data access needs of operational tasks, which traditional databases and data warehouses specialize in. So I hope now you all know how the three of them differ. Now, having known that, there are some factors to be considered before deciding on which platform to use. So let's look into those. Considerations like the variety and volume of data sources, the way data arrives, and how predictable its structure is are crucial. So data lakes are versatile, handling unstructured data in various formats. On the other hand, data warehouses specialize in structured data from multiple sources. Now, databases perform well with structured data from one source, but may struggle with scalability. Now, the choice between these platforms depends on these factors, shaping their roles in data management and analytics. Now, in a solid data management strategy, choosing when and how to use data models is crucial. In a solid data management strategy, choosing when and how to use data models is crucial. Data lakes offer flexibility by storing raw data alongside metadata, allowing schemas to be applied later during data extraction for analysis. On the other hand, databases and data warehouses use ETL, extract, transform, load processes. Here, raw data is transformed into a predefined structure upon ingestion, called schema on write. This difference shows how data lakes enable agility in exploring data and adjusting schemas as needed, contrasting with databases and data warehouses that prioritize upfront data organization and consistency through fixed schemas. Now, big data is highly valuable for businesses, evident in their investments in data management. As data grows in volume and speed, storage expenses increase. Data lakes are cost-effective because they store data as is, reducing storage needs compared to data warehouses that require extensive processing before analysis. Databases can scale storage capacity to match demand. Now, the choice between a data warehouse, data lake, or relational database depends on users' role, whether they are a business analyst, data scientist, or a part of operations, and their specific organizational needs. So operations teams focused on business insights often prefer data warehouses for structured data analytics, despite higher setup and storage costs. Data scientists prefer data lakes for their flexibility with structured and unstructured data, which supports advanced AI and machine learning. Business analysts skilled in SQL may find relational databases adequate for generating specific trend reports on business segments. So each option serves different needs based on data complexity, analytics requirements, and cost considerations. Now, organizations have different preferences between open source and proprietary software, along with the communities backing them. So data lakes are popular because many use platforms like Hadoop, and there's a growing amount of unstructured data from various company systems and real-time data streams. Another important point is how easy and affordable it is to update systems and when data sources and structures change. Unlike relational databases and data warehouses, which can be expensive to update, data lakes make it simple to adjust, making them flexible for changing data needs.
As cloud adoption continues to increase, with IDC predicting that global cloud spending will reach 1.3 trillion by 2025, there's never been a better time to certify your skills. This AWS Cloud Practitioner certification is for anyone who wants to understand Amazon Web Services cloud better, no matter their technical background. Plus, AWS certified professionals earn an average of $183,000 per year, highlighting the significant financial benefits of becoming certified. So what are you waiting for? In this video, we will cover everything about AWS Cloud Practitioner certification, career goals and objectives, market demands, cost investment, and advantages of the certification. Alright, so let's understand about AWS Cloud Practitioner certification. Alright, so now let's talk about AWS Certified Cloud Practitioner exam. So the AWS Certified Cloud Practitioner exam is an entry-level certification designed for individuals who are new to cloud computing and want to build a foundational understanding of AWS services. This certification is particularly beneficial for those without an IT background, making it accessible to a wide range of people looking to start a career in the cloud. This certification is ideal for business professionals, including sales, product management, and project management roles. It helps them gain a basic understanding of cloud concepts, which enhances their ability to communicate effectively with the technical teams and customers. By understanding the core AWS services, pricing, and support models, these individuals can make decisions and contribute more to their organizations. One of the advantages of AWS Certified Cloud Practitioner exam is the flexibility it offers in testing options. Like candidates can choose to take the exam in person at VIEW or like testing centers or online with a proctor, making it convenient to fit for various schedules. Alright, now talking about the key details of the exam. So first, that is a level of the exam is foundational. Then talking about the duration, the exam lasts 90 minutes, giving candidates ample time to answer all the questions thoroughly. The format of exam. So it consists of 65 questions which can either be multiple choice or multiple response. This format is designed to test your understanding of AWS services and cloud concepts in a comprehensive manner. Talking about the cost. The exam cost is $100. It's worth noting that additional cost may apply depending on your location and the prevailing exchange rates. Then testing options. So as we already discussed, you can take the exam in person at a person view testing center or online through a proctored exam, offering flexibility to fit your schedule and preferences. So this was about the AWS Practitioner certification. Now let's have a look at one of its important factors, which is career goals and objectives. So the AWS Certified Cloud Practitioner certification helps you start with a career in cloud computing by giving you a foundation knowledge of AWS services. So this certification is great for entry-level jobs as it shows employers you understand basic cloud concepts. However, the certification alone isn't enough to secure a job. To maximize your chances, it's important to create cloud projects alongside your studies. Working on cloud projects helps you apply that you have learned and gives you practical experience, making you more attractive to employers. It's also beneficial to stay updated in the new AWS services and continue learning. Building a portfolio of projects can show potential employers that you have hands-on experience, which is a highly valued in the job market. Also, for individuals in sales, product management, project management, or other technical roles, the AWS Cloud Practitioner certification can help them better understand how cloud computing works and how AWS services can be used to benefit their business. This can improve communication and collaboration with the technical teams and customers. Now let's move on and have a look at salary and companies hiring for AWS professionals. So the average salary of an AWS professional in the United States is $133,000 per year. This high-paying job role is in demand across many companies. Notable employers looking for AWS professionals include TCS, Accenture, Mindtree, IBM, Capgemini, and Deloitte, and many more like that. These companies value AWS skills due to the growing need for cloud computing expertise. AWS professionals help business leverage cloud technology for better scalability, efficiency, and the cost-saving purposes. With such a increasing or lucrative salary and demand from leading companies, pursuing a career in AWS professional can be a smart and rewarding choice for you. Alright, now let's talk about the market demands. So don't worry about new AI technologies stealing your future about cloud job. You don't have to worry. The demand for AWS skills in the job market is growing rapidly, with many companies transitioning to cloud computing. The cloud computing market is experiencing explosive growth according to Gartner in 2024. Worldwide end user spending on public cloud services is forecast to total $679 billion. Businesses of all sizes are migrating to the cloud to benefit from its scalability, cost efficiency, and agility. This rapidly adoption has created a significant skill gap. A recent report by Global Knowledge estimates a shortage of over 3 million cloud computing professionals globally. By acquiring AWS skills, you are not just securing a job in today's market, but you are positioning yourself for a successful career in the ever-growing field of cloud computing. Coming to the next one, which is cost investment. So the AWS Certified Cloud Practitioner exam costs $100. This is a straightforward fee for registration and taking the exam. Additionally, while the AWS offer free digital training courses, you might also consider investing in supplementary study materials such as books, online courses, and practice exams. Now, let's discuss the advantages of Cloud Practitioner certification. One of the coolest perks of getting the AWS Practitioner certification is the digital badge you receive. It's like a digital trophy that you can proudly display on your social media profiles and email signatures. This badge not only shows off your achievement, but also grants you immediate access to exclusive AWS-sponsored certification events, which can be a great way to network and learn more. Another fantastic benefit of this exam: once you're certified, you get a 50% discount voucher that you can use for recertification or even for taking another AWS certification exam. This means you can keep your skills up to date without breaking the bank. Yes. Alright, the next is, when it comes to recognition, AWS really goes the extra mile. As a certified professional, you will get the invites to special regional appreciation receptions. Plus, when you attend a major events like AWS reInvent or select AWS Summit events, you can use your digital badge to gain exclusive access to the AWS certification launches. These launches are perfect for networking, relaxing, and meeting other AWS professionals. Lastly, you'll also become a part of AWS Certified Global Community. This community, accessible via Intuitive, allows you to connect with other AWS certified individuals from around the world. It is an excellent platform for networking, sharing knowledge, and staying in the loop with latest in AWS. So this AWS Cloud Practitioner certification opens doors to the world of opportunity in the booming cloud computing market. With its industry recognition and focus on foundation knowledge, this certification is a valuable investment for both aspiring IT professionals and business-minded individuals.
What is cloud computing and what is AWS? What is cloud computing and what is AWS? So basically what is cloud computing is, I'll give you one example because in my teaching, I generally use real life examples, some analogies to help you understand these things. On-demand delivery of computer resources, especially data storage and computing. Okay. So basically before cloud computing, what was the scenario? Is that IT companies used to, do all the things for their IT business. For example, there is one client, Raj. He is a photographer and he is very famous photographer. So he is the client. He would like to create a website and make it website available for the world so that people can see the photos taken by him. So he approached an IT company and he said that, you know, you help me to create a website, and whatever it takes, you do everything, I'll pay for you. So this IT company is like, okay, there are two things I have to do. Number one, I have to focus on making the website. So this is can be done by using software developers. They can assign that task to software developers. They can design the website for Mr. Raj. Second thing, I need infrastructure so that I can launch website. So this IT company is thinking about they need infrastructure to launch the website. So this is done because this just requires a software developer who can use some programming scripting language, can design a website, nice website for Mr. Raj. However, what about infrastructure? Websites are softwares. Your applications are softwares. But to run the softwares, you require hardware. And a software like website or any web application, obviously it would require a continuous provision of hardwares. So to get the solution of this, IT companies used to create or set up own data center. So have you ever heard of this word data center? What is data center? So I have a couple of images that I can show you from Google. We have nothing to do with any image, but yeah. What you see on the screen are the photos of data center. So basically data centers are physical locations, maybe a warehouse, a building, a very huge space wherein hardware servers are placed. You can see any image. For example, this guy who is noting down something, I believe, the right side. What you see on his right is different hardware servers are placed in the racks. Do you understand rack? Rack, metallic rack, wherein few things can be set up. Or you can see this white, image on the left, or this one. You can see these are all physical hardwares which are set up in the form of a complete network. They are being connected through wires, cables. You can see here. This image you can see. This is one view of hardware servers connected through cables, right? So these are all hardware servers. You can see 1, 2, 3, 4, 5, 6, 7, and cables, wires. In fact, they are all placed in a rack, and there are many racks inside a data center. These are the actual photos. It doesn't matter this photo belongs to which company or anything. That is not our concern. But yeah, these are actual photographs of the actual data center. So inside one single data center, they have created or they have set up hardware server. Why hardware server? These hardware servers are the actual machines on which our website will be launched. So in the world, whenever you see any application running on internet, it must be running on some server. Let us discuss this core thing. So for an IT company who got a business from Mr. Raj, they also need a data center wherein they have to purchase hardware setup. They have to, invest into getting that huge space. They have to invest into, initial investment of purchasing networking devices, switches, routers, cables, wires, internet provision 24 by 7, electricity provision, electricity backup, because these servers has to be running 24/7 in order to keep the website on. So that after that, it requires air conditioning also to keep the temperature down so that the server's temperature can be maintained and controlled. So they should not have good high temperature because the heat may destroy your electronics component. So these are small things are there. Even physical security is required. There you require people to maintain all these data center. So this is a huge investment in terms of time, in terms of cost, in terms of number of employees, in terms of number of resources, uh, all those things. And this is all the IT company has to do. So not every IT company could accommodate this. And even if they accommodate this, then if tomorrow many customer comes, they need to add more data center or they need to scale their data centers accordingly. They need to add more servers. And doing this is not every time very feasible. Even the performance and efficiency of these things are not very good in terms of performance and efficiency. Security is again a concern. I'm talking about application security on running on these data center or even the physical security of the data center. All these are the challenges for any IT company to handle. However, in the era of 2005, companies like Amazon, they provided cloud computing business to the world the very first time. Complete data center part, this complete data center part, this will be handled by us. You don't need to maintain your own data center. You don't need to maintain any physical security. You don't need to invest into huge capitals. You don't need to pay for working expenditure. Nothing. This is all being done by us. So can I say that this is like third party kind of business wherein the IT company will trust AWS, they will create account into AWS and they will use the complete cloud computing setup of AWS. So what AWS has done, AWS has created such data center all over the world. So they have data centers all over the world. And on that data center, they have provided services. So services are nothing but the applications made by AWS so that you can do certain tasks. For example, number one, very basic. I want to launch a website. What is required for that? For that, we require virtual machine or virtual server. Am I right? To launch an application, you require virtual servers. So AWS has one service called EC2. So what you can do, you can go to AWS, use the service EC2, which will be running on the data centers. And then EC2 will give you virtual machine and you can launch your website. Suppose second requirement is I want to store files. Obviously, this is a website of Mr. Rajendra, who is a photographer. So website is enough, but more than website, files storage is also important because somewhere his photographs should be stored. So for that purpose, what he required? He required a storage device. To store the file, he needs storage device. For that purpose, he can go to store the photos and all. There is a service called S3, which is a storage service. So we can visit, or this IT company can visit AWS service S3 and can provide a space of storage so that files can be stored. Are you understanding? So for my website, let's say we require a database also. So then what we can do? We can go to AWS services. For example, you can visit a service called RDS, which is called Relational Database Service. Now, this is a service you can use to create a database server for you. So your database problem is solved. Then you say that, sir, I want some monitoring service so that I can monitor my resources, my applications. So to help you monitor the services, resources, there's a service called CloudWatch. You can use that service to get it. So why I'm giving you these examples? Because you would understand that for an IT company now, the job is very easy. In creating any IT architecture, multiple types of things are required. You require web servers, you require storage devices, database devices, you require virtual functions, you require monitoring tools, you require security tools, you require networking tools. And for all these requirements, AWS has created services. There are more than 350 services AWS has for different solutions, for different use cases. For example, if you go to your account, this one, I can show you the list of services here. On the left side, you have categories of services. On the right side, you have list of services. So suppose I click on first category, analytics. Now this is the category which is required to do analysis of data, which is basically majorly used by data scientists. You know, the data analyst people or data science related people who work in the company to analyze the data. For that purpose, analytics tools are required. So we have Athena, Clean Rooms, Cloud Search, Data Exchange, Firehose, Pipeline, Data Zone, EMR, which is actually used for Hadoop. EMR is actually a Hadoop framework by AWS. Big data Hadoop you must have heard of, right? Data Lake, so you have lake formation, Apache Flink, OpenSearch, Redshift, MSK. These are all related to analytics. You said that, sir, our application is using blockchain technology. We require a service which can help us to create, access, and manage blockchain network. Then we have one service. For business applications, you have different service. Then for financial management, you have different services. For compute is for running your application. So you have app runner, build and run production web application at scale. You have batch, you have EC2, you have EC2 image builder, Elastic Beanstalk, Lambda is a compute service. Then you have containers. So you must have heard this fancy word containers, Docker container, all these things, right? In IT sector, you must have heard of this in development. So we have two container services, Elastic Container Service and Elastic Kubernetes Service. Then we have databases, for example, DocumentDB, DynamoDB, Elasticache, Keyspaces, Neptune, QLDB, RDS, MemoriDB, TimeStream, or for example, front-end applications and mobile application. You have different services, Amplify, AppSync, Device Farm. The Device Farm, the name is very funny. So this is basically to test Android, iOS, and web apps on real devices in the cloud. This is for testers, right? AppSync is for real-time data sync using GraphQL for mobile and web apps. Then you have Amplify is a complete platform, frameworks and tools and app services for developing, building, testing and running mobile and web apps. So suppose you are a mobile or web app developer, you can simply go to Amplify service and try utilizing it for making your applications. Simple. Then if you are interested into gaming, AWS has gaming application service also called GameLift. So this is basically, if you have any idea or if you have any plan of creating multiplayer games, then you can deploy those applications using GameLift service. This actually help us to deploy and scale session-based multiplayer games. It's very big industry. I think, how many of you still play the games every day? You guys play the games on laptop? Okay. So we play the games. There's nothing wrong. And even multiple players can be part of the same game. So the infrastructure which is required to deploy such applications, they must be scalable. They must be supporting sessions and all these things. So Game Lift is a service that's very interesting. In future, if you work on gaming applications, so you will be finding this service very useful. Then IoT, very famous. We have IoT, Internet of Things services also, IoT Analytics, IoT Core, IoT Device Defender, IoT Device Management, Events, Fleetwise, Greengrass, Sitewise, TwinMaker. Then you have machine learning. So machine learning, artificial intelligence are the latest technologies, generative AI. All these are very, very latest technologies available in the market. So if customers applications are AI enabled or ML based application, then we have good set of services which can help you to implement those AML applications onto your cloud environment. You have management and governance, media services, migration services, networking services, quantum technologies, robotics, satellites, security, identity, and compliance. So these are all security and identity and compliance related services. Then you have finally storage services, storage for storing the files, so EFS, FSX, S3, all storage services are there. So the idea is services and below services data centers. Simple. Everything is managed by AWS, and that is called as cloud environment. Basically, it is a third-party cloud, right? So it may happen that there are different models of cloud computing, I can say. Suppose the same example of Raj and the IT company who got the business from Mr. Raj. So there can be three possibilities that they can do this. Number one possibility is that IT company will self-manage the data center. They will manage their own data centers, virtualization technology. These are all managed and maintained by the company. If it is done by IT company itself, then it is called as private cloud model. Second, if they don't have any plan to create their data centers, but they would like to use third party such as AWS or even second is Microsoft Azure or Google Cloud, whatever. But they would like to use third party cloud. So third party means they are not creating data center or managing data center and virtualization technologies. Basically, they want to rely on different companies who will work for them. So that is third party cloud. So there are major market players in this game. One is AWS, which is the major market shareholder, followed by Microsoft Azure, and then followed by Google Cloud. This is called as public cloud model. So what we are learning, public cloud by AWS. So any customer can go to public cloud because their whole infrastructure depends on third party data center and their services. So IT company will not maintain anything from their side. And the third is called as hybrid. So in hybrid, it is a combination of public and private cloud. The third one. So hybrid cloud model may have certain percentage of workload on personal data center. So I can say data center by IT company and data center by third party cloud such as AWS. So certain percentage of workload is on own data center and certain percentage of workload on AWS data center. So this combined model is called as hybrid cloud. Hybrid cloud is adopted by companies where their compliance and governments do not allow them to have 100% cloud. I give you simple example. Initially, banking sector, when cloud computing started, banking sector entered into cloud very late. Do you know that? Because banking sector had a lot of compliances and governance, wherein as per their compliances, they have certain restriction that they can't deploy everything on cloud model. So certain resources, for example, let's say the virtual machines are running on their own data center. Maybe storage is running on AWS. So they are using storage service of AWS, but virtual machines are maintained by themselves, their own VMs they are using for launching the website. But storage device they are using from AWS side. So this is kind of hybrid cloud. So wherever companies have compliances issues, which do not allow them to deploy 100% workload on AWS, then that they go with the hybrid cloud also. So these are the three possibilities: private cloud, public cloud, and hybrid cloud. So as I explained you, um, different services of AWS like this, different services are there. But these services are running over different set of data center in the world. What are the locations available? I can show you on the right side. This right side list is a list of regions of AWS. And I can show you these regions starting from US East, Northern Virginia, US East, Ohio, West, Northern California, US West, Oregon, Asia Pacific, Mumbai, Asia Pacific, Osaka, Seoul, Singapore, Sydney, Tokyo, Canada Central, Europe, Frankfurt, Ireland, London, Paris, Stockholm, South America, different Africa, Asia Pacific. You could see that a lot of regions are there, and they are actually covering up a lot of countries. Do you want to see the real view of those regions? So what I can do is, first of all, I would like to show you an image of AWS data center. How a single AWS data center looks like. And for that purpose, I can, yeah, show you one YouTube video, which is an official AWS videos, I believe. Let us see that first. There's a documentary, I think. Let me try switching my internet to some other network. Yeah, I hope this is visible to you. Different companies are the customers you can see on the screen. There was one official video also, which I will show you after this, which actually gives you a very good idea. How does These are the actual footages of their data centers being managed by different employees. They have provisions for crisis management also. You can read the scripts also. Cameras for physical surveillance. A data center is a very important part because attackers or visitors, they may, there could be intrusion detection at the very moment. And yeah, so I think you're getting fair idea how does it looks like. I wanted to give you a visual appearance of the data centers of AWS. These are basically buildings, warehouses where AWS is having a setup of these hardware servers. And there are many hardware servers inside single building. So this is one data center building you could see. Now I would like to show you some interesting things. This is actually a graphical image of a data center. And yeah, So then the question is how many such buildings they have maintained in the world. So the number is not known to anyone, but they have many buildings, many data centers in the world. And the areas, the regions where these data centers are set up are shown on this particular uh, image. You can see this is the world map starting from uh, United States. So one is like Northern Virginia, which is the first region. Then you have Government Cloud, Ohio, Mexico, Government Cloud again, Oregon, Canada West. You have Cape Town. In the Middle East, Kingdom of Saudi Arabia. Then this is Bahrain, I believe, UAE, Tel Aviv. You have Spain in Europe, Paris, Ireland, London, Europe, Stockholm, Milan. In Asia, you have Mumbai and Hyderabad. This second is Hyderabad. In China, you have Ningxia, Hong Kong, Beijing. You have Thailand, Singapore, Malaysia. Australia, we have two, Melbourne and Sydney. We have Auckland in New Zealand, and then we have Tokyo and Osaka in Japan, Seoul in China, and you could see that. So total 33 geographic regions are available, and they are colored in two colors, green and red. Green colors are the one which are existing regions. Regions represent AWS presence in that country. So for example, in Australia, Sydney is the region. So inside Sydney region, there will be many data centers. It's not indicating one data center. There will be multiple data centers in that Sydney region. And those data centers together are representing the AWS presence in that country with the name Sydney. So probably somewhere nearby Sydney city, there will be a lot of data center placed. And as such, there are 33 regions. So AWS is spreading their business all over the world. They are approaching new countries because their customers are increasing. That's what they're doing the business for. And as the customers are increasing, as there is a demand from customer from a particular section of a country or a world, then they start creating their own data centers in that place so that they can provide the services very fast. However, you could see that red colors are indicating coming soon, which are the future plans. They are in progress right now. Probably once they announce that Mexico is coming soon, so within a year they will be making it available for usage. So you can see the list also, different regions available as per the different region. So this is one of the very important aspect of AWS physical infrastructure, or you can say that global infrastructure. The bigger entity in this global infrastructure is called as region. And I take example of Sydney. I can draw one circle. Let us assume that this is a Sydney region. Now inside Sydney regions, there will be multiple buildings which are nothing but data center. So here I have drawn 4 data centers. But here I am drawing some another group of data center. And you could see that I'm purposely placing this data center in another groups. So what I'm doing is I'm creating groups of data center in my diagram. Why? Because this is the way data centers are placed inside a region. Inside Sydney region, there will be groups of data center, right? And those groups of data centers are called as availability zones. So now these 3 green colors are actually called as availability zone. So this is availability zone A, this is availability zone B, and this is availability zone C. So you might be wondering that why there is a requirement of grouping of data center inside region. Why can't we have a single group of all the data center and we call it as region? Why not? So there is a very, very big thought behind it. This big thought is related to availability of your resources, and this is called as high availability. Now, what is this concern? I'll tell you. First of all, what AWS does is they make groups of data center which are far from each other. So if you try to see the distance around 60 miles or 100 kilometers, you can say roughly, they try to maintain this much space between each group. So suppose there are three groups inside Sydney, there are three availability zones. So between each availability, between two availability zones, there will be a gap of 60 miles or 100 kilometers, 100. Why there is such big distance between them? Because AWS is purposely doing this in their infrastructure. AWS has set up this infrastructure purposely because they would like to maintain one important thing which is called as high availability. Now, this is something is very important to know for everyone sitting here. High availability. All right. Let's say so Claudia is doing good business online, and Claudia has made a very nice website, and the website is running on AWS Cloud. Okay. So obviously some virtual machines, we want for that website. Suppose we have created one virtual machine of using EC2 service. So this red color is my virtual server on which Claudia's website is running. Okay. So while creating virtual server, you have to choose availability zone. So I have chosen availability zone A. In that, my website, this EC2 machine is created. So when this machine is created, actually, you can see how many data centers are there. There are 4 data centers inside AC. So this machine will be running on each data center. This is called as redundancy. Redundancy means rather than running the machine on one data center, they run it on multiple data center within the availability zone. So for Claudia, how many resources are there? Can you tell me from user side? Our user is Claudia. So from Claudia's perspective, how many resources are there? How many machines Claudia has made? So for Claudia, it is only one machine that is being run. Okay. And Claudia will be paying for only one machine. But actually, inside availability zone, I have drawn 4 data center, but exactly we don't know how many data centers are there inside availability zone. There are multiple. There can be 2, there can be 4, there can be 10. We don't know. So the machine is running in all data centers, so that if one data center is not responding, in case there is some problem in one building, one data center is not at all responding, then another data centers are having the same machine running. So this will act as a spare machine. But if the problem is bigger, imagine there is an internet outage in the same area. So we know that within one availability zone, all the data centers are nearby each other. It's a group. So if there is an internet outage will be there for all 4 data center. If there is a very big issue of electricity, there is a issue of natural calamities. If I'm talking about, let's say, flood, earthquake, anything wrong happens, right? So if the problems are there in that particular area, then it will be impacting all the data center in that availability zone. So I'm thinking of, imagine in Sydney, there is one area. Okay. See, this happens because we need to focus on the explanation. I am repeating it. In Sydney, we are focusing on availability zone A, where Claudia's machine is running. We are just focusing on availability zone A. where Claudia's machine is running. All right. So what I'm saying is, if there is some bigger problem in that area where your ability zone is there, suppose there is a big issue of electricity, so it will be impacting all the 4 data center. So we are thinking about failure situation. We are thinking about, some disaster. Suppose there is some internet outage in that particular area, so it will be impacting all the 4 buildings. If it is there is some big issue of earthquake, it will be impacting all the 4 buildings. So what I'm thinking is, if this is going to impact all the 4 data center, then your website will be down because all the 4 copies will be down. Your EC2 is not available. So that is why when Claudia will make the machine, we will recommend Claudia to not create one machine. We will ask Claudia to create multiple machine. So multiple means 2 or more than 2. So suppose Claudia agreed upon creating 2 machines. So one machine will be created in one ability zone and another machine will be created in another ability zone. So you can see there are 2 EC2 machines Claudia has made, but while making it, we have created these 2 machines in different availability zone. One is in availability zone A, another is in availability zone B. So if there is a problem and in the first availability zone, the first availability zone data centers are not working, they are not responding, it means this website is down on this particular machine. If this data centers, group of data centers are not responding, then the machine which is in availability zone will be down. People will not be able to visit the website. But what about second machine? Is your second machine is in availability zone or availability zone B? In A or B? It is in B, right? And there is a gap of 60 miles, 100 kilometers. So do you think the problem of A, is there any chance of impact of that problem on B? No, because we have purposely kept distance. AWS has purposely kept distance between the 2 groups. If one group has some problem, there's a less chance that second group will be impacted. And that is why the second machine will be still up and people will be able to visit your website anytime. Does this make sense? This phenomenon is called as high availability. This phenomenon is called as high availability. Your websites will be highly available even in the failure situation. And this is possible. How I have made it possible? I have made it possible by using multi-AZ approach. Did I use multiple availability zone for launching my website? Could you answer this? Did I use multiple availability zones? While launching the machine, I launched 2 machines. I launched 2 machines not in one availability zone. I launched it in multiple availability zones. And this is why multiple availability zone leads to high availability. Would you be able to remember this formula? Multi-AZ leads to high availability. So this is a strategy. We never depend on one resource. We depend on multiple resources because other resources act as a spare. Suppose I go to exam hall, instead of carrying one pen, I'll carry 2 pens or 3 pens with me because I know that if one get filled, I'll be completely down. So better than that, carry another pen also, which will help us to write down the answers. And that is how multi-resource approach in multiple availability zone help us to achieve high availability. And this is all called as AWS global infrastructure part. So most interesting part that you should know is that each data center is connected to each other through fiber optic cables. There is a network of fiber optic cables which is landed among all the data centers of AWS. So you can see this is a network within Sydney. All the data centers are connected to each other through fiber optic cables. So as such, there are many data centers in many regions. So this is Melbourne, this is Sydney. So all these 33 regions similar to Sydney, All the data centers in those 33 regions are connected to each other through fiber optic cables. So AWS has transocean cables lying underlying or underground below the sea, and it is all connecting all the data center in all the regions of AWS in the world. That network is called as AWS private network. So this is the blue line that I'm using. AWS private network is a network of all the data center of AWS on the planet, and they're all connected through high speed transocean fiber optic cables, which help us to transfer the data between two services very fast. The AWS private network helps to transfer the data between two services within multiple regions, same region, very fast because they travel through this private network of AWS. Can we use availability zone in different regions in multi-AZ? It means his question is, let's say I'm launching my one website in Sydney region and another website in, let's say, Northern Virginia. So this is Sydney and this is Northern Virginia region. So he says that I will launch one website in one availability zone of Sydney, and I will launch one website in another availability zone of Northern Virginia. Can you do this? So the answer is no. We don't do architecture like this. Whatever we launch the project, we launch it inside one region only. So what you can do is you can use another availability zone in that Sydney region, and you can launch your second machine inside that. Or you can use another availability zone of Sydney. Let's say this is AZB and this is AZC. And inside AZC, you can launch third machine. So all the machines belonging to one project, you should launch it in one region only. Cross-regional thing is not possible. Arvind Kumar. I hope you got the answer. And you will get it when I will teach you EC2 service, when we'll do a lot of demos. I will revise all these concepts once again. So, conclusion. We discuss about cloud computing models. Before that, we talk about introduction to cloud computing. We discuss about AWS, we discuss about cloud computing models, and then AWS global infrastructure. In that, we know what is meant by data center, single building. Then we know what is meant by availability zones, group of data center in one area, and what is meant by region. Region is a group of availability zone in the particular country. And we have seen that high availability we can achieve with the help of multi-AZ setup. What happens if I use one AWS account, how the pricing is done? So basically, AWS follows the model of pay as you go. It means how much you are using, that much you have to pay. Let's say I'm creating one virtual machine and my virtual machine is running for 10 hours. So then after 10 hours, I'm deleting that machine. I'm going to terminate that resource. So for those 10 hours, my machine was up. So I have to pay the charges of the machine only for the usage I did. So I use it for 10 hours. I have to pay the charges for 10 hours. That's all. So companies can easily create resources on demand and they can terminate the resources as per their wish on demand. So whenever they want to scale their infrastructure, want more resources, they can purchase, they can create those resources. And whatever time they are using the resources, according to that, every service has different pricing model. And then your total pricing is calculated and you get monthly bills. So do you know monthly bills? You can use the account for 1 month, whatever services you are using for how much duration. Accordingly, different pricing models are there. Then they calculate your bill and they generate the bill by the end of the month. So you have to pay it. In fact, the good part is when you become a first new customer of AWS in their account, they give you free quota. Are you aware of this free tier quota? Certain usages are free. So being a student of AWS, being a learning student, or you're doing it for your personal use, I believe you can go with the basic plan. And with the basic plan, you will get certain free tier quota where a lot of things will become free of cost for you. So practically speaking, you will not get bills if your usage is under the free tier quota. So that is why it is very, very interesting to start with AWS. And companies are finding it very good model, pay as you go, because they can control the cost as well, and they can control the cost as per their usage as well. So this is what we have learned. This was the introduction to AWS and global infrastructure. You have the idea of data center, availability zone, regions, multi-AZ, high availability, everything. Now we are going to a core technical part where, first of all, I will teach you about AWS account. What are the different ways to access AWS account? AWS account is a free account that you can create for you personally, or as a company, you can use business plan and create an AWS account for launching your client's resources. And how to create an AWS account is a very simple process. In case if you want to create your own personal account, then you need to visit a website called aws.amazon.com. This is the name of AWS website. Once you open this, on the top right corner, you can see there is an orange color button, create an AWS account. So this is a sign up page. On this sign up page, you require one email ID, and you need to provide that email ID here, pay@r.com. So this is the dummy email ID I have mentioned, but I want you to mention in email ID. Then you can use some account name. This email ID is very important because this is used as a owner's email ID. This will be your root email ID. And this is very, very important to recover the account also. To log in into account, to recover from the account, everything. So make sure you are giving the email ID you have the access to. So then you need to click on verify email address and you get one verification link on your email. If you click on that link, then your email will be verified. After that, they ask you personal information. What is your full name? What is your mobile number? What is your address? And which type of plan you want to go with. So you should go for basic plan. Basic plan is a simple plan of AWS that comes with the account without any additional charges. And that plan is suitable for small scale businesses, startups, even for community of AWS, people like us who are working on AWS project, who are learning the AWS system. So we all should go for business this basic plan. Apart from basic, there is business and enterprise plan also. So basically, business plan and enterprise plan are giving the same account, same resources, but they are giving extra support from AWS side. So AWS gives you supports for solving your technical issues, solving your pricing issues, or probably solving your security related issues. So these are recommended for big businesses, who has big client base, who use the account for uh, a major volume of resources. But for us, we will go with the basic plan. That's all. You have to give information and choose the basic plan. And finally, they will ask you credit card information. So this is the myth that people generally think that, okay, if I give my credit card, will they deduct or will they do auto deduct? So there is no auto deduct happens. They want you to give the details of credit card. just to check that you have a valid credit card, because people may lie, and if people lie and they generate a bill and they later on say that I don't have credit card, so that is why AWS is making sure that while creating account you should share some credit card details, so that they will get a guarantee that this person has a valid credit card with him or her. That's the only thing. They will not deduct anything from that. So this is the way you can create your account, and that is very easy and free of cost. I hope you understand. In case in future you want to create your own personal account, you can create from this particular process. So this is basic idea how to create AWS account. Now, what are the ways to access your AWS account? How can you log in into AWS account in different ways? The first way is management console. Second way is command line interface. And third way is software development kit, which is called as SDK. And command line interface is called as CLI. And management console is basically graphical user interface. So management console is actually a browser-based account login. Browser-based. I went to my browser and then I log in into the account. So this is called browser-based session management console, wherein you get all the access to AWS account resources with the help of graphical user interface. You can see the things here visually. You can use mouse to click on something, open something. You have these images, icons, links, buttons, symbols, everything you can simply use with the help of mouse. You can simply click on the service, open the service, create the resource. It is very simple interface. Suppose I go to S3 service. In S3 service, I can basically create a storage resource. So as a graphical user interface, I can click on that service name, click on create bucket. I can enter some name and I create one bucket. So what happened is I was able to use this account with the help of my mouse, with the help of these symbols and links here. This is called graphical user interface. It is called management console. This is one way you can access your AWS account. Second way is command line interface. CLI is something that you can relate to your command prompt. Basically, CLI is a way you can enter some commands to do those operations. For example, I created one bucket with the help of management console. But now I would like to do similar kind of operation or some another operation with the help of CLI. So what should I do for it? CLI is a way to do some operation in AWS account with the help of commands. And to know what are the commands available, first you need to have this thing with you. And I'm sharing you some important documents right now. Even you can Google like me, you will get the link also. You have to type AWS CLI reference V2. You can Google and type AWS CLI reference V2. So 2 means version 2. So this is version 2, the second page. You can use this page also. This page is called as AWS CLI command reference. So you will be able to see multiple commands of AWS operations on different services. In order to understand the details of different commands, then you can see the list of AWS services under this command reference page, and they are alphabetically arranged. So whatever service you wish to perform operation on, and you don't know what is the command for that operation. For example, I go to DynamoDB service. So what is DynamoDB service? It is a database service. I can create a table inside it. So let us understand what are the operations available under DynamoDB. So these are the available commands under DynamoDB. You can see create table. This is also one command. There are a lot of commands available. Suppose I would like to do create table. So I'll go on create table. And then this is the page for create table command. Here you can see the complete description, synopsis, options, and then you can see certain examples also. For example, if you scroll down in the bottom, you can see the details of all the options available. Some examples are also given. See, these are some examples given. So let us understand create table. So this is the command for create table. You see that. To create a table with tags. This is one example given. AWS DynamoDB is the name of service, and then create table is the name of command. What are the details we are passing? Table name, music collection, and then we are giving some attributes. Okay. So this is the command that you can execute on your command prompt. In Windows laptop, there is command prompt. In Linux OS or Mac laptop, you can use terminal. So those who are on Linux and Mac, you guys can go open the terminal, and on that you can perform these commands in order to execute that operation. But the problem is, even if I have the knowledge of this command and everything, login is very important. How can anybody come and access my account? You have to log in into account, correct? Yes or no? So the first thing that you should know is, in order to log in onto management console, you have email ID password. Some user ID and passwords are given. On the same basis, for CLI, you require different set of credentials, which are called access key and secret access key. So these are two things, access key and secret access key. Access key and secret access key are credentials you can use for CLI, and the same credential you can use for SDK also. What are these credentials? They act as a user ID and password. They act as a user ID and password. So user ID and password are actually used for management console, but we cannot use user ID password for CLI and SDK. For that purpose, you require separate credential called as access key and secret access key. So the question is, if my manager gives me access key and secret access key, how can I log in through CLI? That's the question. So to log in from CLI, there are some prerequisite you need to do. So first thing that we will do right now is we will install AWS CLI software on our laptop. Okay, so let us go. You do one thing. First, you go to Google and then you type install AWS CLI. Only search for this keyword, install AWS CLI, and then click on first option. This is the documentation website of AWS where you can see all these details. So it is install or update to the latest version of AWS CLI. So what do you do now? First, so you need to scroll down and you can see all the three operating system options are there: Linux, Mac, and Windows. Now, what is the operating system in your laptop? You need to click on that option. So, for example, my laptop is having Windows operating system. So, I'll click on Windows. And once I click on Windows, then for Windows people, this is the first step, download and run MSI installer 64-bit. Okay, in this step, there is a link given, this one. You need to click on that link and it will download MSI installer on your laptop. I can show you. So if you click on this link, it will start downloading CLI v2.lsi on your laptop. You can see MSI software is downloaded on my laptop. I need to open that software and then start installing it. So I have to wait for few seconds because the setup file, setup wizard is preparing few data. So just wait for a few seconds until you get the next button. Okay, so I got the next button. I'll click on next, accept the terms condition, next, next, and install. So it will ask me few questions and then I should start installing it. So it is finished for me. So what you should do is, first of all, you should close the command prompt. Command prompt, terminal, whatever you have, close it and reopen it. Reopen your command prompt once again. Because if your command prompt is already open, then installation won't come. So I want you to reopen the command prompt. And you need to type now AWS -- version. So what is the command I want to type? AWS space dash dash version. And press enter. So once I do that, I get version 2.16.4 Python 3.11.8 Windows 10 exe AMD 64. This is for Windows users. For Linux users, Linux will be written, but you can see CLI version 2.16 will be definitely there for everybody. We have successfully done installing AWS CLI. Now, without this, you cannot perform CLI operations. Remember. So first, you have to type this command AWS space configure. AWS configure is the command to configure login details from the CLI option. So what you get after you type this command, what it is asking for, access key. Suppose you enter your access key, then what it will ask next question? After you enter access key, it will ask secret access key. You understand? So this is the way you have to configure your CLI. And then after you log in successfully, you can easily perform commands. So I can show you if I can get some access key ID and secret access key. So in this lab, I'm going to see my own credentials. And let me first of all cross check if I can get my access key and secret access key. Okay, so yeah, I think we can create it. Okay, so do one thing, everybody. Do you have your AWS account open? Okay, so do one thing. On the top right corner, you can see your login details. In the sense that you can see your account ID, I am user, this particular option. Can you click on this one and you get the option of security credentials. Can you see this option, security credentials? Can you click on this? Then you come on this page, my security credential. You will be landed on this page, my security credential. By default, credentials are not generated. So we will generate our credentials right now. You can scroll down and find out this option, access keys. Access keys is the option they are providing you. So you need to click on create access key, and you can see, options like application running on AWS compute service, or local code, or command line interface. So go for first option, command line interface CLI, and click on next. First of all, I need to understand, and next. Here you don't need to type anything, just simply create access key. When you come on this page, please stop. Don't click on done. I again repeat, don't click on done button. You need to stop here. Are you on this page? Retrieve access keys. Don't click on done button, because after you click the done button, you will lose the access keys access. You cannot get the secret of that key. So before you lose anything, there is a download CSV file button there. If you click on download CSV file, then your details will be stored inside an Excel file. You can open it in Excel file. So you can just see, I got the details of access key, secret access key in my Excel file. I can color it also. You can see this is secret access key and this is secret access key. So I can copy this access key, go to my command prompt, enter it. Again, I can copy my secret access key, go to command prompt, enter it. Then it is asking me default region name. So you can see always in your account, default region is always, if you go, for example, to dashboard. By default, what is the region of AWS account? Northern Virginia, US East one. Okay. So if you want to go to another region, you see the options. So right now it is asking you, do you want to go with the region Northern Virginia? Then keep it blank, or you can specify the region name. I'm keeping it blank because I'm happy with the default region name. And it is saying default output format. Are you okay? Enter. So basically you have to keep these two things blank only. And now you have configured access key and secret access key. So this is the way you are trying to log in into AWS account through CLI. Now we can perform operations. So first of all, what you do, you go to this command prompt, this management console, and open S3 service. You can search the service name in the search box also. Here also you can type S3 and you get S3 option. So first of all, everybody will come on S3 page and we will create one bucket. So I will do one operation from GUI and one operation from CLI. So I'm going to click on create bucket. So once I click on create bucket, only one thing I'll do, I'll give the bucket name. So here I can type anything. Make sure that bucket name should be small letter. If you give capital letter, it will give you error. So after you give the name, click on create bucket. And you can see the bucket is created on your screen. In my account, there are two buckets. In your site, it can be one bucket. Now we will do one more operation, but from CLI. What I'll type, AWS space S3 space ls. So basically ls is the command to list down the resources. So with this ls, you have S3 ls. It means it will list down S3 buckets. So you can see on management console, total there are 2 buckets in my account. So if I perform this ls operation, then I'll be getting details of both the buckets here. Can you observe this output here? You see this output? I'm getting details of both the bucket because ls is the operation used to perform list operation. Now what you do, first of all, you will type this. Okay. First of all, you have to type this AWS space S3 space MB space S3 colon slash slash, and there after slash slash you have to give bucket name. You can see the command AWS space S3 space MB space S3 colon slash slash. After slash slash you have to give some name. While giving the name, give a small letter. For example, I'm giving a name as Rajendra Wagh 123. So you can see my screen. AWS space S3 space S3 colon slash slash Rajendra Wagh 123. So this command will help me to create a new bucket with the name Rajendra Wagh 123. Okay, so I can click on enter and I get a response, make bucket is filled. So what it is saying that specified location consent is not valid. See, when you create a bucket, there is one constraint that you have to provide, and that constraint is region. You need to mention which region you would like to create the bucket. So I can do one thing. After this command, I can type space minus minus region space US dash east dash 1. So always make sure US dot east dash 1. So this is the region I have given. You can see the region name from here. For Northern Virginia, US dash east dash 1. So that region space US east 1 that I have mentioned. You can see the full command now. Only the name of bucket should be different. You cannot use the same name anywhere. Bucket name should be unique across the globe. So after this, you can check now the bucket must have been created. And you got a response, make bucket colon Rajendra Wagh 123. This is the proof that bucket is created. Just go back and see in the console, just refresh it. Now you can see the third bucket is being created. I can see it in the console also. Are you getting this? Something I'm doing it from CLI. I can do it the same thing from UI also. And after that command, it is being very, very clear that you can perform make bucket or these kind of any operation on any resource in AWS with the help of GUI options or with the help of CLIs. All right. So this is the way CLIs are used to access your AWS account. I'm sure you are very clear with this. Now the third way to access AWS account is software development kit. This is called as programmatic access. What is my programmatic access? Programmatic access is the access given to applications from the programs. So when you create one architecture, for example, this is for a website which you want to launch for photography. So your website is running on, let's say, EC2 server, and the photos are stored in S3 bucket. And the photographs are stored in S3 bucket. Then you are using RDS for database. In this architecture, your EC2 service will access S3 bucket and it will also access RDS for database operation. So when you see that when EC2 is accessing it, it means that from the website, these things will happen. Let's say upload of photo or download of photo. This is being, the logic will be written inside website code. Am I right? Same thing. When read and write operation happens on database, then that logic will be written inside the website code. Website is actually a programming code, right? So will they give access to S3 bucket and RDS machine for this website? By default, not, right? For that purpose, you should have SDK access. SDKs are software development kits for different programming language. So let's say Java. If your website or web application is made in Java, then you require Java SDK on this laptop. Or if your website is in Python, then you require Python SDK on your laptop. So whatever programming language you are using, based on that, SDK should be installed. They act as translator. And when from the program you would like to access AWS resources through the applications, then it is called as SDK access. So for SDK access also you require credential. And those credentials are nothing but access key and secret access key. You can use access key and secret access key for programmatic when applications you would like to give access to different services. Such as here, your website wants access to S3 bucket and RDS machine. So this is a Python code. This is a Python programming code to create a table in DynamoDB service. DynamoDB is a database service. So what resource we are creating inside it? We are creating table. So for creating table, this particular API operation is used, which is dynamodb.create table. Under this, all these details are given. So what is happening? This is a programming code. This is my application. In that, this is a code which is in Python language. So in order to make this possible, we should be able to log in. It is simple. Website will be accessing your S3 bucket, DynamoDB table, many resources. So they will require access to those resources. And for that purpose, you should have programmatic access with the help of access key, secret access key. So to make these operations possible, third category of access is called as SDK access, which is called programmatic access. These are the three ways to access your AWS account. Management console, CLI, and a software development kit. Being a software developer, because you are learning developer associate, you should know all these three ways of accessing AWS resources. You should know SDK, you should know CLI, you should know management console. You can do some practice of CLI operations because I have shown you 2-3 demos for CLI. You have also practiced 1 or 2 demos. So you can do more practice at home on AWS CLI. I hope this is okay for you. We will start with a new service, identity and access management. And there are few topics that we are going to cover. So this service, identity and access management, deals with access provision to your AWS resources in your account. So for example, I'll give you a simple explanation of what happens when you create an account. Let us consider this is a newly created AWS account by me. Every account gets account number also, which is 12-digit number. Okay. And when I create my own account, this is me. When you create the own account, so you are the owner of account, or you can say you are a creator of account. You can log in into account anytime with the help of email ID and password. You can log in. So the person with the help of email ID and password who can create the account, that is called as a root user. That email ID is the root user email ID. Root user is the owner of the account. He can or she can do anything in that account. They have full access. There is no restriction for them for any kind of access. But inside your company, there is no single person who is working on project. there are multiple people who works on project. For example, we have, let's say, Claudia, who is our developer. We have, for example, Anil, who is our database admin. We have Sudhir, who is our network engineer. Or let's say we have Fahad, who looks after administration. So these are the four people who are my team members who also work on the cloud project. So our client project has to be deployed on this account. So obviously, all these people will also require to log in into account in order to work on resources. They would also require access to the account. So what you would do, you would share root user email ID and password to them. In order to them to log in into account, you will share your email ID and password of root user. No, first thing, never share root user credential, because if any one of them gets the root user credential, they can get full control of account. They can change the password and later on you can never recover that account. Remember this. You can never reclaim the account. So for that purpose, in order to give them separate access, we have to create users for them, and we will use the service identity and access management. So in AWS, for that purpose, IAM service is used. So what I will do, I will create users in IAM service for these people. So this is the first user I created for Claudia, then for Anil, then for Sudhir, and then for Fahad. So once you create IAM users for them, everybody will get username and password. Everybody will have their own user ID and password. Simple. So if they get user ID and password, they can log in into account successfully. They can log in into AWS account with the help of their separate user ID and password. So root user credentials will never be compromised. But the question is, this way they can log in. So far we discuss about login only. Login refers to identity. So root user also log in. IAM users also log in. So this is referred to identity management. But I'm focusing on access management. So root user has full access. They can do anything in that account. But IAM user has no access or zero access. Every IAM user which is created, by default, they have zero access. It means even though Claudia, Anil, Sudhir, and Fahad, for these four employees, I have created IAM users, they cannot do anything in the account. They can log in. There is no doubt. They can easily log in into account, but they will have zero access to AWS resources. They cannot create any resource. They cannot see the resource. They cannot delete the resource. They cannot do any operation. So this is the way access management happens. So that is why the IAM service, when it gives the name, it gives identity and access management. Identity refers to login and access is referring to access. So this is also called as authentication and authorization respectively. Login, identity, they all indicates authentication. And access indicates authorization. So by default, every IAM user has no access to AWS resources. But this is not the way we should work. Actually, people should have some access. Fahad, Sudhir, Anil, and Claudia. These are four employees who are working in my team. Claudia is a software developer. Anil is a database admin. Sudhir is a network engineer. Fahad is a admin guy, administrator. What access should I give to them? I should give them access to the resources which are required by them. I cannot give all 350 services access. That if Claudia is a software developer, probably I can give S3, EC2, all these services to Claudia. Anil is a database admin, so I can give him access of RDS DynamoDB services. Sudhir is a network engineer, so I can give him access of EC2, VPC, all these networking related part. Fahad is an administrator, so I should give him admin access. Admin access basically gives all access to AWS resources. So Fahad is someone who is admin guy. So generally I can give him access of IAM service. Why? Because Fahad should be able to create another users in future. This is Fahad's responsibility. Fahad is an admin person, admin of the account. So I will give him access of IAM service. This is called as principle of least privilege. And this is being recommended by AWS that you should follow principle of least privilege. It means always give minimum access whichever is possible. Never give over provisioned access. So if Claudia doesn't require access to VPC, then you should never give it to Claudia because that is not required by that employee. So if it is not required by that employee, don't give unnecessary permission. But how can you provide permission? For that purpose, you need to take help of document, which is called as policy document. So you need to attach policy to the employees. So I am attaching policy to Anil, Claudia, Sudhir, Wahad, everybody. And in that policy, I can write permissions. So in Claudia's policy, I'll write permission for S3 and EC2. For Anil, I will pass RDS and DynamoDB. For Sudhir, probably I will provide VPC. For Fahad, I'll provide IAM service access. So this is the way the whole user management works in AWS. When you create account, you become root. But for other employees, you have to create IAM users. And to those IAM users, you have to provide policy document. This was the theory of this lecture. There are three topics of IAM service that we are going to cover: group, policy, and role. And then we will start with new service called EC2 as well as EBS. So as we have seen yesterday that identity and access management is a service who focuses on authentication and authorization, wherein we can create IAM users and we can attach policy to the IAM users. In that policy, we can write down permission. So this is the whole idea about permission management. So by default, every IAM user has no permission. To provide the permission, we have to attach the policy. Now we will take certain scenarios and let us understand the concept of group. Okay. So let us imagine I have a big team, and in that team, I have multiple employees having the same role. For example, these all employees are all developers. Then I have another employees who are database admin. There are few employees who are network engineer. For example, there are few employees, or there is one employee who is, for example, admin. So now I can see that this is a big team, and for a single role, for a single work, there are multiple employees working together. So I want to provide policy documents to them, right? So we have observed that for developers, we can attach policy which can give access to S3 service and Lambda service. But there is no single developer. There are three developers. So what I need to do, I need to attach the same policy to all the three developers. Same for database people, I need to attach policy. Let's say this is for DynamoDB. So both of them should have policy attached separately. Then for network engineers, for example, everybody requires access to VPC service. So you need to attach policy of VPC to all people. So this is the way it will work. But the problem is, if I can see, for the multiple people, I'm attaching same policy, right? Here, if you focus on developers, there are 3 developers. Need to attach policy to every developer. Same in case of network or database admin. So this is a kind of repetitive work. What we can do here is, instead of attaching policies separately to each developer, we can create a group of developers. So this is the concept of group. What we can do here is, instead of attaching policy to every developer separately, first you create a group of developers. You can call it as group developer. And in that group, all 3 employees, you can make it as member. And then whatever policy you wanted to give, that policy you should attach it to the group. Suppose S3 and lambda is written. So what is the result of this? The result is, if a policy is attached to the group, then that policy is inherited by all the group members. So this is Mr. A, B, and C. All 3 IAM users will inherit the same policy. In short, all 3 members will have the same permission, which are given by the group. Same thing you can do for database people. Don't attach policies separately. The best practice is to create a group, attach the policy to the group, and suppose this is your database group. Attach the policy which is commonly required to that group, and then suppose for database DynamoDB is a service they want. Same thing you can do for network engineers. For network engineers, create a group and then attach the policy for VPC. This is an efficient way of providing policy management. And now you can observe there is one guy admin who is a single person. So you can attach policy directly to him, or you can make him the member of a group. You can create an admin group and then you can attach policy to the admin group. Suppose it requires IAM access, whatever. So this is the way group mechanism works. I hope you understand this. So what I'll do, I'll show you practically how the groups are made. For that purpose, first I will go to IAM service. On this IAM dashboard, I will try to find out the left-hand side users and user groups thing. First, I need to have certain users. Right now, I'll create user for this demo. Suppose I'm creating one user called Rajendra. Okay, so this is the username Rajendra. I want to provide him management console access. I'm giving some custom password to him. I'm attaching him a policy. And create the user. Now it is not allowing me to attach the policy. No worries. But I have one user which I can show you. So what I'll do, I will try to show you group creation. So we have one person, one employee. Suppose I would like to create a group and add this person as a member. Then I will go to the left side user groups option. We'll click on create group. I can call it a group of, let's say, developers group. This is the name I'm giving. And then in that group, which users you want to add? I want to add Mr. Rajendra. And then what policy you would like to attach to the group? You can say this is group name. Here you are selecting members. And here you are selecting the policy which you want to attach to the group. So I can find, for example, S3 policy. And I'm saying create group. Okay. So it says that policy attachment is failed. But one thing I can show you that after you create group, for example, there is developers group here. If you can open these developer groups, you can see it is very simple. You will see the members, first of all. This is the member. You can add multiple members here by clicking on add users. And then you will see permissions. You can attach permission again from here. This is the way you can show that I can create multiple groups and can add members inside the group. So the effect of this is whatever policy you attach to the group, that same policy is applicable to all of its members. I hope this is clear. What I'll do a scenario. So for example, we have a group, and to that group, we have attached a policy which has S3 and Lambda access. And now in that group, we have one person who already has some policy directly attached to him, which is about EC2. Then we have another person who has a policy attached to him, which is for SNS. And we have one more person who has no policy attached to him. What are their final permissions? Let's talk about the red person. What do you think, what permission red will have? So that is the group policy plus personal policy, which is directly attached. So directly attached policy gives him EC2 access. Group policy gives him S3 and Lambda. Second, the green person will have SNS, S3, Lambda. And the blue person, S3 and Lambda. Perfect. Okay. Now there is one more possibility that a person can be member of two groups. So suppose there are two groups. The first group, for example, group A, and the second group here. To the second group, we have attached group policy that gives him VPC access. And you can see there's a yellow guy who is a member of that group, which already has Lambda policy. But there is a red guy also who has EC2 policy. So group B has two members. One is the red person again, and the second is this orange guy. So red person's policy earlier was this. Now it should be changed. What are the updated permission of red person? Okay, the yellow will have Lambda and VPC. It is clear. What about the red guy? Red guy will have EC2, then S3, Lambda, and VPC. So this is the way group concept comes. Now we will go to the policy concept in very detail. So as we know that policy is a document which contains a JSON document which contains permission. So it is simply a document. And there is a language called JavaScript Object Notation, JSON. So you need to write in JSON permission. And according to your configured permission, that policy gives permission to that particular person. So the question is, can a person have multiple policy attached to him? The answer is yes. A person can have many policy attached to him. There is no problem. Then can a person have group policy? So the answer is yes. The person can have group policy also. So how to write policy document? How to read policy document? What is the meaning of that? So if you want to see the architecture of any policy, first I would like to show you on the screen of this IM dashboard. You can see policy section on the left side. In my account, there are 1200 policies available right now. If I can show you, these are the titles, right? These blue colors are the titles of policies. And then there is very important thing, that is types. Suppose I filter and I find AWS managed policies. So these are the policies called as AWS managed. Let's say this one, I open it. AWS managed policy are read-only policies. It means that you can use that policy attached to the user, but you cannot modify that policy. There is no button wherein you can modify this policy, or you cannot delete this policy also. This is the system provided or AWS provided policy, which is completely managed by AWS. These are standard policies which are already created in your account, because these are some standard requirements of every project, wherein they may require full access to a service or read-only access to a service. So these kind of things, it doesn't require you to create policy. They already have created certain policies for you. So let us understand CloudFront full access policy. First of all, this is AWS managed. So this is very simple. You cannot change it. And you can see the summary of permissions defined in the policy. What are the permission that policy gives and what level of access it gives, on what resources, it's all. So basically this is summary written in English language for our understanding. But if you click on JSON, then you can understand the policy is actually written like this in the JSON format. I can copy and show you in the notepad. Okay. Okay, this looks like this in the JSON format. So if you see the architecture of policy, you will find one important segment that is called statement. In policy document, you have to write down statements. It starts with the statement block from the square box, and you can find this is statement number 1. If you scroll down, this is statement number 2. If you scroll down, this is statement number 3, statement number 4. So this policy has 4 statements. All right. All good so far? One policy document can have multiple statements. If you focus on one statement, let us say I'm taking the first statement and I will open it in another pad. So this is one statement I can show you on my screen. Every statement can have statement ID, which is called SID. SID stands for statement ID. Statement ID, you can give any alphanumeric number, alphanumeric word, or any pure alphabets, or maybe numbers, whatever you want to write, you can write. This is for your own identification purpose. This is statement ID, which is purely optional. What is compulsory is these 3 things: action, effect, and resource. I repeat, action, effect, and resource. These are the 3 important things that you must know. If you understand these 3 things, then you can create multiple statements and create a policy document. So what does it mean? First of all, action indicates what operation you want to write down in the policy. So here the operation is list all my buckets of S3. So this is S3 operation. And which operation? Which operation? That is list buckets, right? So for list bucket operation, we are writing this statement. What we are doing? Are we allowing or denying? So this is the effect of permission. So do you want to allow permission to do this operation, or do you want to deny the person to do this operation? Deny means restrict someone. Allow means you are giving permission. You are giving permission to do list buckets operation. So I have written effect as allow. So action is list all my buckets. Effect is allow. So the person will be allowed to perform list bucket operation of S3. And the last is resource. On which resource? So here it is written as ARN AWS S3 star. What do you think? What does it mean? So it indicates all S3 buckets. Simple. All S3 buckets, right? Resources can define which bucket you would like to consider under this API. Let us do some example. Okay. So I'll do some changes. So statement ID is like example 1, 2, 3. Okay, now you need to focus what action I'm giving. Okay. So suppose I'm giving two actions. And I'm writing two statements. Okay. So let us understand the meaning of this document. First of all, how many statements it has? Two statements, right? So let us understand first statement. Statement number 1 to 3. There are two actions given. First is list all my buckets, and the second is S3 get object. All my buckets and get object. And the effect is allow on all the buckets of S3. So what is the meaning of first statement? There are two operations, they are allowed. The second statement, action is put object. Put object means upload the objects. Upload the objects. So upload operation, is it allowed or denied? It is denied on all the buckets. So let me do one simple change in this. Okay. Let us try to understand this policy. The first statement, if you see, what is the action given? All actions of S3. S3 star means all actions of S3. All actions of S3. So all actions of S3 are allowed. So it is like full access of S3. The first statement indicates S3 full access, all operations of S3. But second statement, what it is doing? It is denying the upload. So ultimately, finally, combinedly, the whole policy document, what is the effect of this policy document? If I attach it to some IAM user, what will happen? Person can do all operation of S3 except put object. Can we take next example? Suppose I'm doing a change here and I'm writing down that upload is denied. This is the meaning of this statement. What are the permission the person has? Ultimately, the answer is no. So now I have this scenario. What is the combined effect of both the statements? Because the both statements are part of one policy document. So only download is allowed, but upload is denied. But I can see put object has conflict here. Here it is S3 put object allowed, and here S3 put object denied. Can you see that? Here S3 put object is allowed, and here S3 put object is denied. So when such a conflict comes, that the same operation will have allow plus deny both things into the same document, then we will not get any error. Basically, in that scenario, deny will get priority over allow. So what is the effect of this? Even though we have put object allowed, but because of put object denied, deny gets priority and put object operation finally will be denied. So what I'm doing right now, I'm keeping this policy document blank. This is a blank document, nothing is written. And this blank document is attached to a person. What do you think? What will be the effect of this? No permission. So I can write down that if in a document there is one situation that there are no statements written. So that is by default is deny. This kind of deny is called as implicit deny. Implicit means indirect. So if a statement is not written, then it is implicit deny category. Second, if allow statement is written, then it is called as explicit allow. Let us say I'm writing a statement where I'm allowing something. Explicit allow means you're writing allow statement is the only way you can give permission to someone. So here, as because of allow effect, person can do upload operation. The third category is you may find a statement where deny is written. This kind of deny is called as explicit deny. So let us add explicit deny statement here. So now in this document, there are three things available. First, does it has allow statement? What is the explicit allow statement? Get object, put object, right? Does it has explicit deny? Do you find deny statement here? Yes, we can find deny statement. That is get object. And do you have implicit deny? Apart from these two operations, forget about these two operations. Remaining operations are implicitly denied. Is there any statement for list bucket? Is there any statement for EC2 full access? Is there any statement for Lambda read-only access? So you imagine about all the remaining operations which we have not mentioned, which we have not explicitly written. In this document, only two operations are written. One is put object, second is get object. But what about remaining operations of S3 service? Also, all operation of all other services, they are not written here. If I ask you, can this person view or can this person list EC2 instances? Can this person list EC2 instances? The answer is no. Why? Because that statement is not written in this document. If it is not written, then it is implicitly denied. Implicit deny is always there. We wanted to deny get objects. So instead of writing deny statement, I could have make that statement not written. This way, if I remove this statement, still get object is denied. Get object operation is still denied because it is implicitly. So if you want to deny something simple, do not write statement. So it gets denied automatically. But still I have written the deny statement. Why? Why people write explicit deny? Because by default, implicit deny, if you do not write statement, implicit deny is always applicable. But still, why people prefer to go in certain situation, go for explicit deny? Because I'll give you a simple example. Let us say this is the person and I have attached a policy which allows him what operation? I think as per my document, what it is allowing him, put object. Okay, so put object is allowed. And we are very happy because the person can do only put object. But if your manager says this IAM user should never ever be able to download the files. So compulsory, he should never be able to download the file. So you can say that, sir, I have not written the statement for download get object. So obviously he cannot do it. But there is a chance that in future we may attach another document to him or he can become member of a group and in the member of the group, we may have a group policy attached to him. Suppose the group policy gives S3 star full access. So if the group policy gives full access, then he can do get object also. Accidentally, he got full access because of the group policy. So your manager was saying, Sudhir, what happened? Sudhir said that, so it was not my mistake. Because of the group policy, he got full access of S3, and because of that, he can do get object. But then manager will be, no, Sudhir, you should learn how to give explicit deny. What is that? You should explicitly deny that operation here. Suppose you have explicitly denied now. Now what happens? Even if you get group policy or another policy allowing him the same operation, still deny will win over allow. So even though the IAM user gets another permission or gets another policy, because of which he gets the permission, still he cannot do get object because get object is explicitly denied here, and deny always gets priority over allow. So this person will never ever be able to download the objects from the bucket. So let us proceed with the roles part, which is called IAM roles. So role is basically a way to give temporary access to AWS resources. So what is this? This is also permission management, but this is regarding providing temporary access to AWS resources. So let us understand with one example. Suppose we have an IAM user, Anil. Anil is my IAM user. And generally he perform operation over S3. So we have given him S3 full access. As per his responsibility, he has to work on S3 service. So we have given him S3 full access. But it sometimes happens that, Anil may have to work on some different service temporarily. Temporarily means just for short duration. It may be in the same account or different account. Suppose Anil belongs to account number A, AWS account I'm talking about. And this may happen that there is one more account of company, which is account B, and we need a help of Anil to perform operation on, let's say, DynamoDB service of account B. So there is one DynamoDB service, DynamoDB table, and we need to take help of Anil to work on that service. So in that scenario, the first question, working on DynamoDB, is it Anil's regular job? No, right? So if he wants access to DynamoDB, what should we do? We should create roles. Role will give temporary access because this is not regular job. So as per the principle of least privilege, you should give temporary access. So what is temporary access? Is that we can create a role inside account B. Okay. We can attach DynamoDB permission to that role. And then we can add session duration. For example, 1 hour. So we created a role. We attach a policy DynamoDB and we have given some time, 1 hour. And then Anil can assume this role. What will happen? Anil will be able to access DynamoDB service of account B. But for how much duration? Only 1 hour. How much duration he will be able to access? What is the session duration I have given? 1 hour. So one single session will be of maximum 1 hour. After 1 hour, he cannot use that DynamoDB service in that single session. So this is a way you can give temporary access to users to access services. And this example is famously called as cross-account access. So to get cross-account access, assume role operation is performed by the user and they can assume the roles of another account. Can we have roles inside the same account? That is also possible. That is called same account access. It means there is only one account and account A. So I'm talking about same account access. So you know that Anil is a member of account A, is a user of account A. We have given him S3 full access. That's all good. And we want him to access DynamoDB service of the same account. So again, what we will do, we will create a role. We will attach the DynamoDB policy to him, and then we will give session duration. Let's say 2 hours. So what Anil has to do? Anil has to perform one operation called as assume role. So he will assume the role, and the moment he assumes the role, his session will start. So for how much duration he has access to DynamoDB, it depends on session duration. So he can access DynamoDB for 2 hours continuously. After 2 hours, session will be expired. So this is the way we can control that the person is able to access the service for only temporary duration. Imagine we are talking about S3 access. Okay, suppose you want to give get object. This is the operation I want to allow. So imagine Ashdev, there are many buckets in my account. For example, there are 3 buckets in my account. So bucket is actually a resource of S3. Every bucket will have its ARN. ARN is the unique identification of your resource. Not only buckets, but EC2 machines or Lambda function. Every resource in AWS has its own ARN. ARN stands for Amazon Resource Name. So when you make a policy, you have written effect as allow, you have written permission operation as S3 get object, but you have to also tell which bucket you want to make it applicable. So do you want person to do download object on all the buckets or specific bucket? Suppose you want to allow it for all the buckets. That is why you write S3 star in the resources. If you see the ARN here, what is the ARN? ARN AWS colon S3, after that star. So this is the way whatever buckets are there in your account, in fact, whatever future buckets will also be created. Then that person will be able to access all the buckets and he will be able to download all the objects of all the buckets. But instead of that, if you specify a single bucket ARN, let me show you how does it looks. Suppose I go to S3 service and let me create a bucket for you and I can show you the ARN of individual bucket, how does it looks. And S3 is just for example, otherwise ARN is applicable for all the resources. So for you, I have created one bucket. Let us open it and try to find the properties. So this is the ARN of the bucket. What is the ARN? I can show you. So the format of ARN is ARN colon AWS colon S3 3 times colon. And then finally you write bucket name. So this is the bucket name I have given. So what does it mean? The first statement, person can do put object. He is allowed to do put object. But on which bucket? The bucket which I have mentioned here. This is an individual bucket ARN. But if instead of this, if I write star, then it seems that he can he can upload object of all the buckets. Or if I do this, then he can upload objects into only this bucket. This is called resource field. So if I want for a specific set of buckets. So when you want specific set of buckets, it means you want only 2 buckets out of all buckets, only 3 buckets you want to allow. So you can give ARN by giving comma for all 3 buckets. Or you can attach tags. You know, tag is something that you can attach to any resource. And with condition, you can mention that here you can write a star. But in the next line, you can write condition where you can see that if the tag is matching this, only then, otherwise not. So I think we can go back to the role concept. So what I'm going to do, I'm going to show you a demo of role. I don't have 2 accounts, so I cannot show you cross account access, but I can show you same account access. And that purpose, we will take same example of Anil, and I will draw a new diagram for your understanding. So Anil is an IAM user that I'm going to create. So he is an IAM user. So in the step 1, we will create an IAM user Anil, and we will attach a policy to him, which is S3 full access. Allow S3 full access. This is the policy I'm going to attach. Then I'll create a role in the same account, and to the role I will attach DynamoDB policy, DynamoDB full access, and I will give session duration. Session duration I can give for 2 hours. Right? This is step number 2. And finally, in step number 3, Anil will try to assume the role. Assume role is an operation that Anil has to perform. After assume role, he can use the DynamoDB service. And this is what we are going to do practically. So number 1, create a user Anil, attach him S3 full access. So in this account, I'm going for IAM service. I'm a root user of this account basically. There is nothing written, only account number is written. So this is a root user. So the root user is creating one IAM user in his account. Suppose I'm creating Anil here, and A is capital, you can remember. So to Anil, I'm giving a custom password. For example, one password I'm giving to Anil. Next, I'm going to attach S3 policy to him, which will give him permanent access to S3. And I'll create the user. So I can do a separate login of Anil here. So this is the login of Anil. Let us try to go to Northern Virginia region. And now Anil has logged in into the same account. What access he has right now? S3 full access. So he can access only S3 service. My question is, can he access DynamoDB right now? Let us check. Let us check whether Anil can access DynamoDB right now. So we know that he cannot access, but I would like to show you. So he's trying to create a table inside DynamoDB, and he gets an error. He says that the user Anil is not authorized to perform DynamoDB create table. Simple. He is not authorized to perform DynamoDB create table. So what I'll do now, I'm coming back. I'm an root user here. So what I'll do, I'll go to roles and I'll create a role for Anil. Let us create it. So the first question they ask me, what is the trusted entity? In this example, you have to take second option, that is AWS account. You have to choose second option, that is AWS account. So I'm going to choose second option, AWS account, and they are asking me whether the user belongs to same account or another account. So they are asking me about Anil. So the person for whom you are creating role, is he belong to same account or another account? So if I say another account, then I have to give account ID. So this is the way cross account access can be possible. Are you getting my point? Imagine Anil belongs to some different account. Okay. And you are creating role in this account. So obviously you have to provide account number of Anil. That will be called as cross account. But we know that Anil belongs to same account. So I can say this account only. You can take same account number. And then they will simply add permission. So this permission will be added to the role. You understand, we are creating a role here. So add permission is going to add permission to the role. So from the diagram, can you tell me that what permission we would like to add to the role? Obviously, DynamoDB full access. So let us go and try to search for DynamoDB full access. I have attached it. Now they are asking me role name. So I can say that this is role for Anil. I can give any name, but for your understanding, I'm calling role for Anil and create it. So my role is created. I can show you the role here. This is role for Anil. It is the name of the role. And the permission is DynamoDB full access. And here you can see session duration. So by default, what is the session duration? By default, the session duration is 1 hour. You can go to edit button and you can change the duration from 1 hour to 12 hours. You can have standard times such as 1 hour, 2 hours, 4 hours, 8 hours, 12 hours, or you can give custom duration in terms of seconds. But minimum and maximum is always 1 to 12 hours. You can give any duration between 1 to 12 hours. So right now, I would like to give 2 hours as my session duration. So one single session of Anil will be maximum of 2 hours and save it. So can you see, I have configured the session duration. I have configured the session duration. Role for Anil, session duration 2 hours. Permission is DynamoDB full access. So I have finished second step, right? I have finished step number 1 and step number 2 both. However, there is one thing that you need to do additionally, is that you are creating a role for a person. But Anil is not the only user in your account. There can be another users also. They can also assume the role. So how can you make sure that only Anil will be able to access? Because assume role has to be done by Anil only. That you have to control somewhere. So for that purpose, there is one more thing you have to do in the role. There is a concept of trust policy. And every role has a trust policy. Trust policy is a different policy. This is the permission policy. This DynamoDB is giving permission. Trust policy is a different thing. In the trust policy, we can mention who can assume role. It tells you that who can assume this role. You can mention that inside this policy. I can show you. So this is role for Anil. This is the permission policy, which is DynamoDB. And just beside it, there is trust relationship, where trust entities are mentioned. So if you edit it, you can see that right now, STS assume role is allowed. Who can perform assume role of this role right now? Who can do it? Root can do it. We should change this ARN. Instead of root ARN, what we are writing? What we should write? We should write Anil's ARN. So what is the ARN of Anil user? I can show you how to find out ARN of a user. So first of all, you have to go to IAM service, open that user Anil. So try to find Anil inside the user list and open the page for Anil. So this is Anil user and this is the ARN of Anil. So you can copy the ARN of Anil and just paste it here. Now can you see I have changed the ARN? Who can assume the role? Anil can assume the role. Is that clear? So let us update the policy. Now Anil can assume the role. So your step 2 is done. Step 1, step 2, both are done. Okay, so finally we will do step 3. And now in step 3, I can show you how Anil can use this role. Okay, now I can show you how Anil can assume the role. So let's go to Anil side. So you can see this is Mr. Anil who has logged in into the same account. And now Anil is not able to perform create table. So now what I will do, I will ask Anil to assume the role. I will share him role name and everything. So what Anil will do, please focus. Anil will first of all go and click on this particular option where he can see account number and IAM username. And you can see beside sign out button, there is a button called as switch role. Can you see this? I'm moving my mouse. Can you see switch role button? Where did I get it? On the top right corner where you can see your details of login. So you need to click on switch role. So Anil will click on switch role button. And once he do it, a new page will become, which is switch role page. Here, you have to give details of role, not details of Anil. Anil's details already are there. They're asking you details of role. So the first question, role belongs to which account? So I can identify the role. This is the role, right? What is the account number wherein a role is there? This is the account number. So let us copy paste. What is the name of role? So name of role is role for Anil, copy paste. These are the two compulsory details required. Account number of the role and name of the role. Is this clear? Now optionally, you can give display name. Suppose I'm calling it as funny role. Just a display name I would like to show you. Display name is the name that will be shown. And display color, suppose I'm choosing red color. And click on switch role. And the moment I click on switch role, my 2 hours are started. On the right side, you can see display name is funny role in red color. And it is saying that currently active as role for Anil. Do you see this change? Basically, Anil has signed in as I am user Anil. But right now, currently he is active as role for Anil. And his 2 hours are already started because session duration is 2 hours. And now he would be able to perform DynamoDB. You can see. Let us create a table for Anil. So Anil is trying to create a table. Table name is not. Can you see he has successfully created a table? Did he get any error? No error. Because he got an access to DynamoDB through the role. He is currently in funny role, which is role for Anil. And his 2 hour session is still going on. So he can do operation inside DynamoDB. After 2 hours, what will happen? Permissions will be revoked. He will lose the access to DynamoDB because role session is expired. But whatever he created, will it be there or not there? Suppose he created this table now, right now. So after 2 hours, whether this table will be there? Of course, yes, because role decides access. It doesn't decide resource deletion or creation. Only access will be removed. But whatever you have created, that will be remained there. So this particular table will be still there even though the access is removed. For example, let us do it right now. Anil will switch back. You see the switch back button? Because of switch back, he can leave the role right now. So now he clicked on switch back and he has voluntarily left the role. And then you can see it says that you are not authorized to see the table list. Before switching back, he was able to see the tables, but now he is not able to see the table because he has switched back from the role. So he voluntarily has left the role, even though 2 hours are still remain, but he has left it because he says that, sir, my job is over. I don't want to continue with this role. So he has left it. But does this mean that the table are deleted? The table created by him, are they deleted or not deleted? Not deleted. I can show you. From the root users login, I can show you DynamoDB tables created by him are still there. Only his access is removed. See, this was the table made by Anil. And even if Anil wants, he can assume the role again. Go here, again click on funny role. And he gets the access back. New session is started. You can see he got the access to DynamoDB. He can again left the role. He lose the access to DynamoDB. So he can create as many sessions as he wants. Again, he clicks on funny role. He gets entered into the role. So every time a new session is created. Imagine if this is cross account access, then Anil can access a service of another account also. So this is what I taught you. And this is called as user role. Role has multiple types. Whatever I have taught you was a user role. User role are the roles who can be assumed by users. And whatever I have shown you is the user role example. And when you create a user role, that time You can go to IAM service and I can show you right now. When you go to user role, that time, how to decide whether it is a user role or not, you have to choose second option. If you want to create role for users, if you want users to assume the role, then choose the second option. Okay. If you are creating role for an IAM user, then go with the second option. Now, I will also tell you what are the other types of role. This was just user role. Second is called as service role. So what do you mean by service role? So basically service role is the role that can be assumed by AWS service. Simple. User role is a role that can be assumed by IAM user. Service role is the role that can be assumed by service. So you'll be like, sir, why services required to assume the role? So the answer is, in AWS, if one service wants to perform operation over another service, suppose inside your architecture, there is one EC2 server who would like to do some operation on S3. So this is called as service to service communication. So this is service to service communication. So for EC2 to perform operation on S3, does it require permission? The answer is yes. In AWS, whether you are a user or you are a service, I'm showing you both the scenario. This is the example of service. This is example of user. For user, permissions are required. Permissions can be given by policy or with the help of role. So user can assume role or user can see his policy and he can access the bucket. But what about EC2 service? How a service can access another resource? For that purpose, service roles are required. So even services requires permission to perform operation over another services. So generally compute services would require roles. So I'm taking example of EC2. So in this example, EC2 requires permission to perform operation over S3. So what I will do, I will create a service role for EC2 and attach S3 permission. Simple. So step 1 is create a service role, attach the permission, and step 2 is add the role to EC2 machine. So I'm creating a role for EC2. So that time, what is the trusted entity type? You will take first option. Okay. You will take first option, which is AWS service. So you are creating role for service. So that is why AWS service is the option. That AWS service you will choose only if you are creating service role. An AWS account you will choose only if you are creating user role. So right now I'm creating service role and I'm choosing the name of the service who would like to perform the operation. So that is the service role for EC2. Next. Now we will attach permission. What permission I should attach to the role in this example? S3 full access, right? Because we have taken S3 service. So EC2 wants to perform operation over S3. That is why S3 full access I am giving. Next. What is the name of the role? I can say that sample role for EC2 to S3. This is for my understanding. I have given the name. And in the trusted entity, who is the principal here? A principal is a service. What service? Basically, principal is EC2 service. So you don't need to give ARN of EC2 because service role are generic. They are created for all the resources of that service. Unlike the user roles, service roles are generic. Suppose you are creating a role for EC2, that will be for all the EC2. Any EC2 can assume it. That is why we have given the name. We don't need to change it. It's already there. So we will not change the trusted policy. You can see sample role for EC2 to S3 and it has S3 full access and trust relationship. We will be happy with EC2. And we have nothing to do with session duration. 1 hour is enough. If that expires, EC2 will again assume the role. So no problem. So what is the scenario is I have created a role for EC2 machine. Then the question is, how can I add this role to EC2? Step number 2, how to add this role to EC2. So basically for adding the role, you should create one machine, and this is not required. You should create a machine. So I'll go to EC2 service and I'll create a EC2 server for you. Okay, so let us create one EC2 machine for you. So suppose you're creating one EC2 machine. So one machine I have created. Imagine your machine is ready and you want to modify the role. You want to add the role to that machine. How to do that? So first of all, I'll wait for completion of that machine, and then if it goes to running state, then I'll show you how to modify the role. But before I add the role, I would like to show you whether this EC2 can perform operation over S3. Okay, so my machine is running. I can show you that this EC2 machine cannot perform operation on S3 without the role. So I can first of all show you that whether this EC2 can perform operation on S3. So that is why we have logged in inside the EC2 machine, and we will try to perform an operation AWS S3 LS. So I'm trying to perform list operation on, I would like to list all the buckets inside S3 service. What you get? You get credential error. They are saying that this EC2 machine cannot log in into this EC2 machine cannot access S3 service, right? So what I'll do now, I'll go back to my EC2 service, go to actions. Please see what I'm doing. Go to actions, security, and this. You can take a screenshot. What are the options I'm selecting? First, I have selected the machine. Second, went on actions, click on security, and the last option, modify IAM. So when I do this, I can find out the IAM role. So the name was sample role for EC2 to S3. You can see I have selected the role which I created and updated. So now once I update the role here, you can see successfully attached sample role to the instance. I will try to do the same thing. AWS S3 LS. And I got bucket, all the bucket list in my particular S3 service. What I will do, I will try to perform AWS S3 LS operation. And we got an error. So they are saying that from the EC2, you cannot access S3 because the credentials are not, they are trying to find credential, but the credentials are not there. What they are saying, unable to locate credential. They cannot find the credential of S3 because when you get the role, you get separate credential. So EC2 doesn't have role. So EC2 does not have the credential to find S3. When you assume the role, you get separate credential. This was applicable for Anil also in the previous demo. Here also EC2, if it assumes the role, it gets particular credential. Right now, the system is not able to find those credentials. Now what I will do, I will add the role. Select the machine, go on action, click on security. You can take a screenshot of this, Claudia Beckman. Can you take a screenshot of this image? Once you click on modify IAM role, you need to just find out the role which you would like to attach. So I'm attaching sample role for EC2 and update the role. What happens? Because of these roles, EC2 will get credentials. Temporary credential for credential is not attached, role is attached, but what it does, I'll tell you. When EC2 will try to assume the role, there is an STS service which will give temporary credential. And those credentials will be used to access S3. So now EC2 is trying to assume the role because when it performs the operation, it will assume the role. Immediately it gets the thing. So do you understand two types of role? User role, service role. Okay. So that is all about role. Now there is a third type of role also, which is called role for federation. But this is now deprecated. I can show you. People can create third type of role, which is role for federation. Suppose if I create the role. For role for federation, number 3 and number 4 options are there. What does it mean? You can allow the people outside the account to log in and get access to your resources. It means that if you go with third option, then you get identity provider, Amazon, Cognito, Facebook, Google. So even though the person is not member of AWS account, he is not an IAM user. He is some outsider. He is not IAM user of your account. So that person can access your resources with the help of Amazon identification or Cognito login, Facebook login, or Google login. That's called web identity. So this allows federated user by specified external web identity to provide. So let's say I say Google. Then there are some settings that you need to find out. But the point is, people using their web identity can access your AWS resources, even though they are not member of that particular account. Then fourth option is also federation, but this time it is not web identity, it is SAML 2.0 federation. It means SAML 2.0 is a standard that is used to connect your corporate directory to your AWS account. So what does it mean? Do you know companies maintain their corporate directories? Maybe Okta or Microsoft Active Directory, or they may be having their own solution where you are the user of that login. You always log in into your portal, right? Every day morning, you go and you log in into your portal. So you are the user of that corporate directory. So if you want people like that to access your AWS resource, you can do with SAML 2.0 federation. So web identity and SAML 2.0 are the examples of federated role, which is third type of role. But from last 2-3 years, AWS has deprecated this method. They say that don't use this method. Instead of that, what they did, they created a new service called as Cognito, which we are going to learn definitely in the last lectures. In Cognito service, you can do federation better. So when I will teach you Cognito, that time I will teach you federation part. So there is nothing to need, no need to learn federation in IAM service. We will do federation using Cognito, which is a recommended way. So that's now the end of IAM service. We discuss about group, we discuss about roles, we discuss about policies in very detail. Okay, so now we are going to start with a new service called EC2. After IAM, we are jumping to the next service called EC2. EC2 stands for Elastic Compute Cloud. What is this service? This service is a compute service which gives us virtual servers inside AWS. It means that it can give you a virtual machine. On that virtual machine, you can deploy your application. It is a virtual machine where you can deploy your application. An application can run on this EC2 machine. So this is something which comes with different capacity. I will discuss about that. How to create one EC2 machine, how to deploy application. There are many demos that we are going to perform. Okay. So the first thing that I will start with is I'll teach you how to create EC2 machine, which is called as EC2 instance. How to create EC2 instance. And this will help you to understand architecture of EC2. So basically the EC2 machine is a compute resource. So this is my EC2 instance. One instance indicate one machine. So this is one instance. Now similar to your hardware server. So if you compare, let's take example of a laptop. which is also a hardware machine. So for a hardware machine, what are the things very important? First is operating system. Second, CPU. Then memory, random access memory. Then storage. And finally, application. So you're talking about softwares. Am I correct? These are the things very important for a laptop or for any hardware server. So same thing we will need for EC2 also. What we will need? First of all, for any EC2 machine, we require operating system. So for EC2 to get operating system, we have to use images. So what file is used to install operating system? Image file is used, right? Let's say for Windows, we use ISO files to install operating system on your laptop. Similarly, for your EC2 machine, we require image, which is called as Amazon Machine Image. So EC2 also requires OS, which is given by AMI. These AMIs are available into your account, and these are available for all the operating systems, Windows, Linux, Macintosh, and in all three operating system, all their versions, they all are supported by these AMIs. Second, EC2 machine also requires CPU and memory capacity. For the purpose of these two, there is a concept called as instance type. What is this instance type? Instance type decides CPU and memory combination. So AWS has created more than 750 instance types, and these instance types has multiple combination of CPU and memory. While doing the practical, we will observe different instance types. So the solution to second and third requirement is we can choose instance type where we get a method or a mechanism to choose your CPU and memory. The next thing is storage. So in your laptop, you have hard disk or SSD, solid state drive, inside your laptop as a storage device. So similarly for EC2, you require a storage device. Basically, why the storage is required? Why do we need storage device into your laptop? Why do you have hard disk or SSD in your laptop? The important purpose is to store OS and application. Where the OS and application, when you install OS and when you install software, the files are stored are in storage devices, right? These storage are primarily used to store operating system and application files. And then you can store other type of data also. So similarly, EC2 system also requires a storage so that it can store operating system and application files. And that storage is given by another service called as EBS. And it is called as EBS volume. So what is meant by EBS? EBS is a separate storage service, which is not part of EC2. EBS is a different service. And what we can do in EBS, we can create storage volumes. So let's say this is the volume of 8 GB. So EBS is a block level storage device who is made with the help of underlying technology like hard disk or SSD. There are different types of EBS we are going to see, but you can choose whether you want hard disk type or SSD types. Accordingly, you can create an EBS volume, and that EBS volume will act as a storage device for EC2. So as I told you that these are two separate devices. One is EC2 instance and second is EBS volume. But then how they are connected? They are connected through network. And now this becomes a complete machine. EC2 instance is a compute part, EBS volume is a storage part. And they are connected through network. That is why EBS is also called as network drive. So when you install OS using AMI, that OS is actually stored inside EBS volume. The files of OS are stored inside EBS. And if you install or if you deploy any application, the application files are also stored inside EBS. So when you start the machine, where is the OS boot from? OS will boot from EBS volume. Okay, so AMI, instance type, and EBS volume are the options that we are going with. Finally, the last question is, how will you install the applications? How will you deploy the application on single EC2 machine? So for that purpose, you have two ways. For application installment, you have two ways. Number one is called as user data script. And number two is called as remote login. And I'm going to show you both the methods. We all will do the practical of both the methods. Okay. First, I will show you how to install application using user data script. And second, I will show you how to do installation of application while doing remote login. So what is the difference between them? The difference is that the first method is a bootstrapping method. It means it allows you to install the app, install application at the time of launching the machine. So when you create the machine, it is called launching process. When you launch the EC2 machine, that time this data script will run and it will install application. And the second method is it can allow you to install application after the launching of EC2. Suppose you already have launched one EC2 which is already running. And after that, you want to install something on EC2, then you should know remote login. User data script and remote login. That the first method will allow us to install the application at the time of launching. And the second will allow us to install the application after the launching of EC2. And we are going to do both the demos. All right. So for creating EC2, these many details are required. Then the second question is, what else is required for launching EC2 machine? So the prerequisite for that is network. Inside your AWS account, we should have one network inside your AWS account. So for that purpose, we have a service called VPC. So what will happen? While launching the EC2, they will ask you network settings. Network settings means they will ask you in which network. For example, this is one network, okay, which is called VPC. In which network you would like to launch your EC2 machine. So you can tell that I would like to use this network. So that is decided by VPC. So right now, you don't have any idea about VPC service. You don't know anything about networking because that is a future lecture. So right now, what we are going to do, we are going to use default VPC. So there is one default network already available, which is called default VPC. This default VPC will help us to choose the region for our EC2. Do you remember region and availability zone? So we can decide which region you would like to launch your EC2. And there is one more concept called as subnet. Subnet will help you to choose the availability zone. So you can decide which region and which availability zone I would like to launch my EC2 machine. So that is called network setting. Right now, we will go with default VPC and default subnet, which are already available in your account. So we are not going to create any VPC or we are not going to create any network for our EC2. We are going to use the default network and default subnets. But so we will go step by step. So right now, whatever things I have written at the top, OS, CPU, memory, storage, application, they are required. You can configure them. But when they will ask you about network operations or network configuration, you will go with default VPC and default subnet so that you can choose region and availability zone. How your EC2 will look like, I can show you in another diagram. So your EC2 will look like this. You will choose default VPC. Inside that, you will choose default subnet. Any one subnet. For example, you have chosen default VPC of Northern Virginia. This is the region you have decided. And then you are choosing subnet, which is in availability zone A. So you have decided Northern Virginia AZA. Inside that, your EC2 will be launched along with your EBS. So this is the networking scenario. Then we all will be sitting here inside public internet. So we all are connected through public internet. So if you want to access the application on EC2, suppose I'm launching some website. If I want to access the website from public internet, what do I require? How can I access website running on EC2? In my browser, what should I type? Public IP. Public IP is required. So we'll get public IP and we will try to test whether we can visit the website. You should know the whole idea about the placement of EC2 inside network and how from the public internet we can test the website. First thing that you have to do is that, so let us go and search for the service EC2. EC2. Let us search for EC2 service. The tagline says virtual servers in the cloud. Open this EC2 service. So this is called EC2 dashboard page. The first thing you should understand that you can see different option on the left side. You can observe my screen. First is instances group. Second is images group. Third is EBS group, which is Elastic Block Store. Next is network and security group. Next is load balancing and auto scaling. So EC2 provides these many features to us. Out of that, today we are going to create our own EC2 machine. Okay. For that purpose, you have to click on left side instances option. Under instances, you have first option called instances. You have to click on instances option. And you can see right now, there is one machine available in my account, but that is already terminated. But in your case, it will be 0 machines, right? 0 instances are there. Now what we will do, we will go and we will click on launch instance. There is an orange color button, launch instance. Here, first question is name and tags. You can attach tags to your EC2 machine. So name is the default tag. If you want, you can give any name. For example, I'm calling it as demo machine. Okay. You can give any name to the machine as per your choice. This will be the name tag. Next is, if I just show you all the options here. So EC2 has these many options. First of all, application and OS, that is AMI. Next is instance type. Next is key pair, network settings, configure storage, and advanced details. So we are going to give all the values for all these options, right? So let us start with the first, application and OS images. When you see application and OS images, so you will get list of AMIs. If you want to see all the AMIs, then you get a button here, browse more AMI. Can you find this blue color? Browse more AMIs. You see here on my mouse. You can click on browse more AMIs and you will find that there are 47 AMIs available by AWS. 47. Suppose the first is Linux, second is Linux 2, third is Mac Sonoma, fourth is Mac Ventura, next is Red Hat Linux, next is Mac Monterey, next is Red Hat Linux, next is SUSE Linux, then Ubuntu, then Windows Server. See, you can see all the options are there. So in these options, we are going to choose first AMI, that is Amazon Linux 2023. Why? Because this AMI is free tier eligible. It means that you can get free tier quota for this AMI. So you will not get much billing on it. So I have to click on select. So you can see my screen. Amazon machine image is Linux AMI that we have selected. So if it is done, then we will go with the next option, that is instance types. Under the instance types, you can click on compare instance types. This is blue color option. Compare instance types. So when you click on compare instance types, I can see more than 780 instance types are available. More than 780 instances are available. So let us understand the meaning of it. Let's say the current selection is T2.micro. T2.micro gives me 1 CPU, 1 GB of RAM. Let's go to another instance type, T3.micro. T3.micro gives me 2 CPU and 1 GB of RAM. Let's go with C3.large. C3.large gives me 2 CPU and 3.75 GB of RAM. Let's go with C5.xlarge. This instance gives me 4 CPU and 8 GB of RAM. We can get a combination of CPU and memory capacity. Let's go with the last option in this first page, that is C5a.24xlarge. This instance type, if we choose, then our EC2 will become 96 CPU and 192 GB of RAM capacity. Even you can go to next pages. Let's find out this one. C6gd.xlarge. It gives me 4 CPU, 8 GB of RAM. Let's go with the some different page randomly. Let us find out last option here. M5ad.atxlarge. This gives me 32 CPU and 128 GB of memory. Let's go with the next page. This one. M7i.metal 48XL gives me 192 CPU, 768 GB of RAM. So what is happening is you can choose different instance types and accordingly you get the different combination of CPU and memory. And your pricing of EC2 depends on instance types as well as AMI. So for free tier quota, in order not to get billed, we will go with T2.micro for our demo, which has 1 CPU and 1 GB of RAM. Shall we proceed now with T2.micro? You can see my choice is T2.micro and I'm going to proceed with the next step. The next step is key pair, where login is written. So why this option is given, what it will do for us, what this key pair means. This key pair is required for remote login. If you remember, for application installation, there are two options. You can go with user data script or you can do remote login. So whenever you want to do remote login, you should create a key pair for you. So in my first demo, it is not required. So what I will do, I will go with proceed without a key pair. What option I will choose? Proceed without a key pair. Because in my first demo, I do not require a key pair. So proceed without a key pair. That is my key pair option. Next question is network setting. In network setting, you can find out there is a network already selected. Which one it is? Default VPC. Can you check, is it default VPC? So which region we are in right now? Northern Virginia. So where is our EC2 will be launched? Our EC2 will be launched in Northern Virginia region, right? Second, subnet. What is written in subnet? No preference. It means they will choose any subnet in any availability zone. Are you okay if they choose any availability zone? Yes. If you are not, then you can click on edit button and you can choose the subnet. Suppose I'm choosing this. So which availability zone this subnet is? Can you read this? US East 1E. So 1E is the availability zone. You can see this is US East 1B. This is US East 1C. So basically US East 1 is the name of your Northern Virginia region and ABC later are deciding AZ. This one is US East 1F. This one is US East 1A. So suppose I have selected US East 1A. So they will ask you auto assign public IP. So they are asking you, do you want public IP to be assigned to this EC2 machine? So the answer is yes. We want public IP for this EC2 machine for testing purpose. And for that reason, already enable is selected. So there is no problem for us. It's already enabled. The next question is firewall. For every EC2 server, there is one firewall you can create who can filter the traffic. This firewall is called as security group. This is a new concept that you are learning today. Security group. Security group is a firewall that every EC2 machine has. And you have to configure that firewall. You have to give certain inbound rule for it. For example, right now you can follow me. First of all, you can give some security group name. Do you want to give some name here? Let us give some name. Let's say security group for demo 1. This is the name I'm giving. Security group for demo 1. Next, they are asking you inbound rules. So they are asking you what traffic you would like to allow. So right now, you can choose type as SSH and anywhere. So keep it as it is, don't change it. You click on add security group. So let us add second rule here. Inside this second rule, you will choose type as HTTP and source as anywhere. So you can see my screen, there are two rules. The first rule is SSH anywhere and the second rule is HTTP anywhere. So we are going to allow only two type of traffic to come into my machine. First is people can do SSH, they can do remote login. And second is people can visit our server. And for that purpose, as it is web application, we require HTTP traffic. So if it is done, you can let me know. So our network settings are over. The next option is storage. Inside storage, already one volume is selected. It is called as root volume. You can see here, 1 indicates quantity. This 8 indicates size. And this GP3 indicates type of volume. You can see general purpose SSD, general purpose SSD, provision IOPS SSD, provision IOPS SSD. So basically you have different types of EBS volumes, but by default, the volume that is attached for root volume purpose, it is of 8 GB of GP3 type. So we are happy with this. We are not going to do changes here. Finally, the last option is advanced details. In advanced details, advanced level settings are there. You should know two settings. First is IAM instance profile. So what is this option? For every EC2 machine, for every EC2 instance, there is a concept of instance profile. This is the place where you can add a role. Do you remember service role? In the demo, I shown you how to attach the role after the creation of EC2. Now here, if you know already that this EC2 machine will require a role, then you can select and identify the role that you would like to attach. For example, I would like to attach this sample role for EC2 S3. So that in case of future, if this EC2 machine requires S3 access, then this profile will help it. Right now, I'm just showing you, you can add the role here also. But right now we don't have role, so we will not do anything. We'll simply go down in the last option. The last option is called as user data. This is the option where you can have your user data script written, and what EC2 will do, it will execute those script. So you can write down some bash script here. What you do right now, go to your notepad and you have to select this much. I want you to select this complete script. Can you copy this? Copy this script and paste it here. All right. So like finally, you can see the summary on the right side. Okay, so Arun is saying what that option below, for what purpose? So first question is number of instance. So we are happy with one machine. Linux AMI, T2.micro instance, security group we have created, storage volume of 8 GB we have done, and we have given the user data script. So let us click on launch instance and wait for a moment. So you should get this success message. So you have successfully initiated launch of instance. Okay, so you can click on instance option again and you can see that your machine was in pending state and right now it is showing you running. Can you confirm it is showing you running? So instance state is a state of the machine. You can see stop instance, start instance, reboot. Reboot means restart, hibernate, and terminate. So these are the 5 states of instance: stop, start, reboot, hibernate, and terminate. So when you start your machine, it goes into running state. Running state is the active state of machine. You can access the website on the EC2 only if it is running. So remember, when your server is running, that time only people can access the application. So if I create this machine, I can select and see the details of the machine. Just open it. This is the page for my EC2 instance. I can see a lot of details are there. It has got public IP also. State is running. It has got all the details such as security. So you can see security group here. Storage. You can see EBS volume which is created. So this is the EBS volume which is attached to your EC2 machine. Right now what you do, you just see public IP address. Do you see public IP address? So what you have to do, you have to click on these boxes, which will help you to copy the public IP. You need to click on these square boxes. Once you click on these square boxes, open the tab and paste that number and see. I got connected to the website on my EC2 machine. From my local computer, from my browser, I could visit the website on EC2. I can see the content of website, hello world. If you see the script, you can see that the last statement. We are having index.html. In that index.html, we are going to print hello world example. So we are expecting to run index.html, and for that purpose, we are using HTTPD server. HTTPD is a web server on EC2 machine. You need to install it. So we are installing HTTPD server, Apache server On that, we are putting index.html, and that index.html is having this statement hello world. And you can see this. So as per my architecture, from the public internet, can we access the website on EC2? We have learned how to give user data script and install the application. Now we'll go with the second option, remote login. How can we install application by doing remote login? So this is the demo number 2. First of all, you will go to your EC2 page. You will click on left hand side on instances option. All right, you can see your one machine. You need to click on launch instance. You can give a name as demo machine 2. So I'm creating second machine right now by giving a name as demo machine 2. And here the operating system already Linux is chosen. So I don't think you need to change anything. First give it a name. Second, for operating system AMI already Linux is selected. You can see here Amazon Linux 2023 AMI is already selected. Even instance type is also T2.micro. So that instance type is already selected. Next question is key pair. And this is very important this time. In your second demo, when you want to do remote login, even it is written in the bracket also, login is written. So if you want to do remote login, then you require a key pair. And what is this remote login concept? I will explain you right now. So remote login is a method which is used by developers to install anything afterwards. So let us take this example. Okay. So you can see that this is blue color person is a developer. This blue color person is not end user. This red color is end user. He is visiting website. But this blue color person is developer. Suppose developer wants to log in inside the EC2. I'm saying login. I'm not saying visiting AWS or visiting website. He's not visiting website. He wants to log in EC2 from his local computer. This is called as remote login. So developers do not need to log in into account, because you can understand login into AWS account is a different story. I'm telling that can you directly log in into EC2? So EC2 is a server. You can log in inside it. So if you want to log in into EC2 remotely from your local machine, then it is called as remote login process. Do you understand remote login process? It is done by developers so that they can install something on the EC2 machine. It is used in many places. For example, if you want to install application later on, or if you want to update your application, or if you want to update operating system, update or patch, you should require remote login. That developer do not need to visit AWS account. It is not required. They can directly do remote login to the EC2. Only Fahad understood it. What about other participant? I will not proceed without your confirmation. We are doing it practically, no doubt, but I would like to understand whether you got the idea of theory. Okay. So now for remote login, two things are required. Number one, inside your security group, you should allow SSH access. What is SSH? SSH stands for Secure Shell Access. It means for remote login, which traffic should be allowed? SSH traffic should be allowed inside your security group. So this is one thing which is very compulsory. Second thing which is compulsory is you should create key pair. Now what is meant by key pair? That I will explain. Key pairs are used for authentication purpose. So I can explain your key pair with the help of simple example. So this is your EC2 machine. which is inside your AWS. And this is you as a developer in your public internet, right? You will be connecting through public internet. And this is your local machine, your laptop. So what you want? You want to do remote login. And that for that purpose, we are using SSH protocol. So this is possible. Technically, you can do it. But for authentication purpose, because the question is this developer login inside your account? Where do we log in? Are we logging inside the AWS account or inside EC2? So developer will log in directly inside EC2. He will not log in into AWS account. So try to understand. From his local machine, he wants remote login to EC2 machine. So if you want to remote login into EC2, you need to authenticate yourself that you are the right person. Otherwise, anybody can log in into EC2 and they can play around with your server. They can install bad application. They can install some viruses, malware. So EC2 machine, you cannot get login easily. You need to authenticate. For that purpose, key pair is a concept. So what is key pair? When you create a key pair, then this key pair consists of two keys. One is called public key and second is called private key. So what happens? Public key is stored inside your EBS volume, PK. So public key is actually stored at EC2 side, or obviously EC2 side it will stored inside EBS. And private key, PR key. Private key will be stored inside your local machine. So now this is called key pair. Public key goes on EC2 side and private key remains at your local machine. So what you have to do? When you do remote login using SSH, then you have to pass the path of private key. What you have to pass? Path of private key. So basically while login, you are giving your private key and EC2 will check that private key whether it is correct or not correct. If it is correct private key you have passed, then it will allow you to log in. Otherwise it will not. So do you remember some movies where, people want to do some dealing, they want to transfer some parcel. So what they do? They actually cut a paper into two pieces. One piece is at one party, other piece is at other party. So when they actually meet, how can they authenticate themselves? They give the one piece to the other person. The other person will match that piece with your piece that it has. And if the match is found, then he can consider that this is the right person. Similarly, public key and private key are two pieces. So when you do login, you have to pass the private key. And EC2 already has public key. So EC2 can compare private key with public key. And if it finds that it is a right pair, then it will allow you. Simple. Correct? This is the human technology, right? How to authenticate people correctly. So this has been taken into cryptography. I think this example helps you to understand key pair part. Cryptography is inspired from real life, right? So now let us come back into our demo. And what you do, you click on create key pair. You can see this option. Create key pair. When you click on this, then first thing is you need to give a name. So I'm calling it as key pair 9th June. So now click on create key pair. And you will observe that one file is downloaded on your local machine. Can you see that? Can you open that file? So this file is having private key. This file is actually a private key. So Claudia, do you understand private key is downloaded on your laptop? Please respond. Where is the public key? In EBS volume of your EC2. Now, for example, if I know that this file is there in my download folder, I can show you. This KP pair, this KP pair 9 June is inside my download folder. So they will store it in their local system. And if they know the SSH command, they can easily log in. So whoever has this private key, they can log in inside that EC2. Is it clear? This is a conclusion. Whoever has this private key, and I will show you right now. So first of all, key pair part is done. Now go to network setting. We will go with default VPC. No preference for subnet. Public IP is enabled. And for security group, we can allow SSH as well as HTTP. SSH is required because we want to do remote login, and HTTP because people want to test whether the website is running or not running. You can click on this checkbox, allow HTTP traffic, and SSH is also. Now for storage, we will not do anything. We will go ahead, and into advanced details also, we will not write anything into user data script. We will not write anything into user data script. We will skip this process and launch the machine. Now tell me one thing, this machine has any application right now? Does this machine has any application right now? No. This machine has no application right now. So it is a blank machine having only operating system. You can check. So once it becomes, right now it is pending. So once it becomes running, you can test whether you get any application or not. So let us find out this demo 2 machine and find out the public IP address. I know that there is no server on this EC2, so we get an error. We cannot reach this page. Okay, because we have not installed any application yet. We just have operating system. So now what we will do, we will try to do remote login, but from local machine. For that purpose, you have to open command prompt. If you're using Windows laptop, open command prompt. If you are using Linux or Mac laptop, then go with terminal. Can you check AWS -- version? Can you type this command? AWS space -- version. Do you get CLI version written? I can see that CLI is present in my account. Now what you have to do, first of all, you need to tell me in which folder your file is stored, private key. So can you do CD downloads? So we have to go inside that folder. So we all have to do CD space downloads. My spelling is wrong. CD space download. I have written wrong spelling. So finally what you do, go to your EC2 machine. Come on this page. Here you find connect button. You can see connect button. Click on connect button. It says connect to instance. In connect to instance, you have to click on third option, SSH client. You can see SSH client I have clicked on. And there you find an example. So in the example part, you have to copy this example, SSH -i key pair 9june.pm EC2 user dash. Copy and paste it here. This is the command to do remote login. In this command, the name of command is SSH -i stands for identification. So it will identify key pair. So the name is also given, key pair 9june.pem. So we are giving the name of the private key. And finally, we are giving username of EC2, that is EC2 user. And this is the public DNS of your EC2. So where we get it? We get it from here. In fact, after the @ you can give public IP also. Instead of this long URL, you can give public IP of the machine also. SSH -I key pair name EC2 user @ EC2 machines public DNS. Can you click on enter? What response you get? Are you sure you want to continue connecting? Is this the question asked to you? Are you sure you want to continue? So can you type YES, yes here? Can you type yes? You can see. Finally, you are permitted. You are permitted and you are logged in inside EC2 machine, which is saying that EC2 user @ IP 172.31.24.12. So you can see the command prompt. You have successfully logged in inside EC2. This is the private IP of the machine. You can cross check. I can show you. This 172.31.24.12 is the private IP. Go back and check. The private IP, you can cross check it. This is 172.31.24.12. And this is what the private IP it is showing. So you have successfully logged in inside EC2. This is what you can do remote login. So after you successfully remote login, you can install your application. So what we can do, you have the EC2 script, right? Here. First of all, you will all copy this particular command. Yum install -y httpd. You can type yum install -y httpd and enter. So it gives you error that this command has to be run with super user privilege. Did you get the error like this? Super user privilege? Because you are EC2 user of Linux. In Linux, there are user-based system. So for your Linux OS, you are EC2 user. They want you to become a super user. So for that purpose, you have to type sudo su. Sudo space su. You need to type sudo, sudo space su and enter. Then you see you got a super user access. So what you will do now, you will again type yum install httpd. Yum install -y httpd. This is the command you can copy from your EC2 script. You can see here this command yum install -y httpd. So once you do this, it will start installing httpd server on your EC2 machine. Finally, you get complete message in the bottom. Now you will take next command systemctl start httpd. Systemctl start httpd. You can see command number 3 or 4, I think. This one, systemctl start httpd. Then systemctl enable httpd. Take the last command and run this command here. Echo hello world. Get the public IP of the machine and check now. I can see my index.html is running successfully. Simply you have to execute 4 commands which are given in the user data script. These 4 commands one by one you have to execute. And you can check public IP. You will see that your second machine is having that index.html running. So this is the way we can create one EC2 machine and we can do application installation by 2 methods. One is user data script and second is remote login. I hope you understand and enjoyed these demos.
Cloud computing services vary greatly. They all have some basic qualities and benefits in common, and they can be classified into a few basic cloud service kinds. Hello everyone, I'm Shamli and I welcome you all to this new video of Simplilearn on cloud computing services. Let me give you an overview of the concepts you are going to go through in this video. First, we will go through what is cloud computing. Then, we will have an introduction to cloud computing services, followed by the types of cloud computing services. And at the end, we will look into the features and benefits of cloud computing services. So let's not waste any more time and get started with the video. So what is cloud computing? Cloud computing is the distribution of cloud computing services via the internet, including servers, storage, databases, networking, software, analytics, intelligence to provide faster innovation, more flexible resources, and economies of scale. You usually only pay for the cloud services you use, which helps you cut costs, run your infrastructure more efficiently, and scale as your business grows. Now that we know what cloud computing is, let's proceed with understanding cloud computing services. Cloud computing services provide users with a variety of capabilities, including email, storage, backup, data retrieval, app creation, testing, data analysis, audio-video streaming, software on demand, regardless of the type of service. Although cloud computing is still a relatively new technology, it is now being used by a wide range of organizations, including large enterprises, small businesses, non-profit government agencies, and even individual consumers. So, not all clouds are created equal, and not every sort of cloud computing is appropriate for every situation. A variety of models, varieties, and services have evolved to assist you find the best option for your needs. To begin, one must decide on the type of cloud deployment or cloud computing architecture that will be used to implement your cloud services. Cloud services can be deployed in 3 different ways: public cloud, private cloud, or hybrid cloud. Now let's dive down deeper into cloud computing services and explore its type in more detail. Cloud computing, unlike a microprocessor, is not a single piece of technology. Rather, it's a system made up of 3 services: infrastructure as a service, platform as a service, and software as a service. So let's have a better understanding of each, starting with infrastructure as a service. So what is infrastructure as a service? It is a type of cloud computing that uses the internet to provide virtualized computing resources. The cloud provider controls IT infrastructures such as storage, server, and networking resources, and also offers them to subscribe companies via virtual machines, accessible over the internet in the IaaS model. For businesses, it can provide numerous advantages, including the ability to make tasks faster, easier, more flexible, and less expensive. Now, let's have a look at the working of IaaS. Users connect to resources and services across a wide area network, such as the internet, and then use the cloud provider's services to complete the application stack. The user can, for example, log into the infrastructure as a service platform to build virtual machines, install operating systems in each VM, deploy middleware such as databases, create storage buckets for workloads and backups, and install the enterprise workload onto that virtual machine. Customers can then track cost, monitor performance, balance network traffic, solve application difficulties, and manage disaster recovery using the provider's service. So moving ahead, let's go through its advantages and disadvantages. Advantages. Organizations select infrastructure as a service because operating a workload without having to buy, manage, and support the underlying infrastructure is frequently easier, faster, and more cost-effective. A company can rent or lease infrastructure from another company using infrastructure as a service. For workloads that are transitory, experimental, or change abruptly, it is an effective cloud service paradigm. For example, if a company is creating a new software product, hiring an IaaS provider to host and test the application may be more cost effective. Once the new software has been thoroughly tested and refined, the company can move it away from the IaaS environment and into a more traditional in-house deployment. If the expenses of a long-term commitment are lower, the organization could commit the piece of software to a long-term IaaS deployment. Now, disadvantages. Billing can be a challenge for some firms. Despite its flexible pay-as-you-go model, cloud invoicing is quite detailed, and it is broken down to reflect specific service usage. When evaluating the invoices for each resource and service involved in application deployment, users frequently experience sticker shock or discover expenses that are greater than expected. Another issue it faces is lack of insight because its providers own the infrastructure. The configuration and performance of that infrastructure are rarely transparent to its consumers. Users may find it more difficult to operate and monitor systems due to the lack of transparency. Users of infrastructure as a service are also concerned about service availability and reliability. The supplier has a big influence on the workload's availability and performance. The workloads of users will be impacted if a provider has network constraint or any other type of internal or external outage. Furthermore, because it is a multi-tenant design, the problem of noisy neighbors might have an adverse effect on users' workloads. So now these are the top infrastructure as a service providers. Linode is a privately held cloud hosting firm based in the United States that offers virtual private servers. HostWinds, web hosting, cloud hosting, and dedicated server options are all available from HostWinds. Microsoft Azure is a cloud computing service operated by Microsoft for application management via Microsoft Managed Data Centers. DigitalOcean offers developers cloud service that make it easy to deploy and grow programs that run on several machines at the same time. Alibaba Cloud is a cloud computing firm that serves online businesses as well as Alibaba's own e-commerce ecosystem. So the second service is platform as a service. What is platform as a service? Platform as a service products which are geared towards software development teams include computing and storage infrastructure, as well as development platform layer that includes web servers, database management systems, and software development kits for multiple programming languages. Working of platform as a service. For software development, it does not replace an organization's complete IT infrastructure. It's made possible by the hosted infrastructure of a cloud service provider. A web browser is the most common way for users to access the offerings. Platform as a service such as application hosting and Java development can be supplied via public, private, or hybrid clouds. So now let's look into the advantages and disadvantages. Advantages. The main advantage of platform as a service for users is its simplicity and convenience. Much of the infrastructure and other IT services will be provided by the platform as a service provider, which users can access from anywhere via a web browser. The flexibility to pay on a per-use basis allows businesses to forego the capital costs associated with on-premises gear and software. Many platform as a service solutions are aimed towards software developers. These platform provider computation and storage infrastructures, as well as text editing, version management, compilation, and testing capabilities to assist developers in swiftly and efficiently developing new software. Coming to the disadvantages, platform as a service, on the other hand, can cause issues with service availability and resilience. Customers may suffer as a result of a service outage or other infrastructure interruption, which might result in costly productivity losses. Its suppliers, on the other hand, will typically deliver reasonably high uptimes. Another widespread problem is vendor lock-in, which occurs when users are unable to simply transition many of their services and data from one platform as a service solution to another. When choosing a provider, users must consider the business risk of service outages and vendor lock-in. Internal changes to a platform as a service product could also be a problem. The impact on users might be tough and disruptive. If a platform as a service provider ceases supporting a programming language or chooses to use a different set of development tools. So let's have a look at the top platform as a service provider. IBM Cloud Computing refers to a set of cloud computing services for businesses provided by IBM, a technology corporation. Red Hat is a collection of tightly integrated Red Hat technologies for building cloud infrastructure and developing cloud-native apps on premises. Elastic Beanstalk, AWS Elastic Beanstalk, is an Amazon Web Services application deployment orchestration solution. Salesforce offers CRM services as well as enterprise applications for customer service, marketing, automation, analytics, and application development. And Software AG Cloud is an open and independent cloud platform that serves as your one-stop shop for all software AG has to offer in the cloud. Now coming to the next service, which is software as a service. So what is software as a service? Customer relationship management, or CRM, marketing automation, and business analytics are just a few of the application level services offered by software as a service companies. So how does it work? The provider gives consumers network-based access to a single copy of an application that the provider designed expressly for software as a service distribution in the software on demand model. The source code for the program is the same for all clients, and new features or functionalities are rolled out to all the users at the same time. The data of each model's customer may be stored locally in the cloud or both locally in the cloud, depending on the service level agreement. Coming to its advantages, customers subscribe to a software as a service solution rather than buying and installing software or additional gear to support it. Many firms can now budget more effectively and predictably by converting costs to recurrent operating expenses. You can also cancel software as a service subscriptions at any time to avoid incurring recurring fees. Its systems are frequently customizable and can be connected with other corporate applications, particularly when using software for the same vendor. Vertical scalability is a feature of cloud services like software as a service, which allows clients to access more or fewer services or features on demand. Disadvantages of software as a service. When providers endure service delays, impose undesirable modifications to service offerings, or suffer a security breach, all of these things can have a significant impact on customers' ability to use the software as a service offering. Customers should be aware of their software as a service provider's SLA and ensure that it is followed. If the provider adopts a new version of an application, it will roll it out to all of its clients, whether or not they want it. This may need the organization allocating additional training time and resources. Switching vendors can be tough, as it is with any cloud service provider. customers must migrate massive volumes of data when switching vendors. Furthermore, some vendors use technologies and data types which can make transferring client data between cloud providers even more difficult. So coming to the top companies that provide software as a service, Adobe is a collection of Adobe incorporation programs and services that provide user with access to software for graphic design, video editing, web development, and photography, as well as a set of mobile apps and certain optional cloud services. SAP is a platform as a service designed by SAP SE for developing new applications and enhancing existing ones in a secure cloud computing environment managed by SAP. Google Cloud. Google Cloud Platform is a set of cloud computing services provided by Google that run on the same infrastructure as Google's internal products, such as Google Search, Gmail, Drive, and YouTube. Freshworks Cloud Platform allows users to manage their identities and access across all of their Freshworks products. And Atlassian, advanced features such as an 99.9% uptime SLA, unlimited storage, and premium support provide teams the confidence to scale reliably. Now that we have all the in-depth information about different types of cloud computing services, let's move ahead and explore its benefits and features, which makes it so popular and convenient. First, the supplier hosts and maintains the site in their own facility. The cloud hosting provider acquires, hosts, and maintains the necessary hardware and software. Users avoid the construction expenditures and maintenance problem that would be incurred if the service was established on-premise. Second, self-service using a web-based interface. Through a web interface, service users can initiate certain service functions as well as increase or reduce their service consumption level with little or no intervention from the service provider. Third is, you must pay to utilize the facility. Users of the service only pay for the services they use. When compared to the typical method of building on-site IT capacities targeted for the highest usage situations and then having that capacity to go unused for the most of the time. This can result in significant cost savings. And the fourth one is scalability that comes close to being infinite. Cloud computing service providers usually have the infrastructure in place to deliver their services at a large scale. That means that cloud service consumers can readily accommodate business expansion or periodic surges in service usage. Well, this is all about cloud computing services.
Hello everybody, welcome to Simplilearn's AWS S3 tutorial for beginners. My name is Kent, and today I'm going to be covering these following points. I'm going to be covering what is cloud computing. I'm going to be showcasing what AWS is in terms of cloud computing, and I'm also going to be covering the core fundamental service of the Simple Storage service, which is a object storage service. We're going to be covering the benefits of the Simple Storage service, better known as S3, what objects and buckets are, and we're going to be seeing how things are working in the background and implementing that in terms of lab assisted demonstrations in order for you to see what those features of S3 are. And then we'll perform a wrap up of the material we've done in a conclusion. So let's get started. What is cloud computing? So here is a definition of cloud computing, but I'm going to paraphrase it. Cloud computing is nothing more than you gaining access to infrastructure through web services with a pay-as-you-go model. Now, this is a very, very different model than we're traditionally involved in on an on-prem data center. So when I mean on-prem, I'm saying on-premise. Okay, so you'll hear that a lot, on-prem. Now, when we are on on-premise data center, we have to provision lots of infrastructure even before we get started with deploying any type of application, whether it be a mobile application, a web application, etc., etc. So every application needs some sort of underlying infrastructure, whether that be bare bone servers, databases. They're obviously going to be needing some types of storage, etc., etc. So all this is something that we have to kind of fight against in order just to get started with deploying our application. So this takes usually, traditionally, depending on the size of the company, about 3 months to set up. So what if we could leverage all this infrastructure as a service, and just through some API call, that's what the web services is all about, we could provision a server or we could provision a database within minutes and then deploy any type of application that we want to on top of that stack, and also take advantage of any storage that we may want. We may want object level storage, which is what we're going to cover. We may want an elastic file system, right? So there are different types of storages that we're eventually going to look at as you go down your learning path with Simplilearn. So cloud computing is really about provisioning of all these kinds of services, but not only at the infrastructure level. We're going to see how we could move up the stack and get entire platforms as a service, or even softwares as a service. So what is AWS? Well, AWS is really a cloud computing platform that will offer us many services through these API calls. Some are, again, just bare infrastructure like a service. Other can be a service as a software, for example, email. So here we have an example of the public data storage. This is S3, the simple storage service icon that you're going to see over and over again. This is a representation of an actual bucket in S3. So this will become more clear as we continue the slide deck and actually reinforce this with some hands-on lab. But as you can imagine, you may want to provision a private software-defined network in the cloud. And so we can do that in AWS. We can provide load balancing. We could provide scalability in terms of auto scaling groups that will respond to increased demand as your application, let's say, becomes more popular. You want that infrastructure to grow elastically. So doing this on premise is traditionally not only extremely expensive and thus prohibitive, but very difficult to implement physically speaking as well. So by going with a cloud provider like AWS, we can severely reduce the expense and the complexity of setting all of this up, because we're trading capital expense for variable expense. So capital expense is about you procuring all the hardware that you need beforehand and the budget being approved before even getting that hardware in through your door, right? And then you have to configure it. So there's that complexity factor. Whereas if you're doing this through AWS, you can within minutes just provision all of that very quickly. So you're also not paying for everything all up front. You're paying this with a pay as you go model. So very different. We're now removing what's called undifferentiated lifting, which is everybody has to do the same thing, but it's not really bringing any value to their end product. We all have to buy servers and configure them and scale them, etc., etc. So if we remove that element and have AWS handle that, we can concentrate on our business, which is our application, and improving that application and responding more to our clients' requests. We can be more agile, more flexible. So all of this leads to these points that we see here on this slide. Much easier to use, much easier to get our application to market. We're actually going to be leveraging the physical security that AWS implements for us. They have data centers all over the world that we're going to plug into, and that physical security is already implemented for us. There are varying levels of security that we're going to get into through our AWS journey. but right off the bat, you know that you have physical security. Of course, we're going to be talking about storage in this demonstration or in this slide deck over here. But the nice thing is we only pay for what we use. So that's that variable expense that I was talking about that we've traded for capital expense. We can easily set up databases. We can easily automate our backups and have those backups stored in the cloud through that S3 storage that we're going to get into. Okay, so lots of benefits of going through AWS here. And it's also comprehensive and simple to use. Comprehensive meaning that there are hundreds and hundreds of services. It's going to be actually quite time consuming for you to just know what each service does in general, but you'll get there through your journey. It's all about sticking with it and learning something new every day, which is what Simplilearn is all about. Over here, we have infrastructure as a service, platform as a service, and software as a service. So these are three different types of distinctions we have in the cloud industry to basically cover what's going on here on the right-hand side. So on-premise, you're traditionally involved in everything from networking, which is you, for example, buying the switches, the routers, the cabling, everything all the way up the stack to deploying your application, and you see everything in between there. Okay, so this is a very time-consuming job. Not only that, but it costs a lot of money because you have to buy all these machines up front, and you have to have the individuals with the right knowledge to maintain all of this stack. All right, so different individuals in different teams maintaining this whole on-premise data center. You may also have different data centers deployed globally. So you can imagine the cost overhead of this. So everything in green is basically you're managing it. Now we can offset that and ask AWS to handle part of this stack over here. So on this second column over here, we see infrastructure as a service, which basically says, AWS, I want you to handle all the networking, my software-defined network. I want you to handle my storage, elasticity. I want you to handle my compute power, my virtual machines. I want you to handle even administrating those machines at a physical layer as well. And I want you to physically secure them. So this will allow you more time to focus on all the green up here. Of course, we can move up the stack and say, I even want AWS to take on more responsibility. And that would be more of a platform as a service where AWS would also install and maintain the operating system for you. So you can imagine things like new versions of operating systems, security patches, maintenance patches, all of the like, and any middleware or runtime that you have on top of that. Think of something like the Java virtual machine, perhaps, that needs to be updated. Now, you wouldn't be responsible for maintaining all of what's in orange over here. You would only be responsible for deploying your application and making sure that your data is saved and secured, right? So again, platform as a service is a more hands-off approach. So think of it as you wanted to set up a CI/CD deployment environment for your development team, and you wanted to be very involved in just handling your application code and making sure that it was properly compiled, built, tested, and deployed, right? Well, this could be implemented as a platform as a service. Or you could take your code as a zip file and give it to AWS's service called Beanstalk, which would automatically deploy your code and make sure that it's highly available, scalable, and fault tolerant across all of the orange stack over here, right? So more of a hands-off approach. Of course, we can go all the way up the stack and tell AWS to take care of everything for us and just ask for a service, much like a utility, like electricity or water. We might want to say, we just want an email software service, and we're not really concerned about how the underlying operating system or servers or network are configured for that. We just want to use the software as a service. We don't want to administrate anything else. We just want to be sort of like an end user to it. So AWS will manage everything underneath the hood. So there are varying types of services. You pick and choose whichever one makes more sense for you and your team. So what is S3? S3 stands for Simple Storage Service, and it is an object storage service in Amazon. What this means is that it doesn't matter what kind of file you upload to S3, it will be treated as an abstraction, meaning an object. So you can upload a PDF file, you can upload a JPEG file, you can upload a database backup. It doesn't really matter. All that is abstracted away by the use of storing it within an object. We're going to talk more about what composes an object, but by doing so, what happens is S3 allows us to have industry leading scalability. So it doesn't matter if you're going to make a request for that database backup, let's say that object, 5 times or 10,000 times. That request, that demand will scale. The underlying infrastructure that is implemented behind the scenes is handled for you. So in a sense, it's kind of like a serverless service, a storage service where you're not implicated in handling anything underneath the covers. You're just uploading your objects and accessing them later on. In terms of data availability, very powerful as well, because it takes those objects and will replicate them across at least 3 availability zones. Of course, these availability zones have 1 or more data centers attached to them. So you have lots and lots of copies of your objects distributed globally, or at least at a regional, in a regional area. You can do this as well globally if you enable global replication. And you will see that your level of durability will skyrocket, and you're just not going to worry about losing an S3 object. Data security, well, we can encrypt our data at rest, our objects at rest. We can encrypt it in transit. We can also come up with security policies at the bucket level, which we're going to talk about what a bucket is very soon. These are going to be implemented through what's called IAM policies, and you're going to be able to control who or what has access to your objects. And of course, because everything is handled underneath the covers, all the servers, all the storage nodes are cloud optimized for the best possible performance. So let's continue on our journey on what is S3. We're going to take a look at what is a bucket and what is an object. As you can see here, you have inside this bucket, which is a logical container for an unlimited amount of objects. You could have objects of different shapes and sizes. Like I said, you could have pictures, database backups, etc. So this is what's being represented here by different shapes. And you can think of a bucket really as almost like a folder where objects or files are placed within them. So there are many ways for us to place objects within a bucket. We can do this through the AWS console, which I'll be showing you very shortly. We can do this via the command line interface, or we can do this through a software development kit. At the end of the day, all those 3 options go through an API, right? So it's all about picking the right method that is best suited for whatever kind of end user or application that needs access to these buckets and to these objects. Now, once you've got the data or objects within this bucket, you can control pretty much how the data is accessed, how it's stored, whether you want it to be encrypted, and how it's even managed. So you can have organizations that have specific compliance needs. For example, any objects that are placed in, or perhaps some PDFs, are not to be modified or not to be touched for 90 days. Let's say we can imply object locks if we want to. We can imply security guards. We can also, for example, record all API actions that try to access, to list, to delete any kind of API operations on those objects at the bucket level or on the object level. We can record if that is some sort of organizational compliance need for auditing or for whatever internal auditing reason that you may have. So continuing on here, you can see that there are many organizations that use S3. One in point is Amazon itself. S3 is so popular and so durable that Amazon internally uses it to store its own data. You're guaranteed, almost that you're not going to lose any object in there because it has what we call 11 nines durability. Now, 11 nines durability is really an extreme amount of durability where it's mathematically almost impossible for you to lose an object once you place it in S3. You're in fact more liable to get hit by a meteorite than you are to lose an object in S3, statistically speaking, which is a pretty incredible statistic, but it's true. So if we continue here with the benefits of S3, some of these I've already described, but let's talk about the full picture here. We see the performance, scalability, availability, and durability of S3 are really first class in the industry. Again, durability, we were talking about that 11.9. So what that really means is 99.9999 in total. If you count all the nines, that's 11 of those nines. So most durable in the industry by far. And again, because everything is handled underneath the covers, it's a serverless service. They ensure the scalability and availability and the performance of the inner workings of that object level storage. Now, cost is of course always important, and S3 really shows up here with first class support again for cost. It's got very, very low cost. We can have object level storage for let's say a terabyte of object level storage for as little as $1 a month. So again, it will depend on the kind of storage class. We're going to have a discussion on different types of storage classes that we might want to transition or move over our objects from one storage class to the next, depending on how frequently accessed that data is. As you know, data over time seems to get less and less accessed as your needs shift from one place to another. We're going to talk about that coming up very soon. So we're going to want to really focus on that to reduce our end of the month costs for storage with S3. Of course, security is always at the forefront, and we want to make sure that we either simply secure by encrypting everything right off the bat, either at rest, in transit, or we want to put an object lock or just maintain security at the bucket level, maintaining, let's say, who or what has access to that data. Because by default, no one has access to the data unless we open up the door. And also we want to make sure that we don't give public access to our bucket for obvious reasons of giving away important information by mistake. So AWS makes it extremely difficult for you to accidentally do this. And I'm going to show this in a demonstration lab coming up very soon. And we can also query in place, which is very interesting. So you can imagine you putting, let's say, a file that's in CSV format or a JSON format or Parquet format, some sort of structured format or semi-structured format in S3, and you can actually use SQL queries on the spot to filter that data in place at the bucket level. You can also have other services that may want to extract some business intelligence from that data in your S3 bucket directly as well. So some other more advanced querying operations can take place at the S3 level. So this you will learn during your journey with Simplilearn as you're covering all the AWS technology stacks. And here, the most widely used storage cloud service in the industry. Because of all the points that we just covered, it really is the #1 storage or object level storage solution in the industry. Let's now take a look at objects and buckets in S3. So the objects are really the fundamental entities that are stored in S3, or the lowest common denominator, which means that we're not really interested and what kind of data is within the object at the layer of S3, because S3 doesn't have direct access to the data within an object. Like I said before, it's an abstraction of the data. So we don't know if it's a cat picture, if it's a backup of your database. It's just treated as a fundamental entity, aka the object. Now, every object is associated with metadata, so data about itself, things like what's the name of the object, what's the size, the time and date that the object was uploaded. Things of that nature are categorized as metadata. So S3 does have direct access to that. Now, the data within that object, of course, is accessible by other services. So it's not that once you've uploaded it, you've totally lost the data and it's only can be treated as an object. It's just that at this layer, it's simply just assigned metadata and a version ID, a unique version ID. And if you re-upload the exact same object a second or third time to S3, it will have its own version ID number. So a new unique version ID number will be generated. So really what buckets are their logical containers to store those objects. So of course, at an extremely high level, a bucket would be like your root file system, if you want to think about it like that. But that doesn't mean you can't go into this bucket and create separate folders. Now, when you create separate folders in a bucket, because you might want to logically organize all your objects, you might be fooled by the fact that you think this is a hierarchical storage system, when in fact it is not. And I'll talk about that in a second. So you cannot store an object without first storing it into a bucket. So of course, the first step would be for us to create a bucket and then upload objects within that bucket. So an object cannot exist without its container or its bucket. So there's no Windows Explorer view like we're used to in an operating system, because this is not a hierarchical view. No matter if you create folders within folders within folders, in fact, S3's internal architecture is a flat hierarchy. What we do instead is we assign prefixes, which are treated as folders in order to logically organize our objects within our buckets. And I'm going to showcase a prefix in one of the demonstrations coming up very soon. So when you create, or when you're working with S3, first of all, you're working at a regional level. You're going to have to pick a region. For example, you might pick US East 1 region or US East 2 region, and the bucket that you're going to be creating will be replicated across several availability zones, but within that region. Also, that data, those objects, can be accessed globally because S3 uses the HTTP protocol. HTTP protocol is very permissive. Everybody knows how to administrate it and work with it. So we just need to give access to that object in terms of a permission policy and give it the proper URL, or give whoever needs access to it the proper URL, and they can access that via HTTP globally. So first, when you're creating a bucket, you have to select the region, and the object will live within that region, but that doesn't mean that it still can't be accessed globally. So let's now take a minute, go over to the AWS console, and actually let me showcase how to create objects and buckets. So for our first lab, we're going to be going and creating an S3 bucket and uploading an object to it. So we first have to log into the AWS console, which we have up here in the address bar. Let's click on either create free account if it's your very first time, or as is in my case, already have an account, and we're going to sign in here. You're going to have to pass in your IAM username, password, and your account ID, of course. Once you've logged in, you can search for the simple storage service S3 either by coming up here in the search box and typing S3, and you'll find it there. That's probably the easiest way. Or if you want, you can take a look at all the services and it'll be under storage over here, the first one. Okay. So pick whatever method you see best for yourself. Once we're here, we want to create our first bucket. Now I've already have a couple of buckets here, so we're going to go on and create a new bucket. The very first thing is you have to specify a bucket name. Now this bucket name has to be globally unique. If you take a look here at the region that we're in, it doesn't actually select a specific region. It selects the global option, which means that this bucket will become globally accessible. So that is why it needs to have a unique name, much like a DNS name has to be unique for your website, right? So I'm going to come up here and pick a name that I think is going to be unique. So I'm going to say Simplilearn S3 Demo. All right, let's take a look at if that's going to work out. Of course, we have to pick a region, but it is globally accessible. So you either pick a region that's closest to your end users, or in our case, since we're just doing a demonstration, we can do whichever is closer to us right now. Okay, and we're going to skip these options for now. We're going to come back to them later on. We're just going to create the bucket. Now hopefully that was a unique name and allowed me to create that, and it looks like it did. So if I scroll down, you can see that it clearly got created over here. Now we're going to click on that and we're going to start uploading objects to this bucket. So let me click on the upload button, and you can either select one or more files, or you can select an entire folder. So I'm going to just go and select a specific cat picture that I have here. Okay, and again, we'll go through some of those other options later on, and we'll just click upload. Now this should take no time at all because of the fact that it's a very small object or a file that's being uploaded. So it has succeeded. We can close this up. And we see now clearly that the object is in our bucket. If we go to properties, we can see the metadata associated with this bucket. We can see the region that it's in. We can see the ARN, which is the Amazon resource name, which uniquely identifies this resource, this bucket, across the globe. So if ever you needed to reference this, let's say in an IAM policy or whatever other service needed to communicate with S3, you would need this ARN. It's a very important piece of information. And of course, we have the creation date. Some high level metadata. So objects, as we have covered already, consist of not only the data itself, but the metadata. So there's lots of metadata, and there's a lot of other features that we can go here and enable very easily. And this will be the basis of the future demonstrations that I'm going to do. All right. So just to recap what we just did, we created a unique bucket, gave it a name of Simplilearn S3 Demo, and uploaded our first object to it. So let's now take a look at the inner workings of the Amazon S3. When we upload an object into a bucket, we have to select which one of these storage classes the object will reside in. So you see I have 6 storage classes here at the bottom, and each have their own characteristics that we're going to get into. By default, if you don't specify anything, it'll get placed in what's called the S3 standard storage class, which is the most expensive out of all these storage classes. Once your object gets colder, and what I mean by colder is your access patterns diminish, meaning that you're accessing that file less and less over the course of time, so it gets colder, you will transition that object from one tier to the next, all the way to, for example, S3 Deep Archive. So again, Deep Archive signifies extremely cold, so maybe you're only referencing this data once a year, once every couple of years. And so you want to have the cheapest possible storage available. So right now you can get about 1 terabyte of storage per month for about $1 a month with S3 Glacier Deep Archive. So you are going to be very interested in knowing how to transition from one or more of these storage classes over time in order to save on your storage costs. That's really why we're doing this. So let's go through some of these storage classes. By default, like I said, whenever you upload an object, you automatically get placed into the standard storage class. So any files that you're working on frequently, daily, this is the best fit for it. You've got the highest level of accessibility and durability as well. Not that the others don't have the same level of durability. However, we'll see how when you transition from one storage tier to the next, some characteristics do change in order for you to save on some costs. We're going to go through some of those. Now, this would be considered hot data, right? Data that's used all the time, maybe just by you, maybe by everybody, right? So that's the perfect place to place it in the standard storage class. Now, over time, like I said, you may find yourself working less and less, perhaps on a document that was due by the end of the month. That document was submitted, and then afterwards, you don't work on that document anymore. Perhaps you're only working on revisions based on feedback from your colleagues that are asking you to make some corrections or some amendments. And so only those corrections or amendments come in perhaps once a month. And so in that case, you might find yourself finding a justification for moving that document from the standard tier to the standard IA or infrequently accessed tier. Maybe any objects not modified for more than 30 days are a good fit for that. And that's really the criteria for IA, inactive access, is that S3 or AWS itself recommends to only put objects in there if they haven't been accessed for at least 30 days. So you get a price reduction, a rebate for putting objects that are not accessed frequently in here. Of course, if you remove objects, let's say before the 30-day limit, then you are charged a surcharge for retrieving an object that you said was infrequently accessed, but it really was not. So bear that in mind. If you're going to place objects in infrequent access, be somewhat reasonably assured that you're not going to be going there and accessing them. You can still access those files, no problem, just as quickly. They have the same level of accessibility and durability. However, like I said, anything less than 30 days, you'll get a price ding on that. If you want to have long-term storage, we're talking about Amazon Glacier. So this is more anything over 90 days that hasn't been modified, or 180 days. There's two subcategories of Amazon Glacier that we're going to get into. And this is the cheapest storage by far. And Amazon Glacier doesn't really operate through the AWS console as the same as the standard and the infrequent access. You can't really upload objects to Glacier via the console in the browser. You can only do so, let's say, through the command line interface or through an SDK. The only thing you can do on the web console with Glacier is actually create what's called a vault, which is a logical container for your archives. But then after that, you have to go through the CLI or the SDK to do the rest of the work there. If we continue on, there's some gray areas between the S3 standard and the Glacier. One is the one zone infrequently accessed storage class. So if we go back to the regular standard and IA storage class, all of these objects are stored across a minimum of 3 availability zones. If you want a further price reduction, you can store your objects in a one zone IA storage class, which means that instead of taking that object and replicating it across 3 or more availability zones, it will only store it in a single availability zone, therefore reducing the level of availability that you have to that object. So in this case here, if that single availability zone would go down, for example, you would not have access to that object. Once it would come back up, of course, you would. The other thing is if there was an immense catastrophe where the actual availability zone was destroyed, well, of course, then your object is also gone. So if that's something that doesn't worry you because you have already many copies of this object maybe lying around on premise, then this is a good option for you because it's data that you're willing to lose or lose access to for short periods of time if ever that single availability zone goes down. So it's about an extra 20% off the price from already the normal IA standard price. There is another one called the standard reduced redundancy storage. This one is kind of getting phased out as we speak because the same price for this storage class is about the same amount you're going to pay for the normal IA standard class. What this does is, again, is a good fit for your objects that you're not really worried about losing if there is some sort of catastrophe that happens in an availability zone. There's less copies of it that are stored, and so if that data center and that availability zone goes down, then you lose your object. So of course it offered at the time the highest price reduction possible, but now the difference between this one and the normal IA standard storage class is so small in terms of price that you're probably not going to migrate to or navigate to this storage class. But it is still there in the documentation, and it may very well come up still in the certification exam, so at least be aware of that. Let's now take a look at some individual features of S3, starting off with lifecycle management. So lifecycle management is very interesting because it allows us to come up with a predefined rule that will help us automate the transitioning of objects from one storage class to another without us having to manually copy things over. Of course, you could imagine how time consuming that would be if we had to do this manually. So we're going to see this very soon in a lab. However, let me discuss how this works. So once it's basically a graphical user interface. It's very, very simple to use once you come up with these lifecycle management rules. But you're going to define two things. You're going to define the transition action and the expiration action. So the transition action is going to be something like, well, I want to transition an object from, maybe it's all objects, or maybe it's just a specific type of object in a folder, example, that has a specific prefix, from one storage class, let's say standard, to standard inactive or infrequent access. Maybe only after 45 days, after at least a minimum of 30 days, like we spoke of before. And then maybe after 90 days, you want to transition the objects in IA to right away Glacier Deep Archive, or 180 days. You come up with whatever combination you see fit. Okay, it doesn't have to be sequential from S3 to IA to one zone, etc., because like we discussed before, it depends what kind of objects that you're interested in putting in one zone, objects that you don't really mind losing if that one availability zone goes down. So you're going to be deciding those rules. It ends up that this even is not a simple task because you have to monitor your usage patterns to see which data is hot, which data is cold, and what's the best kind of lifecycle management to implement to reap the benefits of the lowest cost. So you have to put somebody on this job and make the best informed decisions based on your access patterns, and that is something that you need to consistently monitor. So what we can do is we can instead opt for something called S3 Intelligent Tiering, which basically analyzes your workload using machine learning algorithms. And after about a good 30 days of analyzing your access patterns, we'll automatically be able to transition your objects from S3 standard to S3 standard infrequent access. Okay, it doesn't go past the IA one, it doesn't go after the Glacier and whatnot. Okay, so it can then offer you that at a reduced price overhead. So there is a monitoring fee that is introduced in order to implement this feature. It's a very nominal, very, very low monitoring fee. And the nice thing is if ever you take out an object out of the infrequent access before the 30-day limit, as we spoke of before, you will not be charged an overhead charge because of that. Why? Because you're using the intelligent tiering. You're already paying an overhead for the monitoring fee. So at least in that sense, the intelligent tiering will take the object out of IA and put it back into the S3 standard class if you need access to it before the 30 days. And in that case, you won't be charged that overhead. So that is something that is very good to do in order not to have to put somebody on that job. So yes, you're paying a little bit of overhead for that monitoring fee, but at the other side of the spectrum, you're not investing in somebody working many hours to monitor and put into place a system to monitor your data access patterns. So let's take a look at how to do this right now. Let's implement our own lifecycle management rules. So let's now create a lifecycle rule inside our bucket. First off, we're going to need to go to the management tab in the bucket that we just created. And right on the top, you see right away, lifecycle rule. We're going to create lifecycle rule and we're going to name it. So I'm just going to say something very simple, like simply learn lifecycle rule. And we have the option of creating this rule for every single object in the bucket, or we can limit the scope to a certain type of file, perhaps with a prefix like, I could see one right now, something like logs. So anything that we categorize as a log file will transition from one storage tier to the next as per our instructions. We're doing this because we really want to save on costs, right? It's not so much of organizing what's your older data versus your newer data. It's more about reducing that storage cost as your objects get less and less used. So in this case, logs are a good fit because perhaps you're using your logs for the first 30 days, you're sifting through them, you're trying to get insights on them, but then you kind of move them out of the way because they become old data and you don't need them anymore. So we're going to see how we can transition them to another pricing tier, another storage tier. We could also do this with object tags, which is a very powerful feature. And in the lifecycle rules action, you have to at least pick one of these options. Now, since we haven't enabled versioning yet, what I'm going to do is just select transition the current version of the object between these storage classes. So as a reminder of what we already covered in the slides, our storage classes are right over here. So the one that's missing is obviously the default standard storage class, which all objects are placed in by default. So what we're going to say is this. We want our objects that are in the default standard storage class to go to the standard inactive access storage class after 30 days. And that'll give us a nice discount on those objects being stored. Then we want to add another transition. And let's say we want to transition them to Glacier after 90 days. And then as a big finale, we want to go to Glacier Deep Archive. You can see the rest are grayed out. Wouldn't make sense to go back. And maybe after 180 days, we want to go there. Okay. Now there's a little bit of a warning or a call to attention here. They're saying if you're going to store very small files into Glacier, not a great idea. There's an overhead in terms of metadata that's added, and also there's an additional cost associated with storing small files in Glacier. So we're just going to acknowledge that. Of course, for the demonstration, that's fine. In real life, you don't want to store very big tar files or zip files that had, one or more log files in there. Okay, that would bypass that surcharge that you would get. And over here, you have the timeline summary of everything we selected up above. So we have here after 30 days, the standard inactive access, after 90 days, Glacier, and after 180 days, Glacier Deep Archive. So let's go and create that rule. All right, so we see that the rule is already enabled, and at any time you could go back and disable this if ever you had a reason to do so. We can easily delete it as well, or view the details and edit it as well. So if we go back to our bucket, now what I've done is created that prefix with the /logs. Since we're not doing this from the command line, we're going to create a logs folder over here that will fit that prefix. So we're going to create logs, create folder. And now we're going to upload our, let's say, Apache log files in here. So we're going to upload one demonstration Apache log file that I've created with just one line in there. Of course, just for demonstration purposes. We're going to upload that. And now we have, we're going to just close that. And now we have our Apache log file in there. So what's going to happen, because we have that lifecycle rule in place, after 30 days, any file that has the logs prefix, or basically is placed inside this folder, will be transitioned as per that lifecycle rule policy that we just created. So congratulations, you just created your first S3 lifecycle rule policy. Let's now move over to bucket policies. So bucket policies are going to allow or deny access to not only the bucket itself, but the objects within those buckets to either specific users or other services that are inside the AWS network. Now, these policies fall under the category of IAM policy. So IAM stands for Identity and Access Management. And this is a whole other topic that deals with security at large. So there are no services in AWS which are allowed to access other services or data, for example, within S3, without you explicitly allowing it through these IAM policies. So one of the ways we do that is by attaching one of these policies, which are written in a JSON format. So it's a text file that we write. At the end of the day, that's the artifact, and that's a good thing because we can use that artifact and we can configuration control it in our source control and version it and put it alongside our source code. So when we deploy everything, it is part of our deployment package. So in this case here, we have several ways of doing this. We can use what's called the policy generator, which is a graphical user interface that allows us to simply click and point and populate certain text boxes, which will then generate that JSON document that will allow us to attach that to our S3 bucket. And that will determine, like I said, which users or services have access to whatever API actions are available for that resource. So we might say we want certain users to be able just to list the contents of this bucket, not necessarily be able to delete or upload new objects into that bucket. So you can get very fine-grained permissions based on the kind of actions you want to allow on this resource. So in order to really bring this home, let's go and perform our very own lab on this. Let's now see how to create an S3 bucket policy. Going back to our bucket, we're now going to go into permissions. So the whole point of coming up with a bucket policy is that we want to control who or what, the what being other services, have access to our bucket and our objects within our bucket. So there are several ways we can go about doing this. Let's edit a bucket policy. One, we can go and look at a whole bunch of pre-canned examples, which is a good thing to do. Two, we could actually go in here and code the JSON document ourselves, which is much more difficult, of course. So what we're going to do is we're going to look at a policy generator, which is really a form-based graphical user interface that allows us to generate, through the answers that we're going to give here, the JSON document for us. First question is, we got to select the policy type. Of course, we're dealing with S3, so it makes sense for us to create an S3 bucket policy. The two options available to us are allowing or denying access to our S3 bucket. Now, in this case here, we could get really fine-grained and specify certain kinds of services or certain kinds of users. But for the demonstration, we're just going to select star, which means anything or anybody can access this S3 bucket. All right. Now, depending on also the actions that we're going to allow. So in this case here, we can get very fine-grained, and we have all these checkboxes that we can check off to give access to certain kind of API action. So we can say we want to give access to, just deleting the bucket, which obviously is something very powerful, but you can get more fine grained. As you can see, you have more of the getters over here, and you have more of the listing and the putting new objects in there as well. So you can get very fine grained. Now, for demonstration purposes, we're going to say all actions. So this is a very broad and wide ranging permission, something that you really should think twice about before doing. We're basically saying we want to allow everybody and anything, any service, all API actions on this S3 bucket. So that's no small thing. We need to specify the Amazon resource name, the ARN of that bucket specifically. So what we're going to do is go back to our bucket, and you can see here the bucket ARN. Okay, so we're just going to copy this, paste it in this policy generator, and just say add statement. You can see here kind of a resume of what we just did, and we're going to say generate policy. And this is where it creates for us, and make this a little bit bigger for us, it creates that JSON document. So we're going to take this, we're going to copy it, and we're going to paste it into the generator. Okay. Now, of course, we could flip this and change this to a deny, right? Which would basically say we don't want anybody to have access, or anything, any other service to have access to this S3 bucket. We could even say /* to also encapsulate all the objects within that bucket. So if I save this right now, you have a very ironclad S3 bucket policy, which basically denies all access to this bucket and the objects within. Of course, this is on the other side of the spectrum, very, very secure. So we might want to, for example, host a static website through our S3 bucket. So in this case here, allowing access would make more sense, right? So if I save changes, you see that we get an error here saying that we don't have permissions to do this. And the reason for that is because it realizes that this is extremely permissive. So in order to give access to every single object within this bucket, as in the case that I was stating of a static website being hosted on your S3 bucket, it would be much better to also at first enable that option. So I'm just going to duplicate the tab here. And once you go back to the permissions tab, one of the first things that shows up is this block public access setting, right? Right now it's completely blocked, and that's what's stopping us from saving our policy. We would have to go in here, unblock it, and save it, right? And it's also kind of like a double clutch feature. You have to confirm that just so you don't do that by accident, right? So now what you've effectively done is you've really opened up the floodgates to have public access to this bucket. It's something that can't be accidentally done. It's kind of like having to perform these two actions before the public access can be granted. Now, historically, this was something that AWS was guilty of, was making it too easy to have public access. So now we have this double clutch. Now that this is enabled or turned off, we can now save our changes here successfully. And you could see here that now it's publicly accessible, which is a big red flag that perhaps this is not something that you're interested in doing. Now, if you're hosting a public website and you want everybody just to have read access to every single object in your bucket, yes, this is fine. However, please make sure that you pay very close attention to this type of access flagged over here on the console. So congratulations, you just got introduced to your first bucket policy, a permissive one, but at least now you know how to go through that graphical user interface through the policy generator and create them and paste them inside your S3 bucket policy pane. So let's continue on with data encryption. So any data that you place in S3 bucket can be encrypted at rest very easily using an AES 256 encryption key. So we can have server-side encryption. We could have AWS handle all the encryption for us, and the decryption will also be handled by AWS when we request our objects later on. But we could also have client-side encryption where we, the client that are uploading the object, have to be responsible for also passing over our own generated key that will eventually be used by AWS to then encrypt that object on the bucket side. Of course, once that happens, then the key is discarded, the client key is discarded, and you have to be very mindful that since you've decided to handle your own encryption, client-side encryption, that if ever you lose those keys, well, that data is not going to be recoverable in that bucket on the AWS network. So be very careful on that point. We can also have a very useful feature called versioning, which will allow you to have a history of all the changes of an object over time. So versioning sounds exactly how it's named. Every time you make a modification to a file and upload that new version to S3, it will have a brand new version ID associated with that. So over time, you get a sort of stack of a history of all the file changes over time. So you can see here at the bottom, you have an ID with all these ones, and then an ID with 121212. So eventually, if ever you wanted to revert back to a previous version, you could do so by accessing one of those previous versions. Of course, versioning is not an option that's enabled by default. You have to go ahead and enable that yourself. It is an extremely simple thing to do. And so there may be a situation where you already have objects within your buckets and you only then enable versioning. Well, versioning would only apply to the new objects that would get uploaded from the point that you enabled versioning. The objects that were there before that point will not get a specific version number attached. In fact, they will have a sort of null marker version number that will get attached to them. It's only after that you modify those objects later on and upload a new version that they will get their own version numbers. So right now, what we're going to be doing is a lab on actual versioning. So let's go ahead and do that right now. In this lab, we're going to see how to enable versioning in our buckets. Enable versioning is very easy. We're simply going to click on our bucket, go into properties, and there is going to be a bucket versioning section. We're going to click on edit and enable it. Once that's done, any new objects that are uploaded to that S3 bucket will now benefit from being tracked by a version number. So if you upload objects with the same file name after that, they'll each have a different version number. So you'll have version tracking, a history of the changes for that object. Let's actually go there and upload a new file. I'll upload one called index.html. So we're going to simulate a situation where we've decided we're going to use an S3 bucket as the source of our static website to deploy one. And in this index.html file, if you take a look right now, let's take a look at what's in there. You can see that we have welcome to my website and we're at version 2. Okay, so if I click on this file right now and I go to versions, I can clearly see that there's some version activity that's happening here. Okay, we have here at 1456, which is the latest one is on the top, the current version, we have a specific version ID. And then we have a sort of history of what's going on here. Now, I purposely enabled versioning before and then tried to delete versioning or disable versioning. But here's the thing with versioning. You cannot disable it fully once it's enabled. You can only suspend it. Right? Now, suspending means that whatever version numbers those objects had before you decided to suspend it will remain. So you can see I have an older version here that has an older version number. And at this point here, I decided to suspend versioning. And so what it does, instead of disabling the entire history, it puts what's called a delete marker. Okay. You could always roll back to that version if you want. Now, in the demonstration, when we started it together, I enabled it again. So you can see this is actually the brand new version number as we did it together, but you don't lose the history of previous versioning if ever you had suspended it before. So that's something to keep in mind, right? And it'll come up in the exam where they'll ask you, can you actually disable versioning once it's enabled? And the answer is no, you can only suspend it and your history is still maintained. Now, we have that version there, and let's say I come to this file and I want to upgrade this, I don't know, I say version 3, right? And now what's going to happen is if I click on this version, just as the current one with version 2, and I open this, we should see version 2, which is fine. That's expected. If we go back to our bucket and upload that new version file that has version 3 in there, the one I just modified, we should now see in that index.html file a brand new version that was created under the versions tab. And there you go, 1458, just 2 minutes after. You can see here we have a brand new version ID, right? And if I open this one, you can see version 3. So now you have a way to enable versioning very easily in your buckets. And you also have seen what happens when you want to suspend versioning, what happens to the history of those versions files before. Just to actually go back here to the properties where we enabled versioning in the first place, if I want to go back in here and disable it, like I said, you can't disable, you can only suspend. And that's where that delete marker gets placed, but all your previous versions retain their version ID. So don't forget that, because that will definitely be a question on your exam if you're interested in taking the certification exam. So congratulations, you just learned how to enable versioning. Let's move on to cross-region replication, or CRR as it is known. There will be many times when you find yourself with objects in a bucket and you want to share those objects with another bucket. Now that other bucket could be within the same account, could be within another account within the same region, or could be within a separate account in a different region. So there's varying levels of degree there. The good thing is all of those combinations are available. So CRR, if we're talking about cross-region replication, is really about replicating objects across regions. Something that is not enabled by default, because that will incur a replication charge because it's syncing objects across regions. Of course, you are spanning a very wide area network in that case, so there is a surcharge for that. Now, doing so is quite simple to do, but one of the things that we have to be mindful of is to give permissions for the source bucket, which has the originals, to allow for this copying of objects to the destination bucket. So if we're doing this across regions, of course, we would have to come up with IAM policies, and we would also have to exchange credentials in terms of IAM user credentials, in terms of account IDs and the such. We're going to be doing a demonstration in the same account, in the same region, but largely this would be the same steps if we were going to go cross region. So this is something you might find yourself doing if you want to share data with other entities in your company. Maybe you're a multinational and you want to have all your log files copied over to another bucket in another region for another team to analyze, to extract business insights from. Or it might just be that you want to aggregate data in a separate data lake in an S3 bucket in another region, or in like I said, it could be even in the same region or in the same account. So it's all about organizing, moving data around across objects, across these boundaries. And let's actually go through a demonstration and see how we can do CRR. let's now see how we can perform cross-region replication. We're going to take all the new objects that are going to be uploaded in the Simplilearn S3 demo bucket, and we're going to replicate them into a destination bucket. So what we're first going to do is create a new bucket, okay? And we'll just tack on the number 2 here. And this will be our destination bucket where all those objects will be replicated to. We're going to demonstrate this within the same account, but it's the exact same steps when doing this across regions. One of the requirements when performing cross-region replication is to enable versioning. So if you don't do this, you can do it at a later time, but it is necessary to enable it at some point in time before coming up with a cross-region replication rule. All right, so let me create that bucket. And now after the bucket is created, I want to go to the source bucket and I want to configure under the management tab here a replication rule. So I'm going to create a replication rule, call it Simplilearn rep rule. And I'm going to enable this right off the bat. The source bucket, of course, is the Simplilearn S3 demo. We could apply this to all objects in the bucket or perform a filter once again. Let's keep it simple this time and apply to all objects in the bucket. Of course, caveat here, this will only now apply to any new objects that are uploaded into this source bucket and not the ones that are already pre-existing there. Okay. Now, in terms of a destination bucket, we want to select the one we just created. So we can choose a bucket in this account, or if we really want to go cross region or another account in another region, we could specify this and put in the account ID and the bucket name in that other account. So we're going to stay in the same account. We're going to browse and select the newly created bucket. And we're also going to need permissions for the source bucket to dump those objects into the destination bucket. So we can either create the role ahead of time or we can ask this user interface to create a new role for us. So we'll opt for that and we'll skip these additional features over here that we're not going to talk about in this demonstration. We're just going to save this. So that will create our replication rule that is automatically enabled for us right now. So let's take a look at the overview here. You can see it's been enabled. Just to double check, the destination bucket is the demo 2. We're talking about the same region. And again, here we could opt for additional parameters like different storage classes in the destination bucket that object is going to be deposited in, etc., etc. For now, we just created a simple rule. Now, if we go back to the original source bucket, which we're in right now, and we upload a new file, which will be a transactions file in a CSV format, once this is uploaded, that cross-region replication rule will kick in and will eventually, right, it's not immediate, but will eventually copy the file inside the demo 2 bucket. Now I know it's not there already, so what I'm going to do is pause the video and come back in 2 minutes, and when I click on this, the file should be in there. Okay, so let's now double check and make sure that object has been replicated. And there it is, been replicated as per our rule. So congratulations, you just learned how to perform your first same account S3 bucket region replication rule. Let's now take a look at transfer acceleration. So transfer acceleration is all about giving your end users the best possible experience when they're accessing information in your bucket. So you want to give them the lowest latency possible. You can imagine if you were serving a website and you wanted people to have the lowest latency possible, of course, that's something that's very desirable. So in terms of traversing long distances, if you have your bucket that is in, for example, the US East 1 region in the United States, in the Virginia region, and you had users, let's say in London, that want to access those objects, of course, they would have to traverse a longer distance than users that were based in the United States. And so if you wanted to bring those objects closer to them in terms of latency, then we could take advantage of what's called the Amazon CloudFront Delivery Network, the CDN network, which extends the AWS backbone by providing what's called edge locations. So edge locations are really data centers that are placed in major city centers where our end users mostly are located, more densely populated areas, and your objects will be cached in those locations. So if we go back to the example of your end users being in London, well, they would be accessing a cached copy of those objects that were stored in the original bucket in the, for example, US East 1 region. Of course, you will get most likely a dramatic performance increase by enabling transfer acceleration. It's very simple to enable this. Just bear in mind that when you do so, that you will incur a charge for using this feature. The best thing to do is to show you how to go ahead and do this. So let's do that right now. Let's now take a look at how to enable transfer acceleration on our Simplilearn S3 demo bucket. By simply going to the Properties tab, we can scroll down and look for a heading called Transfer Acceleration over here, and very simply just enable it. So what does this do? This allows us to take advantage of what's called the Content Delivery Network, the CDN, which extends the AWS network backbone. The CDN network is strategically placed into more densely populated areas, for example, major city centers. And so if your end users are situated in these more densely populated areas, they will reap the benefits of having transfer acceleration enabled because the latency that they will experience will be severely decreased. So their performance is going to be enhanced. If we take a look at the speed comparison page for transfer acceleration, we can see that once the page is finished loading, it's going to do a comparison. It's going to perform, first of all, what's called a multi-part upload, and it's going to see how fast that upload was done with or without transfer acceleration enabled. Now, this is relative to where I am running this test. So right now I'm actually running it from Europe. So you can see that I'm getting very, very good results if I would enable transfer acceleration and my users were based in Virginia. So of course, now I have varying differences in percentage as I go closer or further away from my region where my bucket or my browser is being referenced. So you can see here, United States, I'm getting pretty good percentages. As I go closer to Europe, it gets lower, of course, but still very, very good. Frankfurt, again, this is about probably the worst I'm going to be getting here since I'm situated in Europe. And of course, as I go look more towards the Asian regions, you can see once again it kind of scales up in terms of better performance. So of course, this is an optional feature. Once you enable it, as I just showed over here, this is a feature that you pay additionally for. So bear that in mind. Make sure that you take a look at the pricing page in order to figure out how much this is going to cost you. So that is it. Congratulations. You just learned how to simply enable transfer acceleration to lower the latency from the end user's point of view. We're now ready to wrap things up in our conclusion and go over at a very high level what we just spoke about. So we talked about what S3 is, which is a core service, one of the original services published by AWS in order for us to have unlimited object storage in a secure, scalable, and durable fashion. We took a look at other aspects of S3 in terms of the benefits. We mainly focused on the cost savings that we can attain in S3 by looking at different storage classes. Now, of course, S3 is industry recognized as one of the cheapest object storage services out there that has the most features available. We saw what goes into the object storage in terms of creating first our buckets, which are our containers, high-level containers in order for us to store our objects in. Again, objects are really an abstraction of the type of data that are in there, as well as the metadata associated with those objects. We took a look at the different storage tiers, the default being the standard, all the way till the cheapest one, which is the Glacier, which are meant for long-term archived objects. For example, log files that you may hold on to for a couple of years, may not need to access routinely, and will have the cheapest pricing option by far. So we have many pricing tiers, and if you want to transition from one tier to the next, you would implement a lifecycle policy or use the intelligent tiering option that can do much of this for you. We took a look at some very interesting features, starting from the lifecycle management policies that we just talked about, all the way to versioning, cross-region replication, and transfer acceleration. So with this conclusion, you are now ready to at least start working with S3. Hello everybody, my name is Kent, and today we're going to be covering AWS Identity and Access Management, also known as IAM, tutorial by Simplilearn. So these are the topics which we'll be covering today. We'll be defining what AWS security is, the different types of security in AWS, what exactly is identity and access management, the benefits of identity and access management, how IAM works, its components, its features, and at the end, we're going to do a great demo on IAM with multi-factor authentication and users and groups. So without any further ado, let's get started. So let's get started with what is AWS security. Your organization may span many regions or many accounts, and you may encompass hundreds, if not thousands, of different types of resources that need to be secured. And therefore, you're going to need a way to secure all that sensitive data in a consistent way across all those accounts in your organization while meeting any compliancy and confidentiality standards that have to be met. So for example, if you're dealing with healthcare data or credit card information or personal identification information like addresses, this is something that needs to be thought out across your organization. So of course we have individual services in AWS, which we will explore in this video. However, in order to govern the whole process at an organizational level, we have AWS Security Hub. Now, AWS Security Hub is known as a CSPM, which stands for a Cloud Security Posture Management Tool. So what does that really mean? Well, it's going to encompass, like I said, all these tools underneath the hood in order to bring a streamlined way for you to organize and adhere to these standards across your organization. It'll identify any misconfiguration issues and compliance risks by continuously monitoring your cloud infrastructure for the gaps in your security policy enforcements. Now, why is that important? Well, these misconfigurations can lead to unwanted data breaches and also data leakages. So in order to govern this at a very high level, like I said, we need to incorporate AWS Security Hub that will automate and manage all these underlying services for us in order to perhaps take automated action. We call that remediary actions. And you can approve these actions manually, or you can automate those actions as you see fit across your organization. So let's delve a little bit deeper into what is AWS security, and then we'll start looking individually at some of these services. And so our organization has special needs across different projects and environments. So of course, the production, development, test environments, all are going to have their own unique needs. However, it doesn't matter which project or which business unit we're talking about and what are their storage backups needs. they should all be implemented in a concise, standardized way across your organization to meet that compliancy we were just talking about. So we want to automate all these tedious manual tasks that we've been doing, like ensuring that perhaps our buckets in S3 are all encrypted or all our EBS volumes are encrypted. And we want to have an automated process in place in order to give us time on other aspects of our business, perhaps our application development, to bring better business value. And that allows us to grow and innovate the company in a way that's best suited for it. So let's take a look at the different types of AWS security. Now, there are many different types of security services out there. However, we're going to concentrate primarily on IAM in this video tutorial. So I like to think of IAM as the glue between all AWS services, because by default, we don't have permission for any one service to communicate with another. So let's just take, for example, an EC2 instance that wants to retrieve an object from S3. Well, those two services could not interact unless we interacted with IAM. So something that's extremely important to learn. And by the end of this video tutorial, you'll be able to understand what IAM is. We have Amazon Guard Duty here, which is all about logs. Basically aggregates all logs from, example, CloudTrail, which we still haven't talked about. It's at the end of this list over here. But instead of looking at CloudTrail individually, Guard Duty will actually take a look at CloudTrail will take a look at your VPC flow logs, and we'll take a look at your DNS logs and monitor that account and your network and your data access via machine learning algorithms. And it'll ID any threat where you can automatically remediate the workflow that you've approved. So for example, if you know of a malicious IP address that's making API calls, well, those API calls are registered in CloudTrail, right? So this machine learning algorithm will be able to detect that and take action. So this is really governed at a higher level than you having to individually inspect all your DNS logs, flow logs, and CloudTrails individually and take action through some scripting fashion that you've come up with. So Guard Duty manages all that. We have Amazon Macie, which once again uses machine learning, but also uses pattern matching. Pattern matching can be used with matching kind of libraries that are already in place, or you can come up with your own pattern matching, and that's used to discover and protect your sensitive data. So for example, if you had healthcare data, also known as HIPAA compliancy, or credit card data that's lying around, well, Macie will discover it and will protect it. So as your data grows across your organization, that might be harder and harder to do in your own way. So Macie really facilitates discovering and protecting that, so you can concentrate on other things. AWS Config is something that kind of works in tandem with all the other services. It's able to continuously monitor your resources configurations and ensure that they match your desired configuration. So for example, maybe you state that your S3 bucket should be encrypted by default, all of them, or you want to make sure that your IAM user access keys are rotated. And if they're not, then take remediary action. So a lot of these automated remediary actions, right, are basically executed via AWS Config. So you'll see the AWS Config actually used by other services underneath the hood. And then you have CloudTrail. CloudTrail is all about logging every single type of API call that's made. So it'll always record the API call, who made it, from what source IP, the parameters that were sent with the API, the response, all that data, which is really a gold mine for you to investigate if there's any security threat. And again, this trail over here, and there can be many, and there's lots and lots of data generated by these trails, can be analyzed by these other services, specifically Guard Duty here, that automates that process so you don't have to. So let's get to the next one, which is, what is identity and access management? So what is IAM? Like I said, IAM is the glue between all AWS services. It will allow those services to communicate with each other once you put IAM into place. The other thing is it allows us to manage our AWS users, which are known as IAM users, and group them together into groups to facilitate assigning and retrieving or removing permissions from them instead of doing it on an individual scale. So of course, if you had 200 IAM users and you wanted in one shot to add a permission to a group that contained 200 IAM users, well, you can do that in one operation instead of 200. Now we do have a distinction between IAM users and end users. End users use applications online, whereas IAM users are your employees in your organization that are interacting directly with AWS resources. So for example, an EC2 instance would be a resource that, let's say, a developer would be interacting with. And traditionally, those are resources that are used full-time from 9 to 5, let's say, 5 days a week, 365 days a year, okay? Now, sometimes those users have to have elevated permissions for a temporary amount of time, and that is more suited for a role. And that will eliminate the need to create separate accounts just for, type of actions that are needed for, let's say, an hour a month or 2 hours a week or something like that. Something like backing up an EC2 instance, removing some files, doing some cleanups. Traditionally, you don't have those permissions as a developer, but you can be given temporary permissions to assume this role. So it's kind of like putting a hat on your head and pretending you're somebody that you're usually not for a temporary amount of time. Once you take off the hat, you go back to being your old, boring IAM user self, which doesn't have access to performing backups or cleanups and stuff like that. So the roles interact with a service called a secure token service, which gives us specific keys, specifically an access key, a secret key, much like a username and password. And then we have a token key, which only gives you access to this role, this elevated permission, for 1 to 12 hours. So we'll talk more about roles as we go on through this video tutorial, but it's important that you at least remember at this point, even if you don't know all the details, that roles have to do with temporary permissions, elevated permissions. So what are the benefits of IAM? Well, across our organization, we are going to have many accounts, and like I said, hundreds if not thousands of resources. So scalability is going to be an issue if we don't have a very high level visibility and control over the entire security process. And once we have a tool like, for example, Security Hub, which we saw on the first slide, we can continuously monitor and maintain a standard across our organization. So very, very important to have that visibility. And we do when we integrate with AWS Security. Now, we also need to eliminate the human factor, right? So we don't want to manually put out fires every single time. Of course, there will be times when something new occurs that we've never seen before that will be needed. However, once an occurrence happens and reoccurs, we can obviously come up with a plan to remediate the action. So once we automate, we can definitely reduce the time to fix that reoccurring error, or it could be a new error that we don't have to interact with because we're using machine learning algorithm services like I was talking about, like GuardDuty or Macy. And we can really reduce the risk of security intrusions and data leakage and such by using IAM to facilitate this. Of course, you may have many compliance needs. You may be dealing with applications that use healthcare data or credit card information for payments, or you might be dealing with a government agency, let's say in the US, that has certain compliancy requirements that needs assurances that if their data is stored on the cloud, that you're still following the same compliance controls that you were, let's say, on premise. So we have a very, very long list of compliance requirements that each AWS service adheres to. And you can go on the AWS documentation online and you could figure out if, for example, DynamoDB is compliant with HIPAA compliancy. And it is. And so you can be sure that you can use that. So AWS itself has to constantly maintain these compliancy controls in place, and they themselves have to pass all these certifications, and that gets passed on to us. So much less work for us to implement these compliance controls. We can just inherit them by using AWS's security model by IAM. And last but not least, we can build the highest standards for privacy and data security. Now, having all this on our own on-premise data center poses security challenges, especially physical security challenges. You have to physically secure the data center. You might have security personnel that you need to hire, 24/7 camera surveillance, et cetera, et cetera. So just by migrating to the cloud, we can take advantage of AWS's global infrastructure. They're very, very good at building data centers. That's part of their business, and securing them. So of course we have a shared security model in place. However, you can rest assured that at least as the lowest common denominator, physical security has been put into place for us. Again, as other services are used, more managed services or more higher end services used in AWS, more and more of that security model will be AWS's responsibility and less yours. We will always have a certain type of responsibility for our applications, but we can again use these high-level services to ensure that our ability to encrypt the data at rest and in transit are always maintained by coming up with specific rules that need to be adhered to. And if those rules are not adhered to, then we have remediary actions that take place in order to maintain, again, that cross-account or organizational-wide security control. Okay, so lots of benefits of using IAM. And let's now take a look at exactly how IAM works and delve deeper into authentication and authorization. So there are certain terms here that we need to know about. One of them is principal. Now, principal is nothing more than an entity that is trying to interact with an AWS service, for example, an EC2 instance or an S3 bucket. Now, that could be a user, an IAM user. It could be even a service, or it could be a role. So we're going to take a look how principals need to be specified inside IAM policies. Authentication. So authentication is exactly how it sounds. Who are you? Could be something as simple as username and password, or it could involve an email address. Example, if you're the root user of the account when you're creating the account for the very first time. Other normal users will not need to log in with their user email. It'll only be the root user that needs that. You could also have developer type access, which needs access, let's say, via command line interface or a software development kit, also known as an SDK. Now, for those kind of access points, we're going to need access keys and secret keys, or public-private keys, let's say, if you want to even authenticate and log in through SSH to an EC2 instance. So there are many different types of authentication that we could set up when creating IAM users based on what kind of access they need. Do they just need access to the console? Do they need access to just services in terms of as a programmatic need? So those are different types of authentication. And then we have the actual request. Now, we could make a request in AWS through various ways. We're going to be exploring that via the console, the AWS console. However, every button you click, every drop-down list you select, that invokes an API call behind the scenes. So everything goes behind a centralized, well-documented API. Every service has an API. So if you're dealing with Lambda, let's say, well, Lambda has an API. If you're dealing with EC2, EC2 has an API. Now, you could interact with that API, like I said, via the console indirectly. You could use a command line interface. You can use an SDK for your favorite programming language like Python. So all of them get funneled through, all your requests get funneled through an API. But that doesn't mean you're allowed to do everything just because we know who you are and you have access to some keys, let's say, to make some API calls. You have to be authorized in order to perform certain actions. So maybe you're only authorized to communicate with DynamoDB, and also maybe you're only authorized to perform reads and not writes. So we can get some very fine-grained authorization through some IAM policies in order to control not only who has access to our AWS, but what they're allowed to do. So very fine-grained actions, read actions, write actions, both, maybe just describe or list some buckets. So depending on the AWS user that's logged in, we can control exactly what actions because every API has fine-grained actions that we can control through IAM. And of course, many different types of resource. When we're coming up with these policies, all these actions can be grouped into resources. So perhaps we can say, well, this user only has access or read-only access to S3, specifically these buckets, and can write to DynamoDB table, but cannot terminate or shut down an EC2 instance. So all these kind of actions can be grouped into resources on a per resource basis based on the kind of role you have in the projects or in the company. So now let's take a look at the components of IAM. We've already seen that we can create IAM users and that how they are different than your normal end users. Now those entities represent a person that's working for an organization that can interact with AWS services. And some of those permissions that we assign through what's called identity-based policies to such a user will have permissions, for example, that are always necessary every time that they're logged in. So perhaps this user Tom always needs access to the following services over here, for example, an RDS instance or an S3 bucket, etc., etc. And sometimes they will need temporary access to other services, for example, DynamoDB. So in those cases, there would be a combination of normal IAM policies assigned to the user and certain assume role calls done at runtime in order to acquire this temporary credential, elevated permission. There is also the root user, which is different than your typical super user administrator access. There are some things that a root user can do that an administrator access cannot. For example, a root user, first of all, logs in with their email address and can also have the option to change that email address, something that is very tightly coupled to the AWS account. So you cannot change the email address with an administrator account. The other thing a root user can do is they can change the support contract. They can also view billing information or taxes information, VAT information, for example. So the best thing to do, the best practice is that once you've created your AWS account, you are obviously the root user. The best thing to do is to enable multi-factor authentication, store away those keys in a secure location, and your first administrative task should be to create an administrator super user, from which that point on you will log in as only an administrative user, and you will create other type of administrative users, and those administrative users will create other IAM users. So never log into your AWS account as a root user unless you need to access that specific functionality that I said that is over and above a super user administrator account. So here we have a set of IAM users, and we could assign to them directly IAM policies, which give them access to certain services. However, the best practice is to create groups, which is just a collection of IAM users. And suppose we have a developer group and a group of security administrators. Of course, we could assign different types of policies to that group, and every user that is assigned to the developer group will inherit those IAM permissions. Makes it much easier to manage your IAM users this way. And for the fact that also you can have users that can be assigned to groups, as you can see here, but what's not shown here that is possible as well is you could have a user that is part of two groups at the same time. The thing that you cannot have, though, is the notion of subgroup. So I can't extend this group and create a smaller group of developers out of this big group here. So we don't have hierarchical groups, but we do allow users to partake in different groups at the same time. So they will inherit those permissions, those IAM policy permissions from, for example, if user A was part of developers and user A was part of security, they would inherit these two policy statements over here. Now, there is another type of IAM policy, and that is called a resource-based policy. So resource-based policies are not attached directly to, for example, users, but they're attached more to resources like an S3 bucket, for example. And so when you have such a case, a user group can't be designated as a principal to a group. That's just one of the restrictions. However, there are other ways to get around that. As I said, when you think of an IAM role, I want you to think that these are temporary credentials that are acquired at runtime and are only good for a specific amount of time. Now, an IAM role is really made up of two components. We have what's called a trust policy. So who do you trust to assume this role? Who do you trust to even make an API call to assume the role? After that, we have an IAM policy. Once you've been trusted to assume the role and you get those temporary tokens, what are you allowed to do? Maybe you're allowed to have read-write access to the DynamoDB. So here we have no long-term credentials that are connected to role. You do not assign a role to a user. The user or service will assume the role via API call via the secure token service, STS. And with those temporary credentials, we'll then be able to access, for example, an EC2 instance if the IAM policy attached to the IAM role says that you can do so. So your users and your applications perhaps running on an EC2 instance and the AWS services themselves don't normally have access to the AWS resources, but through assuming a role, they can dynamically attain those permissions at runtime. So it's a very flexible model that'll allow you to bypass the need to embed security credentials all over the place and then have to maintain those credentials and make sure they're rotated and they're not acquired by anybody trying to find a security hole in your system. So from a maintenance point of view, they're really an excellent tool to use in your toolbox, your security toolbox. So let's take a look at the components of IAM. We have the IAM policy over here, which is really just a JSON document. And that JSON document will describe what this user can do if it's attached directly to it, or if the IAM policy is attached to the group, whatever user is attached to that group will also have the same policy inherited. So these are more long-term credentials in terms of, or permissions rather, that are attached to your login for the duration of your login, whereas roles are, as we've already stated, temporary. And again, once you've established a trust relationship, then we can assign a policy, for example, a policy that gives you only read-only access to a CloudTrail to a role. Now, it's up to the user to assume that role either through the console or through some programmatic means. Whichever way is performed, the user will have to make a direct or indirect call to STS for the assume role call. Now, these permissions are examined by AWS when a user submits a request. So this all happens at runtime dynamically. So when you change a policy, it will take effect pretty much immediately as soon as the user makes the next request. That new security policy, whether you've just added or removed the permission, will take immediate effect. So what we're going to do now is just really quickly go to the AWS console and actually show you how an IAM policy looks like. So I've just logged into my AWS management console, and if I search for identity and access management, it should be the first one to show up. I'll just click on that. And I want to show you actually how these IAM policies look like. If you go to the left-hand side here, there's an entry for policies, and there are different types of policies that we can filter out. So let's filter them out by type. We have customer managed, we have AWS managed, and more in line with job functions that AWS managed also. So we're going to take a look at AWS managed. All that means is that AWS has created and will actually update, maintain these pre-established and already vetted identity policies, IAM identity policies. So I could add further down, maybe look at all the S3 policies that are available, and we can see there are some that allows only read-only access. There are some that will give us full access. And there are, of course, other types here that we're not all going to explore, but let's just easily kind of take a look here at the full access. You can see it's just a JSON document. And of course, you cannot modify it since this is a managed policy. However, you can copy it and modify it. And in that case, it will become your own version of it. And so it'll be customer defined. And so when you go here and you do a filter, you can filter on your own customer managed policies. So over here, we are simply allowing certain actions, right? We talked about actions before that were based on API. So here we have an API that starts with S3. So this is for the S3 API. And instead of filtering out exactly specifically what API calls are there, we're basically saying all API calls. So star representing all API actions. And again, there is another category of S3 which deals with object Lambda, and we are allowing all operations on that specific API as well. We could, if this was our own customer managed policy, actually scale down on which resource, which bucket, let's say, or which folder in a bucket this would apply to. But in this case, since this is a full access, we're basically being given permission to execute every single API action under S3 for all buckets. We're going to see in the lab or the demonstration at the end of this tutorial that I'm going to show you how to scale that down. Okay, so that's how an IAM policy looks like. And if you want to assign an IAM policy to a user, well, stay tuned for the demonstration at the end of the video tutorial. What's not at the end of the video tutorial is really how to create a role. So I'll show you what a role is here. Again, there's a whole bunch of roles already set up that we can go and take a look at here. But we can go and create our own role as well. And I might create a role, for example, that gives in EC2, let's choose EC2, access to S3. So if I click EC2 and click next permissions, I can actually assign the S3 permission right over here. It's just a policy, just like we took a look at. Obviously assign it a tag and review it. And I'm just going to call this my EC2 role to S3. Create the role. And because I selected EC2 as a service, it automatically will include that in the trust policy. So now when I go and I create an EC2 instance, I can attach this role to that EC2 instance, and that EC2 instance will automatically be able to, if we're using the Linux 2AMI, let's say, have access to, or full admin access to, any S3 bucket in the AWS account. So let's go take a look at where we would actually attach that role on the EC2. So when you're creating an EC2, let's just say we go here, we say launch an EC2 instance, and we'll pick this AMI over here because it'll already include the packages necessary to perform the assume role call to STS for us, so we won't have to code that. And we don't have to embed any credential keys in order to get this running, which is really good, which is the whole point of what I'm doing, because by assuming a role, I don't have to manage that. And I'm just going to pick the free T2 micro. And it is here, once you pick whatever you need, whatever VPC and whatnot, that you come to the IAM role and you select the role to be assumed dynamically. Now I have a whole bunch of them here, but this is the one that I had created here, my EC2 role to S3. And if I go and I launch this EC2 instance, and then I had an application, let's say, that needed to contact S3, or even if I went on the command line of the EC2 instance, I would be able now to communicate with the S3 service, because they being AWS, would actually use this role to perform an assume role call to get those temporary STS tokens for me, which will then allow me to access my IAM policy, which gives me full access to S3. And off I go. So this is a great way, like I said, to avoid having to administrate any embedded keys in this EC2 instance. And I could take this role away at any time as well. So there you have it, a little demonstration on how to create a role, how to attach it to an EC2 instance, and also how managed and customer managed policies look like in IAM. Of course, there is also the fact that we have multiple accounts, and so we could assign a policy that will also allow a user in another account access to our account. So cross-account access is something that's very, very well needed, and also is a feature of IAM. So when you need to share access to resources from one account to another in your organization, we are in need of an IAM policy to facilitate that. So also roles can come into play here for that. By also assigning granular permissions, we can make sure that we implement the concept or the best practice of the least privilege access. And also we have secure access to AWS resources, because by default, again, we have the principle of least privilege, and no service can communicate with another until we enable it via IAM. So very, very secure out of the box. Of course, if you want to add an additional layer of authentication, of security, we have multi-factor authentication rather, and that'll allow you to ensure through a hardware device, perhaps let's say a hardware token device, or your cell phone that has some software that generates a code, that will allow you to identify you are actually the person that is typing the username and password, and not somebody who's actually stolen your username and password. So at the end of this video tutorial, we will show you, or I will show you how to enable that. And of course, identity federation is a big thing, where your users may have been defined outside of AWS. You may have thousands of users that you've already defined, let's say in an Active Directory or in an LDAP environment on-prem, and you don't want to recreate all those users again in AWS as IAM users. So we can tie in, we can link the users, your user database that's on-prem, or even users that have been your user account that's been defined, let's say on a social site like Facebook or Twitter or Google, and tie that into your AWS account. And there is an exchange of information, there is a setup to do, but at the end of the day, it is either a role in combination with an IAM policy that will allow to map what you're allowed to do once you've been authenticated by an external system. So this has to do with perhaps like I said, LDAP or Active Directory, and you can tie that in with AWS SSO. There are many different services here that can be leveraged to facilitate what we call identity federation. And of course, IAM itself is free. So it's not a service per API request. AWS is very concerned to put security first, and so IAM is free. It's just the services that you use. For example, if you're securing an EC2, of course, that EC2 instance falls under the current pricing plan. So of course, compliance, like I mentioned, is extremely important, making sure that it's business as usual in the cloud. And so, for example, if you were using the payment card industry data security standard to make sure that you're storing and processing and transmitting credit card information appropriately, in order to do your business, well, you can be assured that the services you use in AWS are PCI DSS compliance. And there's many, many other types of compliance that AWS adheres to as well. So password policies, of course, are important. By default, we do have a password policy in place, but when you go to the IAM console, you're free to update that password policy, make it more restrictive based on whatever policy you have at your company. So many features, and so I think we're ready now to go into a full demonstration, and I will show you how to incorporate IAM users, groups, and also multi-factor authentication. So get ready, let's do it. I'm going to demonstrate now how to attach an S3 bucket policy via IAM. I've already created a bucket called Simplilearn S3 IAM demo. And what we're going to do is we're going to attach a bucket policy right over here. We're going to have to edit it, of course. And the basis of the demonstration will be to allow a user that has MFA, so multi-factor authentication, set up to have access to the contents of a folder within this bucket. So of course, now I have to create a folder. Just simply call it folder 1. Create that folder. And now I'm going to go into that folder and upload a file so that we can actually see this in action. So I'm going to select a demo file that I prepared in advance called demo file user2 MFA. I'm going to upload that. All right. And now what's going to happen is eventually when I create our 2 IAM users, one will have access to view the contents of this file, which should look like something very simple. If I open this up within the console, you'll be able to see, well, it's pretty small right now. I'll make this a little bit bigger, of course. It says this is a demo file which user2-MFA should only be able to have access to. So what's left to do now is to create 2 users, one called user1 and one called user2-MFA, and that's what we're going to do right now. Let's head over to IAM. Identity and Access Management. And on the left-hand side here, we're going to click on Users. You can see here I don't have much going on. I just got an administrator user, so I want to create 2 new users. We'll start with one at a time. So one called User1. Now by default, we have the principle of least privilege, which means this user is not allowed to do anything unless we give them access to either the console right over here, which I will do right now. And also if they were a kind of programmatic user that needed access to specific keys in order to interact with the APIs via the command line interface or the software development kit, for example, if you were a Java developer. So in this case, that is not what I want. So I'm just going to assign console access, and I'm also going to create a default password for this user. But I will not allow them to reset it on the first login, just for demonstration purposes. Now over here, we have the chance to add the user straight to a group, but I'll only do that later on at the end of the demonstration. For now, I want to show you how to attach to this user an IAM policy, which will give them access to specific services. So if I type in S3 full access here, this is an administrative access to an S3 bucket. If you take a look at the JSON document attached or representing that IAM policy, you can see that it is allowing all API actions across S3, star, and also object lambda across all buckets. And I say all buckets because the star represents all buckets. So it is a very broad permission, so be very careful when you're actually assigning this to one of your users and make sure that they deserve to have such a permission. So I'm not going to assign any tags here, but I'm just going to review what I've done. You can see here I've just attached an S3 full access permission to this one user, and I'm going to create that user now. Of course, now's the time for me to download the CSV file, which will contain those credentials. If I don't do it now, I will not have a second chance to do this. And also to send an email to this user in order for them to have a link to the console and also some instructions. I'm not going to bother with that. I'm just going to say close. And now I have my user 1. You can see here that it says none for multi-factor authentication. So I have not set anything up right now for them. And that's what I want to do for this second user that I want to create, called user2-MFA, or MFA rather. All right. So now I want to do the same exact thing as before. I'm going to assign a custom password. And I'm going to go through the same steps as we saw before. I'm going to attach an existing managed policy that AWS has already vetted for us. Review, create. Now, right now, they're exactly the same. So I have to go back to user 2 and set up multi-factor authentication. And to do that, you have to go in the Security Credentials tab. And you'll see here assigned MFA device, we have not assigned any yet, so we're going to manage that right now. And we have the option to order and get an actual physical device that's uniquely made for performing multi-factor authentication. However, we're going to opt for the virtual MFA device, which is a software that we're going to install on our cell phones, let's say. So I can actually open this link just to show you the very many options that we have for that. They're right over here. I'm going to go with Google Authenticator. So go to the App Store on your Android device and you can download that. Of course, if you have an Android device. If not, you have other options for iPhone and other softwares for each one of those. So I'll let you do that. Once you've installed that software on your cell phone, you can come here and show the QR code. Now, what that is going to do is you're going to need to go to your phone now, and I'm going to my phone right now as we speak, and I'm going to open up that MFA software, in this case, the Google Authenticator, and I'm going to say there's a little plus sign at the bottom. I'm going to say scan QR code. I'm going to point my phone to this square code here, this QR code, and it's going to pick it up. I'm going to say add account. There's a little button there, add account, and it's going to give me a code. So I'm going to enter that code right now. So once I've entered the code, I have to wait for a second code, and that's because this code on the screen of my cell phone is going to expire. It's only there for about 20 to 30 seconds. Once that token expires, it refreshes the display with another token. So I have another token now. That's only good for a couple of seconds again. And now I'm going to say assign MFA. What this does is it completes the link between my personal cell phone and this user right now. So now that this has been set up, we can see we actually have an ARN to this device, which we are going to possibly need depending on how we write our policies. In our case here, I'm going to show you a way to kind of bypass having to put that. So now we've got those two users, one with an MFA device and another one without. Okay, so now the lab is going to be, or the demonstration rather, is going to be how do we allow user 2 MFA access to this file in folder 1 and not allow user 1. The distinguishing factor will be that user 2 has an MFA set up and user 1 doesn't. So based off of just that condition, that'll be the determining factor if they can view the file or not. So let's get back to S3 and actually create this IAM bucket policy and see how it's done. So back we are in our bucket, and now we have to go to permissions in order to set up this bucket policy. We're going to click on edit over here, and we're going to click on policy generator to help us generate that JSON file through a user interface. Of course, we're dealing with an S3 bucket policy. Now, what we're going to do is we're going to deny all users and services, so star. S3 is grayed out here because we selected S3 up here. We want to deny all S3 API actions. We're not going to go and selectively go down the list. The specific bucket and the folder. So in this case here, we're missing the Amazon resource name. So we have to go back here and we have to copy the ARN of our bucket, right? So we're going to copy that, come back, Control V, and we're going to, of course, have to specify the folder as well. So I'm going to just do /folder1, and then I'm also going to do /star for all the objects in that folder, okay? So here's the MFA condition that I want to add though, because we cannot assign the MFA condition up here. We have to say add conditions, very powerful feature here. That's optional, but very powerful. We want to look for a condition that says Boolean if exists or bool if exists, all right? So there's got to be a key value pair that exists, and there are many, but we're going to look for one that is specifically known as multi-factor authentication present. And we want to make sure that value is equal to false. So I'm going to add that condition, and then I'm going to add that statement. and I want to generate the policy just to show you now how that user interface has generated this JSON document for us that we're going to attach to our S3 bucket. What I want to do is I want to take this in its entirety, copy it, and go back to our S3 bucket that's just waiting for us to paste our policy in here. Okay, so let's see what's actually going on here. We've created a policy. Again, this policy could have any ID. It's just an ID that was given by the user interface. You could name that whatever you want. Of course, something that makes total sense. And then we have one or more statements, and then we only have actually one statement. And again, you can select any ID here. That was just auto-generated by the IDE. We're saying that all actions on the simple storage service, I say all again because of the star, are denied specifically on this resource, which is our bucket and the folder named folder 1 and all the objects within that folder under the certain conditions. So the condition is if you have a Boolean value of false associated with a key called multi-factor authentication present, and it has to exist, okay? Then if that value is equal to false, you don't have access to the objects in this folder, which means that if you do have MFA set up, you will be allowed access to the contents of this folder. So if we assign this and apply this to all principals, which would encompass user 1 and user 2-MFA, then, let me just apply this, that would mean that user 1 would not be able to see the contents of our object inside folder 1, and user 2-MFA would. So let's go take a look and log into, let's log out first, and then when we're going to log back in, we're going to log in as the individual user 1 and user 2-MFA and prove this is actually the case. So I am now logging back in as user 1 that we created moments ago. And of course, if I, for example, go see a service like EC2, we don't have access to EC2. We've just given ourselves access to S3. So this makes total sense. We're just going to go see what we have access to, which is S3. Should be able to list and describe all the buckets there because we've been given pretty much administrative access. Now, if we go here to our created bucket and go inside folder 1 and want to actually open up this document, we can see now that that's not happening, okay? And that's because of that condition that is checking if we actually have a value of true for that MFA key that we specified, okay? So this is expected and this is exactly what we wanted. Now what we're going to do is we're going to log out once again, and we're going to do the same thing, but with user 2-MFA. Let me log back in. And then specify the new password we created. Now, of course, now I have an MFA code, right? Because I've set that up for user 2. So back on my cell phone I go. I am opening up the Google Authenticator application, and I have in front of me a new Amazon Web Services code that is only good for, like I said, maybe 20 seconds. So it's a little nerve-wracking. If you're not good under pressure, you're going to choke. So I just entered the code, and I have to wait for that to actually work. Now, it looks like I actually didn't check off not to recreate the password. So unfortunately, I must have missed that check mark. So I wanted to kind of avoid this here. So I'm going to start over and create a brand new password. A little painful for demonstrations, but it's good for you guys to see how that actually looks like. So because I've set up my MFA device properly, I am able to log in after I enter that MFA code. And once again, if I go to EC2, now I haven't been given the permissions for EC2. I've only been given the permissions for S3. So nothing changes here. I'm going to go to S3 and I'm going to go into folder 1 of our bucket in question, and I'm going to see if I have access now to opening up and seeing the contents. And here I have the contents. This is a demo file which user 2MFA should only be able to have access to. So that worked. So now you guys know how to create a bucket permission policy that is also known as a resource policy, because it's assigned to the resource, it's assigned to the bucket. And let me actually show it to you one last time. Here it is. And that'll only allow us to have access to the contents of folder 1 if we have multi-factor authentication set up in our account. So that's really good. The last thing I want to show you now is how to maybe create IAM users in a better way, in terms of not having to assign over and over again the same permissions like you saw me do for user 1 and user 2. Of course, now I cannot do anything IAM. Why? Because I'm user 2. I don't have access to IAM. So once again, I'm logging out, and we're going to actually see the best practice in terms of how do I assign IAM policies to a group and then assign users to that group in order to inherit those permission policies. So let's get to it. Let's sign up first. So let us go back to IAM, and we're going to be creating our first group. We're going to simply create the button, or click on the button create group, and we'll come up with a group called testers. We have the ability to add existing users to this group. So we will add, for example, user 1 only to the testers group. And we can also add permissions to this group. So we're going to go here and add, for example, the EC2 full permissions, create group. And what's going to happen now, if we go take a look at testers, we can see we have that one user that we added, and we also have the permissions associated with that group. So this means now that any new users we create will automatically inherit whatever permissions the group has, which is really good for maintainability. So for example, let's say we were to create many new testers. So let's say user 3 over here. Now, of course, I'm going to have to go in this case through the same steps as I did before. I'm just going to remember this time not to forget to uncheck that. And instead of attaching policies directly, I'm going to say, well, I want to inherit the policy permissions that were assigned to the group. So I'm going to say this user is going to be part of the testers group. And of course, I'm just going to skip through the remaining repetitive tasks that I've already described. And this user 3 now is already going to have the permissions to access EC2 that they've gained through the group testers. Whereas if we go back to user 1, this user also has the permissions from the group, but has a unique permission added to itself. So in this case, you do have the option of doing that. You have the option of adding a permission over and above that is assigned to the group to yourself directly. So this is really good, adding permissions to groups when you have, of course, lots of users in your company, in your organization. And instead of going to them and adding permissions after permission, you can centrally access this in one, or manage this in one place. So for example, if I go back to my roles, groups rather, in my testers, and let's say I forgot to add a permission to all the users in this group. So let's say there was 20 users attached to this group. Okay, I'm not going to bore you with creating 20 users. we have 2 now. That's good enough to show the demonstration. And let's say now I need to add another permission, right? So in this case here, I'm going to add a permission, for example, let's say based on DynamoDB, right? So I'm going to get full access to DynamoDB. I'm going to add that permission. And what's going to happen now is if I go back to my users, for example, user 3, I'm going to see that user 3 automatically has inherited that permission, and so has user 1. All right, show two more, and there they are. So in this case, it really allows for you to easily manage a lot of users in that group, because you can simply go to one place, which is the group, and add and remove policies as you see fit, and the whole team will inherit that. So it saves you lots of work, and that is the best practice. So there you have it, guys. You have learned in this demonstration how to create users, how to create groups, how to add users to groups and manage their policies in terms of best practice. And you've also learned how to attach to an S3 bucket a policy that allows you to permit access based off of if a user has multi-factor authentication set up. And we showed you how to actually set that up when creating an IAM user. So again, permissions tab is where this all happens. Hope you enjoyed that, put that to good use, and I'll see you in the next demonstration. So I hope you enjoyed that demonstration. We're just going to wrap things up in a summary and kind of see what was looked at throughout the tutorial. We first started with what is AWS security. We took a look at how important it was across our organization to maintain best practice and also standardize that practice across accounts organization. We took a look at the topmost services, in which we concentrated then after on IAM. And we took a look at what IAM was in terms of IAM users, groups, long-term credentials that are applied as IAM policies, and then the concept of a role. We took a look at the benefits of IAM and the actual terminology used with working with IAM. Of course, principal being an entity that is either a user or a service itself that can gain access to an AWS resources. And we actually saw the different types of authentication and what we can do to implement authorization via IAM policies and also through the use of roles. So we took a look how to organize our users into groups and what actually goes into acquiring a role through a demonstration. We took a look at how to actually create a role and attach that role to an EC2 instance. And then we took a look at the high-level features of IAM, which allowed us to either grant access to another IAM user from another group, implement multi-factor authentication like we just did in the demonstration, or ensure ourselves that we are following all the compliancy standards that have been adhered to by whatever project we're working on, and that AWS is there to support us. So
here we're going to talk about Amazon ECS, a service that's used to manage Docker containers. So without any further ado, let's get started. In this session, we would like to talk about some basics about AWS, and then we're going to immediately dive into why Amazon ECS and what is Amazon ECS in general. And then it uses a service called Docker. So we're going to understand what Docker is. And there are competitive services available for ECS. I mean, ECS is not the on and only service to manage Docker containers. But why ECS? Advantage of ECS. We will talk about that. And the architecture of ECS. So how it functions, what are the components present in it, and what are the functions that it does. I mean, each and every component, what are all the functions that it does. All those things will be discussed in the architecture of Amazon ECS. And how it works, how it all connects together. That's something we will discuss. And what are the companies that are using ECS? What were the challenge and how ECS helped to fix the challenge? That's something we will discuss. And finally, we have a wonderful lab that talks about how to deploy Docker containers on an Amazon ECS. So let's talk about what is AWS. Amazon Web Service, in short called as AWS, is an web service in the cloud that provides a variety of services such as compute power, database storage, content delivery, and a lot of other resources, so you can scale your business and grow, not focus more on your IT needs and the rest of the IT demands. Rather, you can focus on your business and let Amazon scale your IT, or let Amazon take care of your IT. So what is that you can do with AWS? With AWS, we can create, deploy any application in the cloud. So it's not just deploying, you can also create your application in the cloud. It has all the tools and services required, the tools and services that you would have installed in your laptop or you would have installed in your on-premises desktop machine for your development environment. The same thing can be installed and used from the cloud. So you can use cloud for creating, and not only that, you can use the same cloud for deploying and making your application available for your end user. The end user could be internal users, the end user could be in the internet, the end user could be kind of spread all around the world. It doesn't matter. So it can be used to create and deploy your applications in the cloud. And like you might have guessed, now it provides service over the internet. That's how your users worldwide would be able to use the service that you create and deploy, right? So it provides service over the internet. So that's for the end customer. And how will you access those services? That's again through the internet. It's like the extension of your data center in the internet. So it provides all the services in the internet. It provides compute service through the internet. So in other words, you access them through the internet. It provides database service through the internet, over the internet. In other words, you can securely access your database through the internet, and a lot more. And the best part is this is pay as you go, or pay only for what you use. There is no long-term or beforehand commitment here. Most of the services does not have any commitment. So there is no long-term and beforehand commitment. You only pay exactly for what you use. There's no overage, there's no overpaying, right? There's no buying in advance, right? You only pay for what you use. Let's talk about what ECS is. So before ECS, before containers, right? ECS is a service that manages Docker containers, right? It's not a product or it's not a feature all by itself. It's a service that's dependent on Docker container. So before Docker containers, all the applications were running on VM or on a host or on a physical machine, right? And that's memory bound, that's latency bound. The server might have issues, on and on, right? So let's say this is Alice and she's trying to access her application, which is running somewhere in her on-premises, and the application isn't working. What could be the reason? Some of the reasons could be memory full, the server is currently down at the moment, we don't have another physical server to launch the application, a lot of other reasons. So a lot of reasons why the application wouldn't be working in on-premises. Some of them are memory full issue and server down issue, very less high availability, or in fact single point of failure and no high availability, if I need to tell it correctly. With ECS, the services can kind of breathe free, right? The services can run seamlessly. Now how is that possible? Now, those things we will discuss in the upcoming sessions. So because of containers and ECS managing containers, the applications can run in a high available mode. They can run in a high available mode, meaning if something goes wrong, right, there's another container that gets spun up and your application runs in that particular container. Very less chances of your application going down. That's what I mean. This is not possible with a physical host. This is very less possible with a VM, or at least it's going to take some time for another VM to get spun up. So why ECS, or what is ECS? Amazon ECS maintains the availability of the application and allows every user to scale containers when necessary. So it not only meets the availability of the application, meaning one container running your application or one container hosting your application should be running all the time. So to meet that high availability, availability is making sure your service is running 24/7. So container makes sure that your services run 24/7. Not only that. Suddenly if there is an increase in demand, how do you meet that demand? Right? Let's say you have like 1,000 users. Suddenly the next week there are like 2,000 users. Right. So how do you meet that demand? Container makes it very easy for you to meet that demand. In case of VM or in case of physical host, you literally will have to go buy another physical host, or add more RAM, add more memory, add more CPU power to it, right? Or kind of club 2-3 hosts together, clustering. You would be doing a lot of other things to meet that high availability and also to meet that demand. But in case of ECS, it automatically scales the number of containers. It automatically scales the number of containers needed, and it meets your demand for that particular hour. So what is Amazon ECS? The full form of ECS is Elastic Container Service, right? So it's basically a container management service which can quickly launch and exit and manage Docker containers on a cluster. So what's the function of ECS? It helps us to quickly launch and quickly exit and manage Docker containers. So it's kind of a management service for the Docker containers you will be running in Amazon or running in the AWS environment. So in addition to that, it helps to schedule the placement of container across your cluster. So it's like this. You have two physical hosts, joined together as a cluster. And ECS helps us to place your containers. Now, where should your container be placed? Should it be placed in host 1? Should it be placed in host 2? So that logic is defined in ECS. We can define it. You can also let ECS take control and define that logic. Most cases you will be defining it. So schedule the placement of containers across your cluster. Let's say two containers want to interact heavily. You really don't want to place them in two different hosts, right? You would want to place them in one single host so they can interact with each other. So that logic is defined by us. And these container services, you can launch containers using AWS Management Console, and also you can launch containers using SDK kits available from Amazon. You can launch through a Java program. You can launch container using an .NET program. You can launch container using an Node.js program, as in when the situation demands. So there are multiple ways you can launch containers through Management Console and also programmatically. And ECS also helps to migrate application to the cloud without changing the code. So anytime you think of migration, the first thing that comes to your mind is that how will that environment be? Based on that, I'll have to alter my code. What's the IP? What is the storage that's being used? What are the different parameters I'll have to include? The environment parameters of the new environment. With containers, now that worry is already taken away, because we can create an pretty exact environment. The one that you had on premises, the same environment gets created in the cloud. So no worries about changing the application parameter, no worries about changing the code in the application. Right? You can be like, if it ran in my laptop, a container that I was running in my laptop, it's definitely going to run in the cloud as well, because I'm going to use the same container in the laptop and also in the cloud. In fact, you're going to ship it. You're going to move the container from your laptop to Amazon ECS and make it run there. So it's like the very same image, the very same container that was running in your laptop will be running in the cloud or production environment. So what is Docker? We know that ECS helps to quickly launch, exit, and manage Docker containers. What is Docker? Let's answer that question. What is Docker? Now, Docker is a tool that helps to automate the development of an application as a lightweight container so that the application can work efficiently in different environments. This is pretty much what we discussed right before the slide. I can build an application in my laptop or in on-premises in a container environment, Docker container environment, and anytime I want to migrate, right, I don't have to kind of rewrite the code and then rerun the code in that new environment. I can simply create an image, a Docker image, and move that image to that production or the new cloud environment and simply launch it there, right? So no compiling again, no relaunching the application. Simply pack all your code in a Docker container image and ship it to the new environment and launch the container there. That's all. So Docker container is a lightweight package of software that contains all the dependencies. So because, when packing, you'll be packing all the dependencies, you'll be packing the code, you'll be packing the framework, you'll be packing the libraries that are required to run the application. So in the new environment, you can be pretty sure, you can be guaranteed that it's going to run because it's the very same code, it's the very same framework, it's the very same libraries that you have shipped, right? There's nothing new in that new environment. It's the very same thing that's going to run in that container. So you can be rest assured that they are going to run in that new environment. And these Docker containers are highly scalable and they are very efficient. Suddenly you wanted like 20 more Docker containers to run the application. Think of adding 20 more hosts, 20 more VMs, right? How much time would it take? And compared to that time, the amount of time that Docker containers would require to kind of scale to that amount, like 20 more containers, it's very less, or it's minimal or negligible. So it's a highly scalable and it's a very efficient service. You can suddenly scale number of Docker containers to meet any additional demand. Very short boot up time because it takes it's not going to load the whole operating system. And these Docker containers, they use the Linux kernel and features of the kernel like C groups and namespaces to kind of segregate the processors so they can run independently any environment, and it takes very less time to boot up. And the data that are stored in the containers are kind of reusable. So you can have an external data volume and I can map it to the container, and whatever the space that's occupied by the container and the data that the container puts in that volume, they are kind of reusable. You can simply remap it to another application. You can kind of remap it to the next successive container. You can kind of remap it to the next version of the container, next version of the application you'll be launching, and you don't have to go through building the data again from the scratch. Whatever data the container was using previously or the previous container was using, that data is available for the next container as well. So the volumes that the containers uses are very reusable volumes. And like I said, it's isolated application, so it kind of isolates by its nature. It kind of, by the way it's designed, by the way it is created, it isolates one container from another container, meaning anytime you run applications on different containers, you can be rest assured that they are very much isolated. Though they are running on the same host, though they are running on the same laptop, let's say, though they are running on the same physical machine, let's say, running 10 containers, 10 different applications, you can be sure that they are well disconnected or well isolated applications. Now let's talk about the advantages of ECS. The advantage of ECS is improved security. Security is inbuilt in ECS. With ECS, we have something called as a container registry. That's where all your images are stored, and those images are accessed only through HTTPS. Not only that, those images are actually encrypted, and access to those images are allowed and denied through identity and access management policies, IAM. And in other words, let's say two containers running on the same instance. Now one container can have access to S3 and the others, or the rest of the others, are denied access to S3. So that kind of granular security can be achieved through containers when we mix and match the other security products available in Amazon, like IAM, encryption, accessing it using HTTPS. These containers are very cost efficient. Like I've already said, these are lightweight processes, right? We can schedule multiple containers on the same node, and this actually allows us to achieve high density on an EC2 instance. Imagine an EC2 instance that's very less utilized. That's not possible with a container, because you can actually dense or crowd an EC2 instance with more container in it, so to best use those resources. In EC2, straightforward, you can just launch one application. But when we use containers, you can launch like 10 different applications on the same EC2 server. That means 10 different applications can actually feed on those resources available and can benefit the application. And ECS not only deploys the container, it also maintains the state of the containers, and it makes sure that the minimum set of containers are always running based on the requirement. That's another cost efficient way of using it, right? And anytime an application fails, and that has a direct impact on the revenue of the company, and ECS makes sure that you're not losing any revenue because your application has failed. And ECS is a pretty extensible services. It's like this: in many organizations, there are majority of unplanned work because of environment variation. A lot of firefighting happens when we kind of deploy the code from one, or kind of move the code or redeploy the code in a new environment. A lot of firefighting happens there. Right. This Docker containers are pretty extensible. Like we discussed already, environment is not a concern for containers because it's going to kind of shut itself inside a Docker container, and anywhere the Docker container can run, the application will run exactly the way it performed in the past. So environment is not a concern for the Docker containers. In addition to that, ECS is easily scalable. We have discussed this already. And it has improved compatibility. We have discussed this already. Let's talk about the architecture of ECS. Like you know now, the architecture of ECS is the ECS cluster itself. That's group of servers running the ECS service, and it integrates with Docker, right? So we have a Docker registry. Docker registry is a repository where we store all the Docker images or the container images. So it's like three components. ECS is of three components. One is the ECS cluster itself. Right? When I say ECS itself, I'm referring to ECS cluster of servers that will run the containers. And then the repository where the images will be stored, right? The repository where the images will be stored, and the image itself. So container image is the template of instructions which is used to create a container, right? So it's like, what's the OS? What is the version of node that should be running? And any additional software do we need? So those questions gets answered here. So it's the template of instructions which is used to create the containers. And then the registry is the service where the Docker images are stored and shared. So many people can store there, and many people can access, or if there's another group that wants to access, they can access the image from there, or one person can store the image and the rest of the team can access, and the rest of the team can store image, and this one person can pick the image from there and kind of ship it to the customer or ship it to the production environment. All that's possible in this container registry. And Amazon's version of the container registry is ECR. And there's a third party. Docker itself has a container registry, that's Docker Hub. ECS itself, which is the group of servers that runs those containers. So these two, the container image and the container registry, they kind of handle Docker in an image format, just an image format. And in ECS is where the container gets live, and then it becomes an compute resource and starts to handle requests, starts to serve the page and starts to do the batch job, whatever your plan is with that container. So the cluster of servers, ECS, integrates well with the familiar services like VPC. VPC is known for securing. VPC is known for isolating the whole environment from rest of the customers, or isolating the whole environment or the whole infrastructure from the rest of the clients in your account, or from the rest of the applications in your account, on and on. So VPC is a service that provides or gives you the network isolation. ECS integrates well with VPC. And this VPC enables us to launch AWS resources such as Amazon EC2 instance in a virtual private network that we specify. This is basically what we just discussed. Now let's take a closer look at the ECS. How does ECS work? Let's find answer for this question. How does ECS work? ECS has got a couple of components within itself. So these ECS servers can run across availability zone. As you can see, there are two availability zones here. They can actually run across availability zones. And ECS has got two modes, Fargate mode and the EC2 mode. Right here we're seeing Fargate mode, and then here we're seeing nothing. That means it's an EC2 mode. And then it has got different network interfaces attached to it, because they need to be running in an isolated fashion, right? So anytime you want network isolation, you need separate IP, and if you want separate IP, you need separate network interface card, and that's what you have, elastic network interface card, separate elastic network interface card for all those tasks and services. And this runs within an VPC. Let's talk about the Fargate service. Tasks are launched using the Fargate service. So we will discuss about tasks. What is Fargate? Now, Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the cluster. ECS is a service that manages the containers for you, right? Otherwise, managing containers will be a full-time job. So ECS manages it for you, and you get to manage ECS. That's the basic service. But if you want Amazon to manage ECS and the containers for you, we can go for Fargate. So Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the ECS cluster. And the tasks that we discussed, the tasks has two components. You see task right here. So they have two components. We have ECS container instance and then the container agent. So like you might have guessed right now, ECS container instance is actually an EC2 instance, right, capable of running containers. Not all EC2 instances can run containers. So these are like specific EC2 instances that can run containers. They are ECS container instances. And then we have container agent, which is the agent that actually binds those clusters together, and it does a lot of other housekeeping work, right? Kind of connects clusters, makes sure that the version needed is present. So it's all part of that agent, or it's all job of that agent. Container instances is part of Amazon EC2 instance, which run Amazon ECS container agent. Pretty straightforward definition. And then a container agent is responsible for communication between ECS and the instance, and it also provides the status of the running containers. Kind of monitors the container, monitors the state of the container, make sure that the container is up and running, and if there's anything wrong, it kind of reports it to the appropriate service to fix the container, on and on. But it's a container agent. When we don't manage container agent, it runs by itself, and you really don't have to do anything to make the container agent better. It's already better. You really won't be configuring anything in the agent. And then Elastic Network Interface Card is a virtual interface network that can be connected to an instance in VPC. So in other words, Elastic Network Interface is how the container interacts with another container, and that's how the container interacts with the EC2 host, and that's how the container interacts with the internet, external world. And a cluster is a set of ECS container instances. It's not something that's very difficult to understand. It's simply a group of EC2 instances that runs that ECS agent. And this cluster handles the process of scheduling, monitoring, and scaling the request. We know that ECS can scale, the containers can scale. How does it scale? That's all monitored and managed by this ECS cluster. Let's talk about the companies that are using Amazon ECS. There are a variety of companies that use ECS clusters. To name a few, Okta uses ECS cluster, and Okta is a product that uses identity information to grant people access to applications on multiple devices at any given point of time. They make sure that they have a very strong security protection. So Okta uses Amazon ECS to run their Okta application and serve their customers. And Abima is a TV channel, and they chose to use microservices and Docker containers. They already had microservices and Docker containers, and when they thought about a service that they can use in AWS ECS was the only service that they can immediately adapt to. And because in Abima TV the engineers have already been using Docker and Docker containers, it was kind of easy for them to adapt themselves to ECS and start using it along with the benefits that ECS provides. Previously they had to do a lot of work, but now ECS does it for them. Right. Similarly, Remain and Ubisoft, GoPro are some of the famous companies that use Amazon ECS and get benefited from its scalability, get benefited from its cost, gets benefited from its Amazon managed services, get benefited from the portability that ECS and the migration option that ECS provides. Let's talk about how to deploy a Docker container on Amazon ECS. The way to deploy a Docker container on ECS is first we need to have an AWS account and then set up and run our first ECS cluster. So in our lab we're going to use the launch wizard to run an ECS cluster and run containers in them. And then task definition. Task definition tells the size of the container, the number of the container. And when we talk about size, it tells how much of CPU do you need, how much of memory do you need. And talking about numbers, it requires how many numbers of container you're going to launch. Is it 5, is it 10, or is it just 1 running all the time? Now those kind of information goes in the task definition file. And then we can do some advanced configuration on ECS, like load balancers and what port number you want to allow and you don't want to allow, who gets access, who shouldn't get access, and what's the IP that you want to allow and deny requests from, on and on. And this is where we would also mention the name of the container, so to differentiate one container from the other, and the name of the service. Is it an backup job? Is it a web application? Is it a data container? Is it going to take care of your data backend? And the desired number of tasks that you want to be running all the time. Those details go in when we try to configure the ECS service, right? And then you configure cluster. You put in all the security in the configure your cluster step or configure cluster stage. And finally, we will have an instance and bunch of containers running in that instance. All right, let's do a demo. So here I have logged in to my Amazon portal, and let me switch to the appropriate region. I'm going to pick North Virginia. North Virginia, look for ECS. And it tells ECS is a service that helps to run and manage Docker containers. Well and good. Click on it. I'm in North Virginia. Just want to make sure that I'm in the right region. And go to clusters. And here we can create cluster. This is our Fargate, and this is our EC2 type launching for Linux and Windows environment. But I'm going to launch through this walkthrough portal. Right? This gives a lot of information here. So the different steps involved here is creating a container definition, which is what we're going to do right now, and then a task definition, and then service, and finally the cluster. It's a 4-step process. So in container definition, we define the image, the base image we are going to use. Now here I'm going to launch an HTTPD or a simple HTTP web page, right? So a simple HTTPD 2.4 image is fair enough for me. And it's not a heavy application, so 0.5 gigabit of memory is enough. And again, it's not a heavy application, so 0.25 virtual CPU is enough in our case, right? You can edit it based on the requirement. You can always edit it. And because I'm using HTTPD, the port mapping is already port 80. That's how the container is going to receive the request. And there's no health check as of now. When we want to design critical and complicated environments, we can include health check, right? And this is the CPU that we have chosen. We can edit it. And I'm going to use some bash commands to create an HTML page, right? This page says that, Amazon ECS sample app, right? And then it says Amazon ECS sample app. Your application is running on a container in Amazon ECS. So that's the page, the HTML page that I'm going to create, right? Index.html. So I'm going to create and put it in an appropriate location so those pages can be served from the container, right? If you replace this with any of your own content, then it's going to be your own content. ECS comes with some basic logs, and these are the places where they get stored. That's not the focus as of now. Right, so I was just saying that you can edit it and customize it to your needs. We're not going to do any customization now. We're just getting familiar with ECS now. And the task definition, name of the task definition is first run task definition, and then we are running it in a VPC. And then this is an Fargate mode, meaning the servers are completely handled by Amazon, and the task memory is 0.5 gigabit, and the task CPU is 0.25 virtual CPU. Name of the service: is it a batch job? Is it an a front end? Is it a back end? Or is it a simple copy job? What's the service? Name of the service goes here. Again, this you can edit it. And here's our security group. As of now, I'm allowing port 80 to the whole world. If I want to restrict to a certain IP, I can do that. The default option for load balancing is no load balancer, but I can also choose to have a load balancer and use port 80 to map that port 80 to the container port 80, right? I can do that. The default is no load balancer. All right, let's do one thing. Let's use load balancer. Let's use load balancer and port 80 that receives information on port 80, HTTP. What's going to be the cluster name? We're in the last step. What is the cluster name? Cluster name can be Simplilearn ECS demo. Next, we're done and we can create. So it's launching a cluster, as you can see, and it's picking the task definition file that we've created, and it's using that to launch an service. And then these are the log groups that we discussed, and it's creating a VPC. Remember, ECS clubs well with the VPC. It's creating a VPC, and it's creating two subnets here for high availability. It's creating that security group, port 80, allowed to the whole world, and then it's putting it behind an load balancer. It generally would take like 5 to 10 minutes, so we just need to be patient and let it complete its creation. And once this is complete, we can simply access these servers using the load balancer URL. And when this is running, let me actually take you to the other products or the other services that are integrated with ECS. It's getting created. Our service is getting created as of now. ECR repository. This is where all our images are stored. Now, as of now, I'm not pulling my image from ECR. I'm pulling it directly from the internet, Docker Hub. But all custom images, they are stored in this repository. So you can create a repository, call it app1, create a repository. So here's my repository. So any image that I create locally, or any Docker image that I create locally, I can actually push those images using these commands right here, and they get stored here. And I can make my ECS connect with ECR and pull images from here. So they would be my custom images. And as of now, because I'm using a default image, it's directly pulling it from the internet. Let's go to EC2 and look for a load balancer, because we wanted to access the application from behind a load balancer, right? So here is a load balancer created for us, and anytime I put the URL, so a cluster is now created. You see there's one service running. All right, let's click on that cluster. Here is the name of our application, and here is the tasks, the different containers that we are running. And if you click on it, we have an IP, right? IP of that container, right? And it says it's running, it was created at such and such time and started at such and such time. And this is the task definition file that this container uses, meaning the template, the details, all the version details, they all come from here, and it belongs to the cluster called Simplilearn ECS demo, right? And you can also get some logs, container logs from here. So let's go back. And there are no ECS instances here, because remember, this is Fargate. You're not managing any ECS instance, right? So that's why you're not seeing any ECS instance here. So let's go back to tasks and go back to the same page where we found the IP. Pick that IP, put it in the browser, and you have this sample HTML page running from an container. So let me go back to load balancer, EC2, and then under EC2 I'll be able to find a load balancer, find that load balancer, pick that DNS name, put it in the browser. And now it's accessible through the load balancer URL. Right now, this URL can be mapped to other services like DNS. This URL can be embedded in any of your application if you want to make that application connect with this container. Now, using IP is not all that advisable because these containers can die and then a new container gets created, and when a new container gets created, it gets a new IP, right? So hard-coding IP is not, hard-coding dynamic IPs are not advisable. So you would be using load balancer and putting that URL in that application that you want to make it interact with this container instance. It was a wonderful experience in walking you through this ECS topic, and in here we learned about what AWS is and why we're using ECS and what is ECS in general, what is Docker in specific, and we also learned about the advantages of ECS, the architecture, the different components of ECS, and how ECS works when they're all connected together. And we also looked at the companies that use ECS and their use cases, and finally a lab, how we can launch ECS Fargate through the portal. I'm very glad to walk you through this lesson about Route 53. So in this section, we are going to talk about basics of AWS, and then we're going to immediately dive into why we need Amazon Route 53. And then we're going to expand and talk about the details of Amazon Route 53, the benefits it provides over its competitors, and the different types of routing policy it has, and some of Amazon Route 53's key features. And we're going to talk about how to access Route 53, the different ways, the different methods you can access Route 53. And finally, we're going to end with a wonderful demo in Route 53. So let's talk about what is AWS. Amazon Web Services, or AWS in short, is a cloud provider that offers a variety of services such as a variety of IT services or infrastructure services such as compute power, database, content delivery, and other resources that helps us to scale and grow our business. And AWS is hot, AWS is picking up, AWS is being adapted by a lot of customers. That's because AWS is easy to use even for a beginner. And talking about safety, the AWS infrastructure is designed to keep the data safe irrespective of the size of the data. Be it small data, be it very minimal data, be it all the data that you have in terabytes and in petabytes, Amazon can keep it safe in their environment. And the wonderful thing and the most important reason why a lot of customers move into the cloud is that the pay-as-you-go pricing. There is no long-term commitment and it's very cost effective. What this means is that you're not paying for a resource that you're not using. In on-premises, you do pay for resources you're not using a lot, meaning you go and buy a server, you do the estimate for the next 5 years, and only after like 3 or 4 years you'll be hitting the peak capacity, but still you would be buying that capacity before 4 years, right? And then you will gradually be, utilizing it from 40%, 60%, 70, 80, and then 100. So what you have done is that even though you're not using the full capacity, you still have bought it and are paying for it from day one. But in the cloud, it's not like that. You only pay for the resources that you use. Anytime you want more, you scale up the resource and you pay for the scaled up resource. And anytime you want less, you scale down the resource and you pay less for that scaled down resource. Let's talk about why Amazon Route 53. Let's take this scenario where Rachel is trying to open her web browser and the URL that she hit isn't working. A lot of reasons behind why the URL isn't working. It could be the server utilization that went high. It could be the usage that went high. A lot of reasons. And she starts to think, is there an efficient way to scale resources according to the user requirements? Or is there an efficient way to kind of mask all those failures and kind of divert the traffic to the appropriate active resource or active service that's running our application. You always want to hide the failures, right? In IT, kind of mask the failure and direct the customer to another healthy service that's running, right? None of your customers would want to see a server not available, or none of your customers would want to see your service not working. Not impressive to them. And this is Tom. Tom is an IT guy, and he comes up with an idea, and he's answering Rachel, yes, we can scale resources efficiently using Amazon Route 53. In a sense, he's saying that yes, we can mask the failure and we can keep the services up and running, meaning we can provide more high availability to our customers with the use of Route 53. And then he goes on and explains Amazon Route 53 is a DNS service that gives developers an efficient way to connect users to internet applications without any downtime. Now, downtime is the key. Amazon Route 53 helps us to avoid any downtime that customers would experience. You still will have downtime in your server, in your application, but your customers will not be made aware of it. And then Rachel is kind of interested and she's like, yeah, that sounds interesting. I want to learn more about it. And Tom goes on and explains the important concepts of Amazon Route 53. That's everything that I'm going to explain it to you as well. All right, so what is Amazon Route 53? Amazon Route 53 is a highly scalable DNS or domain name system web service. This service, this Amazon Route 53, it functions three main things, or it has three main functions. So the first thing is, if a website needs a name, Route 53 registers the name for the website domain. Let's say you want to buy google.com. You want to buy the domain name. Let's say you want to buy that domain name. You buy that through Route 53. Secondly, Route 53 is the service that actually connects your server, which is running your application, or which is serving your web page. So that's the service that actually, Route 53 is the service that connects the user to your server when they hit google.com in the browser, or whatever domain name that you have purchased. So you bought a domain name and the user types in your domain name.com, and then Route 53 is a service that helps the user to connect their browser to the application that's running in an EC2 instance or any other server that you are using to serve that content. Now, not only that, Route 53 checks health of the resource by sending automated requests over the internet to a resource. So that's how it identifies if there is any resource that has failed. When I say resource, I'm referring to any infrastructure failure, any application level failure. So it kind of keeps checking. So it understands it first before the customer notices it, and then it does the magic, kind of shifts the connection from one server to the other server. We call it routing. We will talk about that as we progress. So the benefits of using Route 53. It's highly scalable, meaning suddenly, let's say, the number of requests, the number of people trying to access your website through that domain name that you have bought, let's say it has increased. Route 53 is highly scalable, right? It can handle even millions and millions of requests because it's highly scalable and it's managed by Amazon. The same thing, it's reliable, it's highly scalable, it can handle large queries without you interacting, without the user who bought it interact with it. You don't have to scale up. When you're expecting more requests, it automatically scales. And it is very reliable in a sense that it's very consistent. It has the ability to route the users to the appropriate application through the logic that it has. It's very easy to use. When we do the lab, you're going to see that. It's very easy to use. You buy the domain name and then you simply map it to the application. You simply map it to the server by putting in the IP, or if you can simply map it to another load balancer by putting in the load balancer URL. You can simply map it to another S3 bucket by simply putting the S3 bucket name or the S3 bucket URL. It's pretty straightforward, easy to set up. And it's very cost effective in a way that we only pay for the service that we have used. So no wastage of money here. So the billing is set up in such a way that you are paying only for the amount of requests that you have received, right? The amount of traffic, the amount of requests that you have received. and a couple of other things. The number of hosted zones that you have created, right? And a couple of other things. It's very cost effective in such a way that you only pay for the service that you are using. And it's secure in a way that access to Route 53 is integrated with the Identity and Access Management, IAM. So you only have authorized users gain access to Route 53. The trainee who just joined yesterday won't get access. And the contractor or the consultant, the third-party consultant you have given access or who is using your environment, you can block access to that particular person because he's not the admin or he's not a privileged user in your account. So only privileged users and admin gain access to Route 53 through IAM. Now let's talk about the routing policies. So when you create a record in Route 53, record is nothing but an entry. So when you do that, you choose a routing policy. Right? Routing policy is nothing but it determines how Route 53 responds to your queries, how the DNS queries are being responded. Right? That's a record, or that's a routing policy. So the first one is a simple routing policy. So we use simple routing policy for a single resource. In other words, simple routing allows to configure DNS with no special Route 53 routing. It's kind of one-to-one. You use a single resource that performs a given function to your domain. For example, if you want to simply map an URL to a web server, that's pretty straightforward, simple routing. So it routes traffic to a single resource, example, web server to a website. And with simple routing, multiple records with the same name cannot be created, but multiple values can be created in the same record. The second type of routing policy is failover routing. So we would be using failover routing when we want to configure active, passive failover. If something failed, right, you want to fail over to the next resource, which was previously the backup resource, now the active resource, or which was previously the backup server, now it's an active server. So you would be failing over to that particular resource or that particular IP. If you want to do that, we use failover routing. So failover routing routes traffic to a resource when the resource is healthy, or to a different resource when the previous resource is unhealthy. In other words, anytime a resource goes unhealthy, it does all that's needed to shift the traffic from the primary resource to the secondary resource. In other words, from the unhealthy resource to the healthy resource. And this records can route traffic to anything from an Amazon S3 bucket, or you can also configure a complex tree of records. Now, when we configure the records, it will be more clear to you. So as of now, just understand that Route 53 can route, or this routing policy, the failover routing policy, can route traffic to Amazon S3 bucket or to a website that has complex tree of records. Geolocation routing policy. Now, geolocation routing, just like the name says, it takes that routing decision based on the geographic location of the user. In other words, when you want to route traffic based on the location of the user, that's your primary criteria for sending that request to the appropriate server, we would be using geolocation routing. So it localizes the content and presents a part or the entire website in the language of the user. For example, a user from US, you would want to direct them to an English website, and a user from German, if you want to send them to the German website, and a user from France, you want to send those requests, or you want to show content specific to a customer who lives in France, a French website. So this is, if that's your condition, this is the routing policy we would be using. And the geographic locations are specified by either continent or by country or by state in the United States. So only in the United States you can actually split it to state level, and for the rest of the countries you can do it on a country level. On a high level you can also do it on a continent level. The next type of routing policy would be geo-proximity routing. Geo-proximity routing policy, when we want to route traffic based on the location of our resource and optimally shift traffic from resources in one location to resource in another location, we would be using geo-proximity routing. So geo-proximity routing routes traffic to the resources based on the geographic location of the user and the resources they want to access. And it also has an option to route more traffic or less to a given resource by specifying a value known as a bias. Kind of weight, but we also have weighted routing that's different. So we've chosen different name, bias. You can send more traffic to a particular resource by having a bias on that particular routing condition. And a bias expands or shrinks the size of the geographic region from which traffic is routed to a resource. And then we have latency based routing. Just like the name says, we use latency based routing if we have resources in multiple AWS regions and if you want to route traffic to the region that provides the best latency at any given point of time. So let's say if one single website needs to be installed and hosted on multiple AWS regions, then latency routing policy is what is being used. It improves the performance of the users by serving the request from the AWS region that provides the lowest latency. So at any given point, if performance is your criteria, and at any given point of time, irrespective of what happens in Amazon infrastructure, irrespective of what happens in the internet, if you want to route your users to the best performing website, best performing region, then we would be using latency based routing. And for using latency based routing, we should create latency records for the resources in multiple AWS regions. And then the other type of a routing policy is multi-value routing policy, where we can make Route 53 to respond to DNS queries with up to 8 healthy records selected at random. So you're not kind of loading one particular server. We can define 8 records, and on a random basis, Route 53 will respond to queries from these 8 records. So it's not one server that gets all the requests, but 8 servers gets the request in a random fashion. So it's multi-value routing policy, and what we get by this is that we are distributing the traffic to many servers instead of just one server. So multi-value routing configures Route 53 to return multiple values in response to a single or multiple DNS queries. It also checks the health of odd resources and returns the multiple values only for the healthy resources. Let's say out of the 8 servers we have defined, one server is not doing healthy. It will not respond to the query with the details of the unhealthy server, right? So now it's going to treat it as only 7 servers in the list because one server is unhealthy. And it has the ability to return multiple health checkable IP addresses to improve availability and load balancing. The other type of routing policy is weighted routing policy, and in here we use to route traffic, or this is used to route traffic to multiple resources in a proportion that we specify. So this is an weighted routing, and weighted routing routes multiple resources to a single domain name or a subdomain and control the traffic that's routed to each resources. So this is very useful when you're doing load balancing and testing new versions of the software. So when you have a new version of the software, you really don't want to send 100% of the traffic to it. So you want to get customers' feedback about the new software that you've launched, new version or new application that you've launched. So you would kind of send only 20% of the traffic to that application, get customer feedback, and if all is good, then we would move the rest of the traffic to that new application. So any software launches, application launches will be using weighted routing. Now let's talk about the key benefits or key features of Route 53. Some of the key features of Route 53 are traffic flow. It routes end users to the endpoint that should provide the best user experience. That's what we discussed in the routing policies, right? It uses a routing policy, a latency-based routing policy, and geo-based routing policy, and then failover routing policy. So it kind of improves the user experience. And the other key feature of Route 53 is we can buy domain names using Route 53 console. We can buy it from here and use it in Route 53. Previously it was not the case, but now we can buy it directly from Amazon through Route 53, and we can assign it to any resources that we want. So anybody browsing that URL, the connection will be directed to the server in AWS that runs our website. Health checks. It monitors health and performance of the application. So it comes with an health check attached to it. Health check are useful to make sure that the unhealthy resources are retired, right? The unhealthy resources are taken away, or your customers are not kind of hitting the unhealthy resources and they see an service down page or something like that. We can have weighted round robin load balancing. That's helpful in spreading traffic between several services or servers via a round robin algorithm. So no one server is fully hit, or no one server kind of fully absorbs all the traffic. You can shift, you can split and shift the traffic to different servers based on the weight that you would be configuring. And also weighted routing also helps with a soft launch of your new application or the new version of your website. There are different ways we can access Amazon Route 53. So you can access Amazon Route 53 through AWS console. You can also access Amazon Route 53 using AWS SDKs, and we can access it we can configure it using the APIs. And we can also do it through the command line interface. That's Linux type, Linux flavor, AWS command line interface. We can also do that using Windows command line, Windows PowerShell flavored command line interface as well. Now let's look at some of the companies that are using Route 53. So some of the famous companies that use Route 53 are Medium. Medium is an online publishing platform, and it's more like a social journalism. It's kind of having hybrid collection of professionals, people, and publications, or exclusive blogs or publishers on Medium. It's kind of an blog website, and that uses Route 53 for the DNS service. Reddit is an social news aggregation or web content rating and discussion website that uses Route 53. So these are some websites that are accessed throughout the world, and they are using Route 53, and it's highly scalable. Suddenly if there is a new news, right, their website will be accessed a lot, and they need to keep their service up and running all the time, more availability. Otherwise customers will end up in a broken page, and the number of customers who will be using the website will come down. So it's very critical. Now these sites, these companies are very critical, they're being highly available, their page, their site being highly available, and the internet is very critical and crucial for them, and they rely and use Route 53 to meet that particular demand. And Airbnb is another company, Instacart, Coursera is another company, Stripe is another company that uses Route 53 as their DNS provider for their DNS service. They use Route 53 so their customers get best performance. They use Route 53 so their website is highly available. They use Route 53 to kind of shift the traffic between the resources so their resources are properly used. With all the weighted routing, the resources are properly used. Now let's quickly look at a demo. I'm in my AWS console and I'm in Route 53. So let me click on Route 53. So in this lab, we're actually going to simulate buying a domain name, and then we're going to create an S3 static website, and we're going to map that website to this DNS name, right? So the procedure is the same for mapping load balancer. The procedure is the same for mapping CloudFront. The procedure is the same for mapping EC2 instances as well. We're picking S3 for simplicity, right? But our focus is actually on Route 53. So let's go in here and we'll see if we can, we'll buy a domain name here. So let's first check the availability of a domain name called Simplilearn-demo-Route 53. Let's check its availability. It is available for $12. So let me add it to cart and then come back here. And then once you continue, it'll ask for personal information. Once you give the personal information, you finally check out, and then it gets added to your shopping list. Once you pay for it, Amazon takes like 24 to 48 hours to make that DNS name available. So the next stage would be contact details, and then the third stage would be verify and purchase. So once we have bought the domain name, it will become available in our DNS portal, and I do have a domain name which I bought some time back, and it's now available for me to use. So I can go to hosted zone and simply start creating. I can go to hosted zone, and then here it's going to list all the domain names for me. Right, click on the domain name and then click on the record set, and here I can actually map Elastic Load Balancer, S3 website, VPC endpoint, API gateway, and CloudFront, Elastic Beanstalk domain names. Right, all that gets mapped through this portal. Quite simple, like 4 or 5 step button clicks, and then it'll be done. So I have an domain name bought, and then I'm going to go to S3, and I'll show you what I've done in S3. So I've created a bucket name called as DNS name. Let me clear the content in them. So I've created a bucket, and then permissions, I've turned off public access blocking, and then I've created a bucket policy. So this bucket is now publicly accessible. And then I went on to properties and created the static website hosting. Right? And I've pointed that this is the file, that's my index file that I'm going to put, or name of the file that's going to be my index file that I'm going to put in this S3 bucket. So I've put the index file.html, saved it, and we're going to create a file now. We're going to create an index file. So this is a sample code. It says Amazon Route 53 getting started, routing internet traffic to S3 bucket for your website, and then a couple of other information. So I've saved it as an index.html file in my desktop. So let me upload that from my desktop into this bucket. So that's index.html, and it's in capital I. So let me go to properties and go to static website hosting and make sure that I spell it properly. Right, it's case sensitive, and then save it. So now this means that my website should be running through this URL, and it does. It's running through the static website URL. We're halfway through. So now let me go back to Route 53. Go back to Route 53, go back to hosted zones, go into the domain name, and then create a record set. And it's going to be an alias record. And I see my S3 static website endpoint there. Right, so click on it and create. It has now created an record that's pointing my domain name to the S3 endpoint that I have created, and my static website is running from it. So let me test it. Right, so let me go to the browser, put the domain name in there, and sure enough, the domain name, when my browser queried for the domain name, Route 53 returned a response saying this domain name is actually mapped to the S3 bucket. Static website hosting enabled S3 bucket, and this is the URL for that static website hosting. And then my browser was able to connect to that S3 bucket and download the details and show it in my browser. Right, so it's that simple and pretty straightforward.
Today's session is on AWS Elastic Beanstalk. So what's in it for you today? We'll be discussing about what is AWS, why we require AWS Elastic Beanstalk, what is AWS Elastic Beanstalk, the advantages, disadvantages, the components of Beanstalk, along with that, the architecture and the companies that are primarily using the AWS Beanstalk. So let's get started and first understand what is AWS. AWS stands for Amazon Web Services. It's a cloud provider and that offers a variety of services such as compute power, database storage, content delivery, and many other resources. So we know that AWS is the largest cloud provider in the market, and so many services are available in the AWS where you can apply the business logics and create the solutions using the cloud platforms. Now, why AWS Elastic Beanstalk? Now, what happened earlier, and that whenever the developer used to create the software or the modules related to the softwares, it has to be joined together to create a big application. Now, one developer creates a module that has to be shared with another developer, and if the developers are geographically separated, then it has to be shared over a medium, probably an internet. So that is going to take some time. It would be a difficult process, and in return it makes the application or a software development a lengthier process, the building of the software development a lengthier process. So there were challenges which the developers were facing earlier, and to overcome that we have the Beanstalk as a service available in the AWS. So why AWS Elastic Beanstalk is required? AWS Elastic Beanstalk has made the life of the developers quite easy in terms of that they can share the applications across different devices at a shorter time duration. Now let's understand what is AWS Elastic Beanstalk. AWS Elastic Beanstalk is a service which is used to deploy and scale web applications by developers. Not only web application, any application that is being developed by the developers. This is a symbol representation of the AWS Elastic Beanstalk. Now, along with that, the AWS Elastic Beanstalk supports the programming language, the runtime environments that are Java, .NET, PHP, Node.js, Python, RubyGo, and Docker. And in case if you're looking for any other programming language or a runtime environment, then you can make a request with AWS to arrange that for you. Now, what are the advantages associated with the Elastic Beanstalk? First advantage is that it's a highly scalable service. Now, when we talk about the scalability, it means that whenever we require the resources in demand, we can scale up the resources or we can scale down the resources. So that is kind of a flexibility we get in terms of changing the type of resources whenever we need it. And in that case, the Elastic Beanstalk is a highly scalable service. Now that is something which is very difficult to achieve in case of an on-prem environments, because you have to plan for the infrastructure, and in case if you're short of the resources within that infrastructure, then you have to procure it again. The second advantage associated with the Beanstalk is that it's a fast and simple to begin. Now when we say it's fast and simple, that means that you just have to focus on the development of an application, building an application, and then you can just deploy the application directly using the Beanstalk. What the Beanstalk is going to do, that every networking aspect is being taken care by the Beanstalk. It deploys your application in the backend on the servers, and then you can directly access your application using the URL or through the IP address. The third advantage is that it offers the quick deployment. That is what we discussed in the fast and simple to begin as well. So why it offers a quick deployment? You don't have to bother about the networking concepts. You just have to focus on the application development, and then you can just upload your application, deploy that, and then you are good to go. The other advantage is that it supports multi-tenant architecture. When we talk about tenants or multi-tenants, that means we can have a virtual environments for separate organizations or the divisions within the organizations that will be virtually isolated. So likewise, you can have virtually isolated environments created on the Beanstalk, and they can be separated, used as a separate entities or a separate divisions within the organization. And we know that it's a flexible service. Since it's a scalable, then it is a flexible also. Now coming to the simplifies operations as an advantage. Now once the application is deployed using the Beanstalk, then it becomes very easy to maintain and support that application using the Beanstalk services itself. And the last advantage that we can have from the Beanstalk is that it's a cost efficient service. The cost efficient, as we know that many of the AWS services are cost effective. The cost optimization can be better managed using the AWS Beanstalk as compared to if you are developing or if you are deploying any kind of an application or a solution on the on-prem servers. Now there are some components that are associated with the AWS Beanstalk, and it has to be created in the form of a sequence manner. So AWS Elastic Beanstalk consists of few important components which are required while developing an application. Now what are these components? These are 4 components. One is application, the second is application version, the third is environment, and the fourth one is the environment tier. And we have to progress while deploying our applications or the softwares using the same sequence. Now let's understand what are the different components of the Beanstalk are. The application. It refers to a unique label which is used as a deployable code for a web application. So generally you deploy your web application or you create your application, and that is something which is basically used as a unique label. Then the second component is application versions. So it resembles a folder which stores a collection of components such as environments, versions, and environment configurations. So all these components are being stored using the application version. The third most important component is the environment. In the environment, only the current versions of the applications runs. Now remember that Elastic Beanstalk supports multiple versions as well. And using the environment, you can only run the current version of the application. For if you wanted to have another version of an application to be running, then you have to create another environment for that. Then comes the environment tier. And in the environment tier, it designates the type of application that the environment runs on. Now generally there are 2 types of environment tier. One is the web and the other one is the worker node, and that's something which we'll be discussing later as well. Now let's understand how does Elastic Beanstalk in AWS works. So first we have to create an application, and this is a task that would be done by the developers. And for that you can actually select any runtime environment or a programming language like Java, Docker, Ruby, Go, Perl, or Python as well. And once you select that environment, you can develop your application using that runtime environments. Now, after that, once the application is created, then you have to upload the version of an application on the AWS. And after that, once the version is uploaded, and then you have to launch your environment. So just have to click on the buttons. That's it. Nothing more you have to do. Once the environment is launched, then you can actually view that environment using a web URL or using the IP address. Now, what happens in that case is when you launch an environment in the backend, the Elastic Beanstalk automatically runs an EC2 instance. And using a metadata, the Beanstalk deploys your application within that EC2 instance. That is something which you can look into the EC2 dashboard as well. So you don't have to take care of the security groups, you don't have to take care of the IP addressing, and even you don't have to log in into the instance and deploy your application. It would be done automatically by the Beanstalk. It's just that you just have to monitor the environment, and the statistics will be available there itself in the Beanstalk dashboard. Otherwise, you can view those statistics in the CloudWatch logs as well. Now, in case if you wanted to update any kind of a version, then you just upload a new version and then just deploy that and then monitor your environment. So these are the essentials to create a local applications for any platform, whether it's a Node.js, Python, etc. These are the things that you have to actually take care, and this is the sequence you have to follow while creating an environment. So you can say that it's a 4 steps creation of or deployment of your application. That's it. Now, after users upload their versions, the configuration is automatically deployed with a load balancer. Yes, and with a load balancer, that means you can access the applications using the load balancer DNS also. And apart from load balancer, if you wanted to put any other feature that includes the auto scaling, for example, if you wanted to create your EC2 instances where the application will be deployed within the virtual private cloud or in a particular subnet within the VPC, all those features that are available, and you can select them using the Beanstalk itself. You don't have to move out to the VPC. You don't have to actually go to the EC2 dashboard and select all those separately. Everything would be available within the Beanstalk dashboard. So that's what it says in the presentation, that after creating an application, the deploy service can be specifically accessed using the URL. So once the environment is created, there will be a URL defined. Now you can put a URL name also. That is something which you wanted to put for your application. You can define that. You can check for the availability of that URL, and then you have to use that URL to access your application over the browser. Now, once it is done, then in the monitor environment, it says the environment is monitored, provided capacity provisioning, load balancing, auto scaling, and monitor features. All those features are available there itself in the Beanstalk. Now let's understand the architecture of AWS Elastic Beanstalk. Now there are 2 types of environments that you have to select. You can select. One is the web server environment and the other one is the worker environment. So based on the client requirement, Beanstalk gives you 2 different types of environment that you have to select. Generally, the web server environment is the front end facing. That means the clients would be accessing this environment directly using a URL. So mostly web applications are deployed using that environment. The worker environment is the backend applications or the micro apps, which are basically required to support the running of the web applications. Now it depends on the client requirement what kind of an environment you wanted to select. Now in the web server environment, it only handles the HTTP request from the clients. So that's why we use the web server environment mostly for the web applications or any application which works on the HTTPS requests. So it's not only the HTTP, you can use the HTTPS as well. The worker environment, it processes background tasks and minimizes the consumption of resources. So again, it is just like a kind of a microservice or an application services that are running in the backend to support the web server environment. Now coming to the understanding of the AWS Beanstalk. So this is how the architecture of the AWS Beanstalk is designed, and you can refer to that image also. Now in the web server environment, let's say if we select a web server environment, and it says that if the application receives client requests, the Amazon Route 53 sends these requests to the Elastic Load Balancer. Now obviously we discussed here that the web server environment is primarily an environment which receives the HTTP requests. It's a kind of a client facing environment. Now if the application receives a client request from the Amazon Route 53, this Route 53 is a service which is primarily used for DNS mapping. It's a global service and it may route, you can route the traffic from the Route 53, matching your domains towards the load balancer. And from the load balancer, you can point that traffic to the web server environment. Obviously, the web server environment is nothing. It's just the EC2 instances that would be running in the backend. Now, here in the diagram, you can see that there are two web server environments, and they are created in the auto scaling group. That means there is some kind of scaling options that are defined as well. And these instances are created in an availability zone, or they can be created in a different availability zone also for the redundancy as well. And these web application servers are further connected to your databases, which primarily will be in a different security groups. Probably it can be an RDS database also. So all these functionalities, all these features are basically available on the Elastic Beanstalk dashboard itself. Now what happens in that case is, if the application receives client requests, Amazon Route 53 send these requests to the load balancer. Later, the load balancer shares those requests among the EC2 instances. How does that happen? It happens using a predefined algorithm. The equal distribution of a load is distributed to both the EC2 instances, or n number of EC2 instances running in the availability zone. Now in the availability zones, every EC2 instance would have its own security group. They can have a common security group also. They can have their own security group as well. Now, after the security group, the load balancer is then connected to the Amazon EC2 instance, which are part of the auto scaling group. So that's something which we have discussed already. Now, this auto scaling group would be defined from the Beanstalk itself, and there will be some scaling options that will be created. It could be a possibility that it might be the minimum number of instances that would be running as of now, and based on the threshold defined, it may increase the number of EC2 instances, and the load balancer will keep on distributing the load to as many instances that will be created inside the availability zones. Obviously, there will be an internal health check that the load balancer will be first doing before distributing the real-time traffic to these instances created by the Beanstalk. Now what does auto scaling group does? It automatically starts the additional EC2 instance to accommodate increasing load on your application. That's something which we know that. And also it monitors and scales instances based on the workload as well. So depends on what kind of a scaling threshold you have defined in the auto scaling groups. And when the load of an application decreases, the EC2 instance will also be decreased. So whenever we talk about the auto scaling, generally it comes in our mind is that we scale up the resources. That means it increases the EC2 instances. In the auto scaling, you might have the scale down option also, scale down policy also created, in which if the load minimizes, it can terminate the additional EC2 instances as well. So that is something which will be automatically managed. All these features can be achievable using the Elastic Beanstalk, and with this feature accommodated, it gives you the better cost optimization in terms of managing your resources. Now it says that Elastic Beanstalk has a default security group, and the security group acts as a firewall for the instances. Now here in this diagram, it says about the security group auto scaling also. You might create it in a default VPC also. You might create it in your custom VPC also, where you can have the additional level of securities also created. You can have the NACLs, NACLs also defined here before the security groups. So that would give you the additional filtering option or the firewall option. Now it says that with these groups, with these security groups, it allows establishing security groups to the database server as well. So every database would also have its own security group, and the connection can be created between the web servers environment that is created by the Beanstalk to the database security groups as well. Now let's discuss about the worker environment. Now understanding the worker environment, what happens is that the client, the web server environment is the client facing. The client sends a request for an access to the web server, and in this diagram the web server further sends it to the SQS, which is a simple queue service, and the queue service sends it to the worker environment, and then whatever the worker environment is created for doing some kind of a processing or some kind of an application that is running in the backend, that environment initiates and then send back the results to this SQS and vice versa. So let's understand the architecture of a AWS Elastic Beanstalk with the worker environment. So when a worker environment here is launched, AWS Elastic Beanstalk installs a server on every EC2 instance. So that is in the case of a web server environment also. And later the server passes the request to the simple queue service. Now this service is an asynchronous service. Instead of a simple queue service, you can have other services also. It is not necessary that you need to have the SQS also. This is an example that we are discussing about. And the SQS shares those messages via a post request to the HTTP path over the worker environment. And there are many case studies also with respect to this kind of an environment that is being created, that is being done on many customers. And you can search for these kind of case studies available on the internet. Now the worker environment executes the task given by the SQS with the HTTP response after the operation is completed. Now here what happens is a quick recap. The client requests for an access of an application to a web server using an HTTP request. The web server passes that request to the queue service. The queue service shares the message with a worker. Probably a worker might be the manual worker, and generally it's an automated worker. So it would be shared via the worker environment only. And the worker sends back the response with the HTTP response back to the queue. That response can be viewed directly from the queue service by the client using the web server. So this is one of the examples. Likewise, as I said, that there can be many other examples also where you can have the worker environments defined. Now, what are the companies that are using the Elastic Beanstalk? These are few of the companies that are primarily using. One is Zillow, Jelly Button Games, then you have League of Women Voters, eBury. These are some of the few listed companies, and obviously you search on the AWS site and you'll find many more organizations that are using the Elastic Beanstalk primarily for deploying their applications. Now, the next thing is to go with the practicals, that how actually we use the Elastic Beanstalk. So let's look into the demo using the AWS Elastic Beanstalk. Now, first you have to log in into the AWS console, and I'm sure that you might be having the accounts created, or you can use the IAM credentials as well. And then you have to select the region also. Now I am in the North Virginia region. Likewise, you can select any of the regions that are listed here. Now click on the services and you have to search for the Elastic Beanstalk. You can find the Elastic Beanstalk under the compute section. So here itself, you'll find the Elastic Beanstalk as a service. Now open this service and there it will give you an option to create an environment. You have to specifically select an environment, probably a worker environment or a web service environment. So let's wait for the service to open. So we have the dashboard now available with us. This is how the Elastic Beanstalk looks, and this is the symbol representation of a beanstalk. Now what you have to do is we have to click on Get Started, and that will load, and you have to create a web app. So instead of creating a web app, what we'll do, we'll create a new application. So just click on Create a new application. Put an application name. Let's say we put something like XYZ. You can put any description to your application. Let's say it's a demo app, and click on Create. Now it says you have to select an environment. Now the environment, the application name XYZ is created. You just have to select an environment. So click on Create One now, and it is going to ask you that what kind of an environment tier you wanted to select. So as we discussed that there are two types of environments. One is the web server and the other one is the worker environment. Let's look into it, what is defined by the AWS. AWS says that it has two types of environment tiers to support different types of web applications. Web servers are standard applications that listen for and then process HTTP requests, typically over port number 80. Workers are specialized applications that have a background processing task that listens for message on an Amazon SQS queue. Workers application posts those messages to your application by using the HTTP response. So that's what we saw in the case of the Beanstalk slides also. Now the usability of a worker environment can be anything. Now we'll do a demo for creating a web server environment. So just click on Select, and we have the environment name created. Now we can define our own domain. It ends with the region.elasticbeanstalk.com. Let's say I look for a domain which is XYZ only. That's the environment name. Now I'll check for the availability whether that domain name is available with us or not. And it says we don't have that domain name. So probably I'll try to make it with some other name, and let's look for the availability. XYZ ABC, and it says yes, it is available. Now once I deploy my application, I would be able to access the application using this complete DNS. So you can put a description. It's a demo app that we are creating, and then you have to define a platform as well. Now these are the platforms that are supported by the AWS. Let's say I wanted to run a Node.js environment. So I'll just click on the Node.js platform. The application codes is something which is basically developed by the developers, and you can upload the application right now, or you can do that later as well once the environment is ready. Now either you can select to create an environment if you wanted to go with all the default settings. Otherwise, if you wanted to customize it more, you can click on Configure More Options. So let's click on Configure More Options. And here you would be able to define various different features like the type of an instance. For example, what kind of an EC2 instance or a server that should be running so that the Beanstalk can deploy your applications over it. If you wanted to modify, just click on a Modify button, and here you can modify your instances with respect to the storage as well. Now, apart from that, if you wanted to do some modification in the case of monitoring, in the case of databases, in the case of security, or in the case of a capacity, let's look into the capacity. So here you can actually do the modification. So in the capacity, you can select the instance type also. By default, it is t2.micro, but in case if your application requires a larger type of an instance, then you can actually go for the instance type as well. Similarly, you can define your AMI IDs also, because obviously for the application to run, you would require the operating system also. So you can select that particular AMI ID for your operating system as well. Let's cancel that. Likewise, you have many other features that you can actually define here from the dashboard, and you don't have to go to the EC2 dashboard to do the modifications. Now let's go and create an environment. Let's assume that we are going with the default configuration. So this is going to create our environment. The environment is being created, and you can get the environment and the logs defined in the dashboard itself. So you'll see that the Beanstalk environment is being initiated, the environment is being started, and in case if there would be any errors or if it is deployed correctly, you'll get all the logs here itself. Now the environments are basically color coded. So there are different color codings that are defined. If you get the environment in a green color, that means everything is good to go. So here you can see that it has created an elastic IP. It has checked the health of the environment. Now it has created the security groups, and that would be an auto security groups created by the Beanstalk. And the environment creation has been started. You can see that Elastic Beanstalk as Amazon S3 storage bucket for your environment data as well. This is the URL through which you will be accessing the environment, but right now we cannot do that since the environment is being created. Let's click on the application name, and here you can see that it is in a gray color. That means right now the build is being done. It is being created. Once it will be successfully created, it should change to the green color, and then we will be able to access our environment using the URL. Now, if I move to the EC2 instances and see in the EC2 dashboard, if I see whether the instance is being created by the Beanstalk or not. So let's see, and let's see what are the differences in terms of creating an instance manually and getting it created from the Beanstalk. So click on the EC2. Let's go to the old EC2 experience. That's what we are familiar with. And let's see what's there in the dashboard. So here you can see one running instance. Let's open that. And the XYZ environment, which was created from the Beanstalk, is being initiated. The instance is being initiated. And that is something which is being done by the Beanstalk itself. We have not gone to the dashboard and created it manually. Now, in the security groups, if you see that, here the AWS Beanstalk security groups are defined. It has the elastic IPs also defined. So everything is being created by the Beanstalk itself. Right. Now let's go back to the Beanstalk and let's look into the status of our environment, whether the color coding has been changed from gray to green or not. And here you can see the environment is successfully created, and we have that environment colored in green. We'll access the environment, and it says it's a web server environment. Its platform is Node.js running on 64-bit Amazon Linux AMI, and it says sample application. Health status is OK. Now the other thing is that if you do not want to use the web console, the management console, to access the Beanstalk, then the Beanstalk offers you the Elastic Beanstalk CLI as well. So you can install the command line interface, and then you have the command references, CLI command references, that you can actually play with and get your applications deployed using the Beanstalk itself. So this is one of the sample CLI commands that you can actually look into. Now let's look into the environment. Let's click on the environment and we'll be represented with the URL. It says health is OK. These are the logs that you have to follow in case if there are any issues. The platform is Node.js. That is what we selected. Now the next thing is you just have to upload and deploy your applications. So just click on upload and deploy. Select the version label or the name. Select file, and wherever your application is hosted at, just select that, upload it and deploy your application. You'll see that like your environment is created, similarly your application will be deployed automatically on the instance, and from this URL you will be able to view the output. It is as simple as just like you have to follow these 4 steps. Now let's see whether the Node.js environment is running on our instance before deploying an application. So we'll just click on this URL. Since the Beanstalk has already opened up the security groups on HTTP port 80 for all, we can actually view that output directly from the URL. So we have the Node.js running, that's visible here. And after that, you just have to upload and deploy your application. And then from that URL, you can get the output. Now, this URL, you can map it with the Route 53 service. So using the Route 53 DNS services, the domain names can be pointed to the Elastic Beanstalk URL. And from there, it can be pointed to the applications that are running on the EC2 instance. Whether you wanted to point it to the URL directly using the Beanstalk, you can do that. Otherwise, as we saw in the slides, you can use the Route 53, point it to the load balancer, and then point it to the instances directly also once it is created by the Beanstalk. So that was the demo, guys, with respect to the Beanstalk and how we can actually run the environments. Apart from that, the operational tasks like system operations, you can manage all these things from the environment dashboard itself. So you have the configurations, you have the logs, you can actually check the health status of your environment, you can do the monitoring, and you can actually get the alarms and the events here. So let's say if I wanted to see the logs, I can request for the logs here itself, and I'll be represented with the full log report, and I can now download that log file and I can view the logs. So it's in the, so we have this bundle logs in the zip file. All right, so if you want to see some kind of logs with respect to Elastic Beanstalk activity, it's in the form of a notepad, and here you can see what all configurations the Beanstalk has done on your environment, on your instance. Similarly, you can go for the health, monitoring, alarms, events, and all those things.
Hello folks, welcome to yet another exciting video from Simplilearn. Are you ready to unlock the doors to a thriving career in cloud computing? The job market for AWS is booming, and companies are on lookout for talented individuals like you. AWS holds a significant 32% share in cloud computing job listings, making it the go-to choice for many businesses. What makes AWS so appealing? Well, it's known for its cost-effectiveness, scalability, and rock-solid security features. However, to stand out and succeed in the job market, it's essential to be fully prepared to ace those interviews. In this video, we have compiled the top 20 AWS interview questions that will not only sharpen your knowledge, but also boost your confidence when facing those crucial interviews. As a bonus in this video, along with the top 20 frequently asked questions, we will also cover 5 questions based on case studies that you can definitely expect in your AWS interview. So the first question is, what is AWS and what are its key components? AWS, or Amazon Web Services, is a cloud computing platform offered by Amazon. It provides a wide range of services like computing power, storage options, and networking capabilities. Key components include EC2, Elastic Compute Cloud, for virtual servers, S3, or Simple Storage Service for scalable storage, RDS, Relational Database Service for managed databases, and IAM, Identity and Access Management for security. You can also imagine AWS like a huge toolbox which has everything you need to build and run your applications without worrying about the infrastructure. You have EC2, which is like the section for renting virtual computers, S3 for storing your files securely, RDS for managing databases, and IAM for controlling who can access what. Now, what is the difference between EC2 and S3? EC2 provides resizable compute capacity in the cloud, allowing you to run applications. S3, or Simple Storage Service, on the other hand, is storage for the internet. EC2 is like having a computer in the cloud, while S3 is more like having a hard drive in the cloud where you can store files. Think of EC2 as a rented computer in the cloud. You can install software, run applications, and do pretty much anything you would do on a regular computer. Now, S3, on the other hand, is more like a giant external hard drive. You can store all your files there, like images, videos, or backups, and access them from anywhere on the internet. Now, let's move on to the third question. Explain the concept of Elastic Load Balancing, or ELB. Now, ELB automatically distributes incoming application traffic across multiple targets, such as EC2 instances, containers, and IP addresses, to ensure no single resource is overwhelmed. ELB is like having a traffic manager for your website or application. It automatically spreads incoming visitors or requests across multiple servers so that no single server gets overwhelmed. It's like having a multiple cache registers open at a store during rush hour. Let's move on to the next question. What is auto-scaling in AWS? Auto-scaling automatically adjusts the number of EC2 instances in a group based on demand. It helps maintain application availability and allows you to only pay for the resources you actually need. So auto-scaling is like having a magical elastic band around your servers. When there's a sudden spike in traffic to your website or application, auto-scaling automatically adds more servers to handle the load. And when the traffic slows down, it removes those extra servers so you don't waste money on unused resources. Now, describe the difference between IAM users, groups, and roles. IAM users are individuals within your AWS account, while groups are collections of users. Roles are similar to users, but they are meant to be assumed by other AWS services or users for specific tasks. Okay, imagine you're the boss of your AWS account. IAM users are like your employees. They can log in and do stuff, but only what you allow them to. Groups are like teams of users with similar permissions, and roles are like special hats that users or even other services can wear to do specific tasks. Now, the sixth question is, what is Amazon RDS? Amazon RDS, or Relational Database Service, is a managed relational database service that makes it easier to set up, operate, and scale a relational database in the cloud. Amazon RDS is like having a personal database expert on the call. It takes care of all the basic details of setting up, operating, and scaling a relational database like MySQL or PostgreSQL, so you can focus on building your app instead of worrying about database management. Now, explain the difference between Amazon RDS and Amazon DynamoDB. RDS is for relational databases and SQL Server, while DynamoDB is a fully managed NoSQL database service provided by AWS. RDS is like a traditional database with tables, rows, and SQL queries, while DynamoDB is more like a super fast, super flexible storage system for all kinds of data, from simple text to complex JSON documents. It's like comparing a filing cabinet to a magic box that can hold anything you throw at it. Now, what is Amazon VPC? Amazon VPC, or Amazon Virtual Private Cloud, is like having your own private corner of the AWS cloud. It's a virtual network that you can set up and customize to keep your resources isolated and secure. Think of it as creating your own little neighborhood within the vast city of AWS. Now, what is the difference between public and private subnets in Amazon VPC? Imagine public subnets are houses with doors facing the street. They're directly accessible from the internet. Private subnets, on the other hand, are like houses with backyard entrances. They're shielded from direct internet access, making them perfect for storing sensitive data or running internal services. Moving on to the 10th question. How does CloudFront work and what are its benefits? CloudFront is like having a network of delivery trucks all around the world, ready to bring your content closer to your users. When someone requests a file from your website or application, CloudFront finds the nearest delivery truck or edge location and serves the file from there, reducing latency and speeding up the overall experience for your users. Now, what is the difference between Amazon S3 and EBS? Amazon S3 is a giant storage locker in the cloud where you can dump all your files and they'll be safe and accessible from anywhere. EBS, on the other hand, is more like renting a hard drive that you can attach to your virtual server. You can install your operating system and applications on it just like you would do on a regular computer. Now, the next question. Explain the difference between the stop and terminate actions in EC2. When you stop an EC2 instance, it's like putting your computer to sleep. All the data and settings are saved and you can start it back up later without losing anything. But when you terminate an instance, it's like shutting down your computer and throwing it away. You lose everything and you can't bring it back. Now, what is AWS Lambda and how does it work? AWS Lambda is like having a team of tiny workers waiting in the cloud to execute your code whenever you need them. You just upload your code to Lambda, define when you want it to run, and Lambda takes care of everything else. Scaling, monitoring, and billing you only for the compute time you actually use. So let's move on to the next question. How do you secure your data at rest in AWS? Think of securing your data at rest like locking it in a safe. AWS offers various encryption options to keep your data safe from prying eyes, whether it's stored in S3 buckets, databases like RDS, or even on your EBS volumes. You can use AWS managed encryption keys or bring your own keys for added security. Moving on, what is CloudFormation and how does it work? Cloud formation is like having a blueprint for your entire AWS infrastructure. Instead of manually setting up each resource, you define everything you need in a template file using simple JSON or YAML syntax. Then, with a single click, CloudFormation creates and configures all the resources for you, saving your time and ensuring consistency. Now the next question, explain the differences between Amazon S3, EBS and EFS. Amazon S3 is a versatile storage solution for the files of all types, accessible from anywhere. EBS or Elastic Block Store is more like a traditional hard drive attached to a single EC2 instance, perfect for storing data that requires low latency access. Now, EFS or Elastic File System, on the other hand, is like a shared network drive that multiple EC2 instances can access simultaneously, making it ideal for shared file storage across multiple instances. Now, what is Amazon SQS and how does it work? Amazon SQS or Amazon Simple Queue Service is like having a virtual queue for your messages in the cloud. When one part of your application sends a message, SQS holds onto it until another part of your application is ready to receive and process it. It helps decouple different components of your system, making them more resilient and scalable. Now the next question is, what is the difference between Amazon S3 and Glacier? Amazon S3 is like having a storage locker where you can quickly access your files whenever you need them. Glacier, on the other hand, is more like putting your files in cold storage. It's cheaper but slower to retrieve. It's perfect for data that you don't need to access frequently, but still want to keep for archival purposes. Now, what is AWS Elastic Beanstalk? You can relate AWS Elastic Beanstalk to a personal chef who takes care of all the cooking and serving while you focus on enjoying your meal. So it automates the deployment and management of your web applications, handling all the heavy lifting of provisioning servers, load balancing, and scaling. So you can just upload your code and let Elastic Beanstalk take care of the rest. Now coming to the last question on our list, how do you monitor AWS resources and services? Monitoring AWS resources can be explained as having a dashboard that shows you how your applications and services are performing in real time. AWS offers various monitoring tools like CloudWatch, which collects and tracks metrics, logs, and events from your resources, and AWS Trusted Advisor, which provides recommendations for optimizing your AWS environment based on best practices and cost efficiency. And that wraps up our rundown of the top 20 AWS interview questions. But wait, let's have a look at those 5 bonus questions now. Number 1, you're setting up a website for a small shop using AWS. How would you choose the right AWS tools to make sure the website stays fast and reliable, whether there are only a few visitors or a lot of people shopping at once during a big sale? Your second question, imagine you're like a tech detective investigating why your website's database is slow for a busy online shop. How would you use AWS tools to find out what's causing the problem and make the database super fast again? Number 3, as the hero for a startup, your mission is to control their AWS costs while still allowing them to grow. How would you do this, making sure they can expand without spending too much money or slowing down their operations? Now your fourth question, a non-profit organization needs help migrating their data to AWS. What steps would you take to ensure a smooth transition, considering their limited budget and technical expertise? And the last question you have, a startup wants to store their customer data securely on AWS. How would you recommend they do this, considering both cost and security? Try answering these questions in the comment section. Let's have a discussion there. Thank you for learning with us. If you found this course helpful, be sure to share it with others and subscribe for more courses on AWS and other important tech skills. Keep learning, keep growing, and we'll see you in the next course.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.
Hello everyone, welcome to our AWS Developer Associate course. This course is designed to help you master the skills needed to become an AWS Developer Associate. AWS or Amazon Web Services is one of the most popular cloud platforms in the world, and there's a huge demand for skilled developers who know how to use it. Whether you are just starting out or looking to improve your skills, this course will guide you step by step. We'll cover everything